Hi, and welcome to Introduction to Rigging in Maya, presented by Digital Tutors, an Autodesk authorized publisher. My name is Delano, and I'll be your instructor as we guide you through the process of rigging in Maya and learn how to utilize the powerful tools and features available. We'll learn a rigging workflow that allows us to work efficiently so we can spend less time troubleshooting and more time adding creativity. Rigging and character setup makes up a key area in a production pipeline, and for artists new to rigging and animation, it can be a bit difficult to grasp and completely understand. We'll overcome this together and learn a flexible approach to rigging while learning the essentials like understanding Maya's robust rigging tools, creating skeletons, working with deformers, parenting objects, inverse kinematics, choosing good naming conventions for our control objects, and ultimately learning how to develop an animator-friendly control for our characters and props. So without any further waiting, let's go ahead and get started by discussing the importance of establishing good naming conventions for our objects. In this scene, I've just set up a simple joint chain along with an IK handle that allows us to get some pretty cool functionality out of our limb objects. So that's very cool, and we're going to be getting into all of these fun topics. But for right now, our main focus is going to be on naming these objects. Now, there's a few reasons why we want to get into the habit of using good naming conventions. One, it allows us to stay organized within our scene. If we ever needed to go back and find certain objects, what we can do is just go based off of that naming convention that we have established and quickly find that object. So we're going to be getting into a naming convention that we can use that can really be beneficial. Okay, so that's one of the benefits. Another benefit is for when this scene is passed off to an animator, they can just simply select a control object and know exactly what that object is going to do for them without trying to guess from the name that may be kind of confusing what the object does. So we want to use some short, simple, descriptive names that are going to bring home the point of what the object in the scene does. So let's go ahead and get right into how we can apply this. So here we can, I'll just go ahead and select this root bone object, and it's the root because it's the primary bone for this chain. And again, we're going to be getting into this topic very shortly. So again, the main focus again is just naming these objects. But since I know that this object is a joint, and I know it's on the left side of the arm, okay, from the arm's direction, and I also know that it is where the shoulder rests, okay, and I know that there's just one of these objects in our scene, we kind of get an idea of a naming convention we can use for this object. So again, repeating that, we would start with an object type, okay, followed by the direction of the object, followed by what the object is or what it controls, followed by how many objects are in the scene. So let's go ahead and apply that naming convention. Okay, so I'll just show you one that I find works quite well for myself. So since this is a joint, we can just call it as follows: JT for joint, followed by an underscore, followed by L, since it's the left side, there's the direction, followed by another underscore, and then what this object controls, that's the shoulder, and we could abbreviate that. We can type in SHLD for shoulder, followed by 01 for how many of this object are in our scene. So once we hit enter, after we have typed that in, notice this is, yes, a very short name, but it is very descriptive. And this will also help us to avoid anything like overlapping names within our scene. Okay, so in this case, if the object was on the right side, we can label this L with an R. Okay. Also, we're going to be getting into other naming schemes we can use for different types of objects. So we'll get into that kind of fun stuff. But here's a name we can use for our shoulder object. So for our arm, for example, okay, just doing this again, we can call this JT underscore. Okay, so joint underscore L for the left side, followed by another underscore. And since this is the arm bone, you can just type in arm 01. Right to the point, short and descriptive. All right, wonderful. So for the elbow, we can go to that and just label it JT, followed by underscore L, underscore elbow 01. So again, the type of the object, the direction, what it controls, or what it's affiliated with, and also the how many of this object are in our scene. Okay, great. And this number at the end also helps for when importing objects. So let's say if we try to import this object and we had another object of a like name. Well, that next imported object would have a suffix of 02, telling us that, okay, that is the new object or the imported object that we've added. And this is actually the original. So you see the benefit there of utilizing this type of naming scheme. So for the hand, we can label this JT underscore L underscore hand 01. And for the end bone, we can use JT underscore L, okay, again left direction, underscore hand, and since it's at the end, we can put a suffix of end 01. Okay, simple as that. Alright, great. And then how about for the IK handle here, where we're going to, again, be getting into what type of IK handle this is and the benefits of it. But for right now, I'll just tell you it's a rotate plane solver. So for this, since I know that this is an IK handle, I can see from its display, I can simply use RP, okay, IK for rotate plane IK solver, followed by underscore L for the left direction, followed by another underscore and what it controls. So in this case, it controls the arm. Okay, 01. So here we see a really nice naming scheme for this. Now let's say if we ever needed to get in our scene and select each bone on this joint chain, okay, or even just specific objects that are a part of this chain, okay, or part of this region. Well, with the naming scheme that we've used, okay, and I'll just use the bones for a demonstration here, since we know, alright, I just want to select the bones on the left side. So since we know that we've used JT for joint followed by an underscore and L, what we can do in Maya is actually use a wildcard to select each object within the scene. So let's go ahead and explore that, okay, again to see another benefit of utilizing a good naming scheme. So what we can do is just go right up to the top where we see our status line, where we see our filters and snap tools and such. What we'll do is go to this divider here, right where our snap tools are, and just left mouse button click to select and close that. And we'll do the same thing for our selected objects input output nodes. We'll just close that out, as well as for our rendering. We'll select that to close it. And here we get to our input box, which shows us things like our transforms. We can type those in for selected objects or rename objects. But what we want to get to, if we go ahead and left click the drop arrow, is get to right here at the bottom where it says select by name. So make sure that's selected. The left mouse button, just holding that and select. Now we can go ahead and type in the name of the object. So if we wanted to find, let's say, our arm bone, we know that it's called JT underscore L underscore arm 01. Hit enter. And notice once we do that, we have found that bone. Okay, so if we had a clutter of bones within our scene and we wanted to find this would be a great way to do that. But we need a solid naming convention so we know exactly where to find it or how to. So let's say if I wanted to now select all of the joints in this chain. Well, one way we could do that is to type in JT followed by underscore L, okay, followed by an asterisk. So let's go ahead and put that in. What the asterisk does, that basically allows us to have a wildcard. So what Maya will do is look for everything with this prefix or suffix before or after the asterisk. And when we hit enter, notice what happens. Now we have gone ahead and selected all of the objects with that prefix. And we can see kind of from our channel box that has happened because we see that we not only see our object name, but we do see the etc. symbol telling us that there's more to this than meets the eye in our selection. So if we were to go to our outliner, or what is our scene summary, which we'll also be exploring very shortly, if we go to window, we go to the outliner in Maya. Okay, here again we see our scene summary. We can go to this plus icon next to our selected joint, okay, and just left mouse button click to expand it. And notice as we do, okay, selecting on the gray items, meaning they're selected, as we do we can see that we have gone ahead and selected only all of the objects that had the prefix of JT underscore L. So again we see the benefit of using a solid naming scheme. Wonderful. Well, so that does complete this lesson. And in the next lesson, what we're going to be exploring is the simplest way, or one of the simplest ways, to rig an object. let's discuss one of the simplest ways to rig an object. Now, if you've ever seen a character setup or character rig within Maya, it may have seemed kind of intimidating. You have a lot of joints, have a lot of controls to control those joints, and also other nodes that control certain parts of the character. Well, a rig is not necessarily something that's complex. Those are called rigs. Those are what we would label rigs, but a rig can be as simple as having one object control another object. So the simplest way to set up a rig is actually parenting one object to another. What parenting does is basically takes an object and puts it underneath the other object in a hierarchical form, and we'll see how that is displayed within Maya. But let's say if we wanted to have object B here be controlled by object A, so that object A would be its parent. What we do is first select object B, which is called the child. So the first object we'd select when parenting would be our child bone, or excuse me, our child object. And if we wanted to now parent it to our object A, we'd simply shift and left mouse button and click on that object. So now, with that selected, which will be our parent, we simply hit P on our keyboard. When that happens, notice, alright, nothing much seemed to have happened. Everything looks the same. If I go ahead and select object B, go to the move tool, either hitting W on the keyboard or going there to the toolbar, we still have access to move B around. Okay, can rotate it, hitting E on the keyboard, go to the rotate tool. Okay, we'll do that just fine. We could even scale it if we like. But notice what happens when we select A. When we select that, now notice that B is also highlighted, and if we were to rotate A around, notice that B is following A precisely. Okay, so here we see or get an idea of what parenting does. It basically is self-explanatory. The parent will control the child's movement. Alright, so if we were to go to our move tool, go to the W key or just go to our toolbar, selecting that, and move that around, notice that B is also going to move around with A. Okay, if we move it around, and even if we scale, going to our scale tool or hitting R on the keyboard, notice, alright, we're able to control object B as we control object A. And you could get into some really fun things with parenting. Rather than setting up these basic parents, you could get into some really fun topics with it. But essentially, that's how it works. So let me go ahead and just bring everything back to its default quickly. I'll just, with object A selected, go to its translate to rotate attributes in the channel box and put in a value of 0. And then for the scale, put in a value of 1. Okay, and then for the B object, quickly do the same. Value of 0 for the rotate and translate attributes, just to bring them back. Alright, so that is how parenting works. So let's say if we wanted object C to be controlled by B. Well, again, we would select our child first, what we like to be our child object, followed by shift selecting what we like it to be its parent. Okay, so with that now selected, we can just hit P on our keyboard. So notice now if we go to B, it is going to control C. And if we select C, we still have access to move it around. Alright, wonderful. So I'm just going to go ahead and undo that back. Okay, so that is, again, the basic way of doing parents. And also, since B is a part of A, notice if we move A, that's going to move everything. So if we were to look at this in Maya's scene summary, we can clearly see how these things are working. So let's go ahead and check that out. One way of doing that is by going to Window and going to Maya's Outliner. So we'll select that. Okay, notice we see the objects within our scene. Alright, and here is our first object A, but where is object B and where is object C? Well, they are lying, again, right underneath object A. So if we were to go to the plus sign here to expand object A, we can see that we can get right to object B. There it is. Okay, and if we expand object B, we get to object C. So here we see, alright, so B is being controlled by A. We know that from the lines that we see in the outliner. Okay, and also C is being controlled by B, as we can see again looking at the lines within the outliner. So this is the hierarchical form of what occurs when we parent objects. Okay, so that's one way we can examine that. Another way is through the hypergraph. So we'll go to Window again, but this time we'll go down to Hypergraph. Okay, Hierarchy. We'll select that. I'll just bring it over. Again, we see a summary of what we have within our scene. Here we see a better example of the hierarchical form of our object. So here, object A is at the top, meaning it's going to control everything underneath it. Object B is right underneath directly, and we can see the lines, the connections, and object C underneath it. All right, wonderful. Okay, so now that we have discussed parenting, let's go ahead and see how that would look on a character. So what I'm just going to do is go to the ABC layer, and I'm going to go ahead and hide that, just selecting the V, okay, with the left mouse button to hide its visibility. And then we'll go up to the torso layer here, go to the first box, and left mouse button click. And when we do, we get this character that was designed by Justin, part of our human series for designing photoreal humans, which is also a training product we have. So if you're interested in learning how to do just that, please check out digitaltutors.com. But let's see how we can apply this to a character. Again, just setting up a basic structure. So what we'd want is for the back, as we move the back object, to control everything up the top. And then as we move the chest object, we would like that to basically control the neck as well as our head object as well. So let's go ahead and do just that. What would we need to do to have our back object control our chest object? Well, again, we first select our chest, and then, or what we like to be our child, followed by shift selecting the back object, okay, right underneath, and then we hit P. So what does that do? Well, if we select the back object, notice we're able to control the chest and the back. And if we go to the chest, we still have control over it. All right, wonderful. Now, let's see if we wanted to control the neck with the chest and also the back. We'd simply select the object first and shift select the chest object and hit P. All right, wonderful. So now again, we get control over this object. Okay, and then for the head, of course, we know what to do. We select that first and shift select the neck and hit P. So as we move the neck around, all right, the head is following just as we like it to. All right, wonderful. And with parenting, this is really all. We can get an additive result as we rotate our objects. So let's go ahead and check that out. If we select our base, okay, or selecting the back object, shift select the chest object, then shift select the neck, and then shift select the head, notice what we're able to do. If we go to our rotate tool, and we rotate it in the x-axis, selecting the X ring, and move it back and forth, notice what type of really fun effects we can get. Now this is really moving like a torso. Very cool. Okay, so we can twist our objects around too and sway them back and forth, and notice what type of really cool features we can get with parenting. All right, wonderful. So that's how we parent objects in Maya, and we could see the benefits of doing something just as simple as that. And we're going to get into some more fun topics with parenting. But let's say if we wanted to unparent an object. Well, all we need to do is select what object we'd like to unparent and use Shift P. Okay, the hotkey Shift P. So let's go ahead and examine that. I also do want you to note that you can get to your parent options under Edit as well. So Edit, and then right at the bottom, Parent and Unparent. But if we were to go to our outliner, we can get to our perspective and outliner view from the toolbar right here at the bottom, about the third down from the custom panels we have. If we open that up, we could get to our outliner a little bit faster from there. But if we go ahead and go to our back object here, okay, let's go ahead and expand that so we could get to our chest. We'll expand chest so we could get to neck, and we'll expand neck so we can get to the head. Now let's say if we wanted to unparent the chest so that the back no longer controls it. Well, we'd simply select the object we like to unparent and hit Shift P. All right, wonderful. So that's one way we can unparent objects. Now, if we wanted to do that in the outliner, let's go ahead and discuss that. We can go ahead and hit Z to undo that. To unparent, we'd simply go to the object that we'd like to unparent with it selected in the outliner. Simply hold the middle mouse button and drag down to the bottom of the outliner. And notice now it has been detached from the control of of the object that once controlled it. So that's how we would unparent objects. And when we like to reparent again, okay, or if we like to parent within the outliner, we would simply select the object we'd like to parent, middle mouse button click and drag on top of the object. Okay, so right here it would be our back object. And we let go, and now notice it is again controlled by the back object. So that's how we can unparent objects and reparent them. Now let's see how we can do that in the hypergraph. So I'm just going to go back to the perspective, go back to window, and go to the hypergraph. From there we can find our objects. Okay, so here's our chest object, back object. So again, let's say if we wanted to unparent our chest object, we can just go ahead and middle mouse button click. I'm just adjusting this window quickly, but we can take the chest, middle mouse button click, and drag down or drag off of the object. And when we do, notice how it has been separated from its once parent object, which was the back. And when we like to parent the object again, we'd simply hold the middle mouse button, click, and drag right on top of the object again, similar to what we did in the outliner. But again, when we select it, when we select the back and move it around, notice it again is controlling its child. All right, wonderful. So that is the simplest form of rigging an object, parenting. So with that now discussed, what we're going to be doing is getting into how we can create joints in the next lesson. In this lesson, we'll understand what a joint is and what it does for us in the rigging process. This lesson is called 03 Start, and it's located in the project files directory of this training disk. Now, before we get into creating joints, we first want to know what they are. Essentially, what they allow us to do is transform, which means move, rotate, or scale, a skeleton, similar to and designed to depict the bones and joints within a creature's skeleton. For example, humans and animals, but we're not limited to them, as we're also able to use them to transform other objects like ropes and also the rotation of hinges, for example. Okay, so that's what joints do for us. Another very awesome thing they do is allow us to have our characters mesh deform as they move. For example, what we're going to be getting into a little bit later on, which is called character binding, is essentially taking the points on our mesh and binding them or connecting them to our joint so that they will allow us to move our mesh and basically deform our mesh naturally. So this is going to be a really cool process that we're going to get into a little bit later. So let's get right into the joint creation process. Now, we can access that from our menu, but we first want to make sure we're in the right module. So we can hit F2 on our keyboard to get to our animation module, and that will allow us to get to the menu for our joints under skeleton. Another way we can access them a little bit faster is by going to a preset shelf designed in Maya. So if we go to the animation shelf, okay, we should also be able to see our different rigging tools. For example, our joint tool and IK handle tool and other tools we can access very quickly from a shelf. So that's another very handy way to do that, to access tools. Now, if you wanted to design your own customized shelf to get to those tools a little bit faster, just to see the tools that you want to use without any others that you may not use regularly, you can make a custom shelf. So to do that, what you'd want to do is go to the leftmost corner of or leftmost side of Maya next to the shelves. Okay, you'd see this drop arrow. You left mouse button click and hold it, and from there you get to the different shelf options. So let's go to new shelf, and it's going to ask us to make a name. So we'll call it DT underscore IRT for intro to rigging underscore shelf. Alright, wonderful. So now that we have this, we can go ahead and hit OK. Notice now it gives us a clean slate to work with. So how do we add tools? Well, all we need to do is hold Control Shift. So let's do that. Hold Control and Shift on our keyboard. From there, we go to the menu that we'd like to add a tool. Okay, so in this case, let's go to our skeleton menu, and we simply, with the left mouse button, click on the tool while holding Control and Shift. So make sure again you're holding Control Shift. Go to the tool, and just simply left mouse button click it. And notice what happens. It gets created on our shelf. You can see that from the icon. And it also gives us a description. It tells us to click to place joint. So let's go ahead and click that. Notice it also gets updated to our toolbar. And if you ever want to access that tool again, if you're in another manipulator, for example, you could simply hit Y on the keyboard to repeat the last tool, whatever is in the toolbar. But once that's selected, we're now ready to make joints. Now, a few things to keep in mind when creating joints for your objects or characters is you typically want to design them in an orthographic view, like side view, front view, or top view, not the perspective, because if you go ahead and click in the perspective, chances are that joint's going to be positioned somewhere in space far away from where you'd like it to be shown, or where you'd like it to be placed. So you'd want to go ahead and design it in one of the orthographic views. Also, when designing a chain, for example, for the spine, as we're about to do, make sure that it's in the side view so you can very easily draw them out to follow the contour of the body if you so desire. So with those things in mind, let's go to our side view. We'll just hit spacebar with our mouse in the side view so we can access that. And we're going to be drawing a joint chain for our character. Now, another important thing to keep in mind is the position of your joints. You pretty much want to use a reference prior to rigging a character just so you know, okay, where should this character deform from? So in this case, we're going to want the character here to deform from the back, around where the back should pivot, right here around where the chest should pivot from, at the base of the neck, and also at the base of the head. Okay, and then we'll also draw out another chain just to visually represent the flow of our chain, which you'll also really find very common within rigs. So let's go ahead and work on drawing out a chain. Now, if you just want to draw out a chain and follow the contour of the body, you can go ahead and left mouse button click, and notice we're able to draw joints that way. But if you want to draw them straight on, and at times I'll do that if I would like to work on things like advanced twists on characters, just so that that will be set up more conveniently. Now, if you ever want to do that, I'm going to go ahead and just undo the creation of these joints. You would simply hold shift and left mouse button click following the direction that you'd like to move in. And notice that will allow us to lock our joint either vertically if we left mouse button click and drag up and down, or if we hit undo, hit Z to get rid of that bone, and hold shift, and while moving left or right, drag our joint. Okay, notice we're able to lock its motion horizontally. So that can be very helpful, okay, again, for making your joints. So we're going to go right up the spine. I'm just going to go ahead and undo again. So we make a joint right at where the back should rotate from, at about this position. Okay, and we could even zoom in a little bit. Then we'll hold shift and left mouse button click and drag up so we can have a bone positioned right at the chest where that should rotate from. Then again we'll hold shift and left mouse button click and drag up to the neck where the base of the neck should rotate from. And then holding shift again, we'll drag to where the head should rotate from, right at the base there. If I were to zoom in so you can clearly see that. And then we'll go ahead and finish out the chain, again, just for a visual representation of the flow of our chain. Right at the end, we'll just go ahead and hold shift and left mouse button click and drag up to the top. All right, wonderful. So now that we have our joint chain, to activate it, okay, so we can use it, we simply hit enter. All right, excellent. So now they're all highlighted, or actually our root bone is highlighted, but this essentially tells us that, all right, you have now completed making your joint chain. Okay, so with that now done, how are we going to have it so that our objects here are following alongside of our joints, or along with our joints? Well, we have already discussed parenting, so let's go ahead and explore that now using our joint chain rather than parenting to our geometry. So we select our child first, followed by the object we'd like it to be its parent. So in this case, for the back, let's go ahead and shift select our root joint, okay, or the first joint made in the joint chain, and we hit P. So now, if we go ahead and select the joint, notice that's going to control the movement of our our object that the child object, which in this case is the back end. Again, we still have access to move that object around. Okay, but now we want to rely more on the joints to do this for us. So let's say we go ahead and do the rest. Okay, we'll select the chest, and we will go ahead and select the joint associated with it, and we'll hit P. All right, wonderful, great. So now that is moving around just right, and if we go to the root, we can go ahead and move that around as well, and notice both will move. Very cool. So we'll select the neck. Okay, and if the manipulator is getting in the way, you could just go to the select tool, hitting Q on the keyboard, or going to it from the toolbar. But from there, making sure the child object, which is the neck geometry, selected first, we'll hold Shift and select the neck bone, and we'll hit P. Alright, excellent. So now that is being controlled. And then we'll do the same for the head. We'll select the head geometry. Okay, again, go to our select tool so we could select the joint easily, and hit P. Wonderful. Alright. Great, so there it is, and we won't need to parent anything to the top bone at all. Alright, wonderful. So with this now done, we have our joint chain established. Okay, we have, if we were to go ahead and select all of them, we can see that we'll also with this really quickly be able to get that nice additive result in our rotation, for example, as we move them around. Okay, so very cool. And we could even go to the perspective to see this. We twist. Alright, excellent. So now let's say with our joints in place, let's say we go ahead and discuss a few more things about them before we get more into their attributes. So if we like to see them, one way we can do that is to go to shading and go to X-ray so we can see it through our character. But Maya 8 has a new feature that allows us to have our joints show through our character, okay, without going to X-ray mode. So if we go ahead and uncheck that, we actually, under shading, would then go to X-ray joints. And notice we're able to see the placement of our joints through our mesh, okay, making it very easy to select them as well. So if you're not using Maya 2008, you can still access your joints very easily by just using X-ray. But if you have 2008, you can go ahead and use this X-ray joint feature. But here what we see, again, is a parent-child relationship in hierarchical form, okay, going upwards. All right. So here's the main parent, the root, and we have the necks, which controls the joints above, and so on and so forth. Now, very quickly, we know what a joint is, but what a bone is essentially it shows us the relationship between our joints. For example, the joint from our parent, or excuse me, our root, all the way to where our chest joint is, this link that we see here, that would represent the bone. Okay, so the link between the chest and the neck, right between here, that is the bone object. So that's just FYI. All right, excellent. All right, well, we have created bones within our character, and we have the character now moving, okay, along with our bones by a regular parent. And from this, we can very quickly establish a parent-child relationship automatically when we create joints. So that's another benefit of using them. But with this now discussed, that finishes this lesson. In the next lesson, we're going to get into our joint attributes. In this lesson, we'll look at some of Maya's joint display settings. This is lesson 04 start. Let's say we start off this lesson by just going to shading and going to X-ray joint so we can see them as we're making them. And we'll also make sure, again, we're drawing them from an orthographic view. So in this case, since the palm is facing the way it is, okay, since the arm is turned the way it is, it's probably going to be best to draw it from the front view, okay, where the arm is positioned, the elbow at the bottom, and where the hand is also where that's oriented. Okay, so it all depends where you're drawing your joints. It all depends on really the position of your character. So in this case, it might be best to draw from the front, but if the hand was flat palmed, you'd want to start from more of a top view, drawing out your joints, where the elbow would be more at this position in the top. And we do have kits that go over this thoroughly. We have our character setup kit, and we also get into this with our quadruped rigging kit as well as far as joint creation. So if you're interested, I would recommend checking those out. But let's go ahead and draw out our joint chain for this arm so we can get into some display settings that we have. So we'll draw out one around where the shoulder would rotate from. Okay, starting there for our root. Then we'll draw out one at around the arm, where the arm would twist. Then to our elbow. Okay, so we'll bring that down a little bit there. And then bring it back up slightly for our hand. And then we could end it right at the tip of our middle finger. Hit enter. Alright, wonderful. So what do we see here? We see some bones are larger than others. Now why is that? Well, this all has to do with our bone radius settings. We can access that by going to our bone tool and double clicking. And notice right here at the bottom we see our our radius settings for these bones. Now, what we see, just working our way down, we see our short bone length. What short bones are bones that have a small distance. So that's from our root bone to this arm bone. Notice how small our root bone is because it was a short distance from joint to joint. Now, the long bones are the opposite. They are the ones that have a longer distance. So what these settings allow us to do is to adjust their maximum size. Okay, so we can adjust our short bone length, as we can see, which is right now set to a unit of 1. Alright, so that would be the max we're able to expand it for right now with this setting as we draw them. And for our short bone radius, what that does is it basically controls the size of our joint. So the circle that we see, our joint display. So the short bone is set to 0.5, the large bone radius set to 2, and the large bone length set to a value of 30. Okay, so knowing that, if we wanted to change their size, we would need to, if we wanted this tool to work as we adjusted these settings, we'd need to go ahead and redo the chain. Otherwise, we wouldn't be able to see it update as we move these sliders, as we can see. Go ahead and move that around. I'm just going to bring that back to 30. Just wanted to show you that. But we do have a way of adjusting their radius from the attribute editor, Maya's attribute editor. So let's go ahead and check that out. We'll just go back to our channel box so we can get a wider view. We'll hit enter and go back to our perspective. And as you can see, also the joint chain is a little bit positioned outside of the arm, so you can go ahead and hit enter. If you'd like to position it in the arm, you'd simply select the root bone, go to the move tool, hitting W on the keyboard, or go into it from the toolbar and just use Z, the Z axis, and move it back so it's positioned a little bit better. There we are. Okay, so now if we want to adjust our bone radius, what we can do, let's say if we wanted to shrink the size of our elbow bone here, we can simply do that by going to our attribute editor. Okay, that is this first tab, okay, around where our channel box and also settings lie, first tab. If we select that, notice we get two different options. So here is the category we want to focus on, the joint category. All right. So right now the radius is set to about 1.8. So if we wanted to shrink that, we could either put in a value here, so let's say about a value of 1, and we could definitely see what happens as we do that. Or another way we can move in our text fields is by holding Control and left mouse button clicking within the text field left and right. And notice what that does for us. Allows us to make really fine adjustments by doing so. Okay, wonderful. So let's say we brought that to about 1.3, and we could even type that in. Alright, great. So we've adjusted the size of that one. And let's say we even if we even went to the end bone here, and since it's not really too significant, we can decrease its size. So we can just hold Control and hold the left mouse button and just shrink that down. All right, wonderful. So that's one way we can adjust the radius of our bones. But let's say altogether we wanted to shrink or increase the size of all of our bones, okay, for our characters. Sometimes you'll be working with scenes that have bones appearing as if they were really skinny in size, or you'll have bones that are rather large in size, depending on the scale of your character. Well, you can adjust your bone display by going up to display, the display menu, going down to animation, and going down to joint size. So when we select that, let's go ahead and do that and explore what this does. And I'll even go back to the channel box so we can get a wider view in here. So if we move this slider, notice altogether we're going to be able to adjust the view of our joints, which is very handy for the display of them. That's what the purpose of it is, to just adjust their view so we can see them clearly within our character. Okay, and when we get to working on things like fingers, if we were to draw out a chain for them, you'd probably want to bring the size down if the bones were too large, okay, or bring them up if they're too small. So it all depends. Whatever is more comfortable for you. Excellent. All right, well, that is those are a few of our bone settings. We have gone over the display, the X-ray display, okay, as we saw from the last lesson, and even as we've used in this lesson. Now, the last topic we're going to discuss prior to moving on to more of our joint attributes is display handles. What display handles allow us to do is basically create a quick control object for our joints. Now let's go ahead and explore that. I'll just close out the joint display. If we were to, let's say, go to our arm bone, with that selected, going back to our attribute editor, if we scroll down till we get to the display tab, let's go ahead and open that up. And here, right at the top of the display category, we see display handle. So let's go ahead and check that on and see what that does. If you notice, there's something that has been updated with our scene. So let me go ahead and go to show. Let's go to show, and we'll go to joints to hide them. Notice what now appears across here, and this basically tells us, all right, this is a handle we can use for our bones if we ever wanted to hide them and just really animate on them, but without really seeing the bone. So this handle here shows us the position of our bone, and what we can even do is adjust the handle placement. Okay, so if we were to ever adjust any of these settings, if we wanted to bring it up in the Y, let's say 2 units, okay, that's probably too high. Notice where it is. Notice the bone is still where it's at, but the handle is a little bit higher. So you'd want to use this if you wanted to, let's say, easily select your handles. You can just adjust their shape, but you're not adjusting the pivot at all. You're not adjusting the bone, just so you can clearly see and select an object. Okay, so I'll just go ahead and bring that down to 0. So that's another way we can see bones. And I mentioned controls because you can almost use these as controls for your joints, as they would be kind of a quick setup of doing just that. So if we wanted to go back to our joints, let's say if we had an arm setup like this and we wanted to basically just use our handles for control objects, we can just go ahead and turn those on. The handles, again, are nothing more than just a display. We're still controlling our bones directly by them. But if we just wanted to hide our joints for whatever reason and still be able to manipulate them, we can go ahead and turn on the handles to do just that. And notice also with the root bone what happens with it. It has a different crosshair telling us that this is actually the root, while these are just child objects of the root object, or the root bone. All right, great. So with that now discussed, we've gone through a few display settings for our joints. We've gone through how to set up their bone radius, how to adjust them all together with our display settings, and also how to turn on their handles in case we wanted to modify them without seeing them. So with all of these things discussed, that finishes this lesson, and then the next lesson we're going to get into more of the attributes of our joints. Now we're going to delve further into our joint attributes. Let's go ahead and draw out a joint chain for the index finger. So we can go to our front view. That would be the best possible orthographic view for repositioning the finger joints that we're working with. So we'll draw out a joint chain from the root, or the base of where the index finger would rotate from. Then we'll go to the middle. Okay. Then we'll go to the end, where our very end of the finger would rotate. And then we'll draw out one more at the tip. And hit enter. Alright, so we have our joint chain in place. But if we go to our perspective view, Let's go there. Notice how our joint chain is not properly positioned. It's right in the center, about the center of our grid. Well, how are we going to bring it to our index finger? Well, it is okay to translate or move our joints. So we can go to our move tool, hitting W on our keyboard. I'll go to there from our toolbox and move it over. Okay, so we can reposition it from there. But one thing we do want to avoid is rotating our joints. So we don't want to rotate them in place. The reason why is we want to keep our rotation zeroed out when working on our rigs. This is going to help with connections for controls, and it'll also help when dealing with more complex data like motion capture, just making sure you'll have a comfortable workflow working with it. So try to avoid having any values within your rotation when working with joints to have a better workflow. But how are we going to rotate it then? Do we have to leave it like this? Well, no, we don't. Let's go ahead and check out some attributes we have that will allow us to accomplish what we're trying to achieve. So what we want to do is go to our attribute editor. So that's this first tab here. Okay, again, around where our channel box and settings are. We'll just click on that. And with that selected, we want to bring our attention to the joint category, or our joint tab here. So we've pretty much gone ahead and discussed what our radius was. We know what that is. The bone or the draw style, we could set that from bone to box, and that should update within our viewport. Now, quickly, degrees of freedom, before we get into how we can rotate our joints, we'll just go through our other attributes here, just so we understand what they do. Degrees of freedom, that pretty much will allow us to either lock or unlock the rotation of our joints depending on if we have them checked or unchecked. So checked means that they're unlocked. They have a free, they do have freedom in their rotation. But if we were to, let's say, uncheck the X and go to our rotate tool, hitting E on our keyboard, or going there again from our toolbar, if we were to go ahead and try to rotate in the X, notice how our bone is locked. So that's just a way, again, of just locking our rotation, just limiting that quickly. So I'm going to go ahead and leave that checked on. Now stiffness, what that does, that's mainly for your IK handles. You can control the resistance of how your bone rotates from the stiffness. So depending on how you increase this value, you can limit your motion. Preferred angle basically is also for your IK solver. That allows you, that tells Maya, okay, what angle would you prefer to bend your joint chain in as we're moving the IK handle around. And again, we're going to be getting into IK solvers very shortly here. So that's pretty much what that does. The joint orient is where we want to focus right now, where we want to bring our attention. So that is going to allow us to rotate our joints, okay, or fix their orientation. Orientation and rotation, same thing. But that's going to allow us to fix our position, the rotate axis of our joints, without affecting our joint attributes. So let's go ahead and see how we can use this, because this is going to be very handy for when working on your own characters. If we were to go to the joint orient and go to our rotate Y category for it, hold control and then hold the left mouse button and drag, notice we're able to adjust the orientation or the way the joint is positioned for its rotate axis. Okay, so this is, again, a very handy tool. So once we have it in a good position, now we can go ahead and check out our rotate transformer. Notice it is still set to 0. So again, a very cool, very handy tool to use. All right, wonderful. So now that that has been discussed, and again, I think you're really going to use that quite a bit when working with your characters. And we did see an application of this here using the finger. Okay, but it can apply to other areas of your character. But now that we've discussed that, the next thing we're going to discuss is individually moving our joints even while we have child objects. So if we were to go to our move tool, for example, and let's say we just moved our joint chain around. Let's say if we wanted to bring it down a little bit, if we went to more of a side view, and let's even go to our channel box. And just quickly, a hotkey to get between our attribute editor and channel box is simply hitting Control A. Okay, notice that takes us right to our channel box, and if we're from our channel box, we hit it again, that'll take us to the attribute editor. So that's just FYI, but I'm going to hit Control A again to go back to that. And if it doesn't work, chances are it's just overridden in your hotkey. So you can go ahead and fix that by going to Windows, Settings and Preferences, and your hotkey editor. All right, great. So let's say if we wanted to bring down the position of our joint for the root, but then we'd have to bring up the position of our mid and then bring down the child bone and maybe even adjust the tip, though it's not necessary. But we'd have to just go ahead and bring down the root, and then we'd have to go to the next, bring that up, and then go to the child, bring that down. All right, well, that works pretty fine for us, but I'll show you a way you can do that without having to update the children of this parent. So I just gone ahead and hit undo to back before when we moved our joints. But now, all we want to do to move our joints individually is simply go to pivot mode. And we can do that by hitting insert on our keyboard. Okay, so now notice when we are in insert mode, if we were to go back to the Y, moving in the Y, notice how we get the line still, okay, just with no manipulator visible, telling us that, all right, we are in pivot mode. But if we were to go to the Y and move that down, notice only the root is moving. Very cool tool, and I use it quite a bit, and I think that you're really going to have a blast using it too to adjust your character positions. Alright, so we can now go to our mid bone and move that up, and go to our end bone, okay, and move that if needed. Okay, and again, the child bone, or the end bone, since there's nothing else connected to it, we can simply go to our move tool and move that around however we like it to be positioned. So that's how we can individually move our joints without affecting our child objects. Now, when in pivot mode, you want to first make sure you have a manipulator selected. If we were to go to our select tool and try to hit insert and then go to our move tool, notice it's not going to go to pivot mode. Alright, so you want to try to make sure you have a manipulator first selected, and then you can go to pivot mode from there. Now, another way to do this is to simply hold D on the keyboard, and notice that will temporarily disable whatever manipulator we're in, so we can go ahead and move around our object, and once we let go of the D key, we're right back to our manipulator. Alright, excellent. So that is how we can change the position of our joints without affecting our child objects. Again, a very handy tool, or a tool I find very handy, and I think you will do the same. Now, to finish off the lesson, we're going to discuss one more topic, and that is joint labeling. So if we go ahead and select our joint, our root joint, and we go back to our attribute editor, now we want to bring our focus to joint labeling. And just quickly, if you're trying to figure out what joint rotation limit damping does, this works like joint stiffness. All this does is allows us to limit the movement of our joint chain when we have an IK solver. So that's another option that we have of doing so, adjusting those values. But getting to our joint labeling, what we can do with this is basically, just as it says, we can label our joints so we can see an annotation or visible display from our perspective view, okay, or from our camera view. So let's say if we wanted to really go ahead and label this from our workspace. Well, we can go to our side, and we know that the side is the left. This is the left-hand position. And for the type, well, we have a number of options. Look how many options that we have to work with. Well, we know that this is an index finger, so let's go ahead and do just that. Select the index finger. Now, with all of this done, watch what happens when we check on Draw Label. Notice it's going to draw out the label for us. Okay. Alright, so right now it is telling us that we have our index finger labeled, and it is on the left side, and the left side is color coded. So if we were to switch this to the right side, notice that's going to switch to green, and you can see that the letter has updated to R, telling us that it's on the right side. But we could switch this back to L, or you have the option of just changing it to none, and notice the color change from there. So this would even be a good selection since we're just working with one index finger. Okay, we'll bring that back to left, and you also have the option of making your own label. You can go to none go to other, right under prop C. Okay, and then from here you can switch that if you like. So you can call this end thing if you wanted to abbreviate that, and notice that'll update too. Excellent. So those are our joint attributes, okay, and they come in very handy. We've gone ahead and discussed our joint orientation, we've discussed joint labeling, and we've also discussed how we can reposition our bones manually or individually. Okay, and we also explained that it is okay to translate your joints into place, but be careful or be mindful of having any rotate attributes so you can keep everything as clean as possible and make the rigging process as comfortable as possible. But with that now discussed, that's the end of this lesson, and now we can move on to the next, where we're going to discuss how we can insert joints into chains if we ever need to. In this lesson, we'll explore using Maya's Insert Joint tool. Let's go into our perspective view. Alright, what's wrong with this picture? Well, here we have this leg joint chain, but it's missing a few things. One, it's missing a knee joint so we can bend from the character's knee. What else is it missing? Well, it's also missing a foot bone where we can be able to bend from the foot if we ever needed to. So we need a way to insert these joints comfortably. So Maya does have a very cool tool we can use to do just that, and that is called just that, the Insert Joint tool. So let's go ahead and explore how to use just that and the benefits. So we'll go up to Skeleton, and we'll go right under the Spline IK Handle tool called Insert Joint tool. So we'll go ahead and select that. Notice our tool option has changed. Now, to insert the joint, again, it'd be best to go from an orthographic view. You can add it from an angle in the perspective, but to add it comfortably, you can go again to the orthographic view. So let's go to our side view, and we'll select the joint chain where we'd like to add it to. So that is from our hip bone here. We'll just go ahead and select that. And notice a joint has been created actually underneath this joint that we had selected in the hierarchy. So there's our first point. When adding a joint using the Insert Joint tool, it goes right underneath the selected joint in hierarchy. So right now it's the parent of the joint that we had selected. So now if we were to move this joint, and we want to do that in our pivot mode, or hitting insert on the keyboard, or holding the D key if we like, just so that we don't move our end bone here by the ankle. So to move it around, we simply now go to our move tool, and then we can again hold D if we like. So we can hold D on our keyboard and reposition this joint to the angle it needs to be at. And we'd want to give it an angle too, because this is also going to help the IK solver to know what direction to bend the leg. If it's just straight, you might have an error or an issue where as you go to bend your leg, it's bending in the wrong direction. So you can specify the bend just by adding a slight angle to your chain. But notice now that knee is at a knee joint is created, and it's much better than what we had before. Excellent. But we do want to also be mindful of the other directions of our joint. Notice how it's kind of slightly off in the front. It's fine in the side, but you do want to get into the habit of checking each direction of your objects just to make sure that they're properly positioned, or you can run into a lot of hassles. So let's say we go ahead and move this chain. We can hit insert this time and just move it over to fix its position. Alright, great. And we want to get a nice, as good of a flow as we can down our chain. Alright, excellent. So from there, we hit insert again, and notice the joint has been created. Very nice. So this insert joint tool, very cool, because what it also does is it copies the orientation of the bone that we had selected. So in this case, it's root bone. Okay, it copies that orientation. Notice how they are similar. And one thing it's also great for is even inserting joints while you are binding your characters. And we're going to get into more of that topic, but just to briefly discuss that, when you do have your characters bound, if you want to insert a joint, you can do that very comfortably using this tool, but you'd have to add that object as an influence object for it to manipulate your points or your vertices of your mesh. So we're going to even be getting into adding influence objects as well, so we can understand that topic too. That is related also to binding as well. Okay, but now that that's discussed, so that's what that does. And we do want to also add another joint around where the foot is, so we can make sure that its position is going to be fine. Now, before we do that, let's go up to shading and we'll check on wireframe on shaded. The reason why is this helps us to know, all right, what position do we need to put this joint in so that it will deform this area of our character properly. So you do want to get into the habit of working with wireframe mode when working with joints, just so that you know that the place that you put your joint will deform correctly. Alright, so now we'll go to our insert joint tool, go back to our side view, and let's say we select this time our ankle bone. Okay, so now this bone that we have created is going to be a child of our ankle bone. And from here we can go to our move tool, then go to our insert key or insert key on the keyboard, so we can go to our pivot mode and just change or correct the orientation of this bone. Alright, excellent. So from there, let's check it out in the front view to see if we need to change anything. And actually, it looks pretty good. Great. Well, there is the insert key tool. Okay, and also one thing to remember is that you do want to go ahead and work on relabeling your joints. Okay, when you add them or when you insert them. So in this case, we could label this one the JT underscore knee 01. And if this was the left leg, if you had other legs in here, you can go ahead and label this L underscore knee. Okay, as we've done before, as we discussed in the first lesson. So with this foot bone, we can simply label it JT underscore foot 01. Alright, so again, we do want to get into the habit of that. Alright, but again, that is the insert joint tool and the benefits of utilizing it. Very cool tool for adding joints if we ever need to. And again, it does copy the orientation of your selected bone, and it does go right underneath the hierarchy of the selected bone as a child of it. Alright, so with that now discussed, our next topic in the next lesson is going to be how we can connect joints to our different chains, and also how we can reroute our skeletons if we ever need to. In this lesson, we'll explore Maya's Connect Joint tool. In this lesson, we have this really cool insect leg that Kyle has built for us. Now, what we're going to be doing in this lesson is exploring a few options that the Connect Joint tool can do for us. So let's go to our joint tool, and what we're going to do is just draw out just a few joints. Okay, we'll hit enter. Alright, so getting right into the tool, we'll go up to skeleton, and we'll go to Connect Joint, and we'll go to the options, and we'll also reset our settings. So what Connect Joint does, it's going to take whatever joint we had selected, and it's going to align its position, okay, with the position of our destination. And then it's going to take that bone and place it under the parent of our destination bone. So let's explore that. Let's say if we had an extra object onto our insect leg here, and that we wanted to animate but still have it follow along with our insect leg. Well, what we could do is go ahead and select our joint, okay, followed by the destination, which in this case, let's say it was the elbow of this insect leg, and we go to apply. Notice what happens. Notice it is going to connect this joint right to the position of our elbow bone. Very cool. And not only that, if we could even go ahead and check that out in a different view, like our perspective. So notice how it has only moved its position, not orientation at all, but just its position. But also notice that this bone is now parented underneath the root bone, okay, or the parent bone of the destination object, which in this case is the main or the current root bone of this chain. Alright, so that's a really cool feature, and we still have control to go to the bone that we have connected and move that around. So we can move that around if we like, or change its orientation from the orient tool that we have, and then still be able to go through and move this chain around. Okay, but notice what would happen if we were to go to the elbow bone and move that around. Notice that that is going to stay the same, that chain. Alright, so there is the benefit of using the Connect Joint tool. So one thing to keep in mind is that you cannot connect to the root joint of a skeleton. It has to be one of the child objects. And also remember, it doesn't connect the orientation, but just the position of the joint, and then it gets parented under the parent of the destination object or the destination joint. So that is a look at what Connect Joint does for us. Let's go ahead now and take this joint, and we'll just go ahead and delete the chain. And what we'll do now is explore what parent joint does for us. So let's go ahead and select that. We'll go back to our front view. Okay, and we'll draw out another joint, just one, right above our current parent, or excuse me, our current root joint. So what parent joint does, it works just like a regular parent. Okay, with it, if we have our child selected first, we select our root joint, okay, which is where we'd like this joint to basically end up in its chain. With that selected, okay, and again here we can select our root joint, so that's what's different from our parent joint. But once we have done that, we can now hit apply, and notice a direct parent connection has been made between our joint that we have selected followed by the destination, which in this case is the parent joint. So again, the parent joint will allow us to connect to the root joint of a skeleton, but the connect joint will not. But it will align the the position of that selected object to the destination spot, and then it will then parent it right under the parent of the destination joint. So that's a look at how we can do that. What we're going to be doing now is in the next lesson we're going to discuss how we can quickly reroute the skeleton, or basically change the root of the skeleton if we ever needed to very quickly. Let's look at a way we can quickly change the root joint of our skeletons. This is lesson 08, a continuation from our last where we went over connect joints, or the connect joints tool. What we're now going to be doing is discussing a way we can quickly reroute our skeleton so that whatever bone we have selected is then going to be the root joint of the skeleton. So in this case, we want this joint that we have created, okay, to be the root joint of the skeleton. And when working with an insect, you more than likely would want a setup like that, just so you can get some more better control out of the insect, out of this leg and out of the insect's body. So that's just a quick tip that you may want to experiment with. But alright, so let's say we had this joint and we wanted it to be the root. Well, we'd simply, with it selected, go up to skeleton and go down to reroute skeleton. So with that selected, notice what that does. Now this bone has been updated to be the parent of our entire chain. Very cool. Wonderful. So I could even go ahead and select the elbow bone. So if we were to select that and go to skeleton, go to reroute skeleton, notice that that is now going to be the root of our whole entire chain. So it's a very cool tool. Now, something very important also to note, if we ever wanted to, let's say, have a bone that was added into our scene, let's go back to our joint tool, and we'll go ahead and just add a joint. Let's say if we wanted to have this joint be the root bone, but it was connected to our elbow. So let's go ahead and quickly do a parent where we select our joint first, and we select our elbow, so the elbow will be its parent. But then we say, alright, I want this bone to be the root. So we'll select that, and we'll go up to skeleton and go to reroute skeleton. Alright, notice what is going to happen here. Now, yes, this bone is the root bone of the skeleton, but also notice that now this bone that was directly connected to it now controls the rest of the chain. So the bone, once we have rerouted our skeleton, the bone that is directly connected to it is going to be the child that controls the rest of the bones in our chain. So that's something very important to note. Alright, excellent. But I'm just going to go ahead and select the bone that we had previously as our root, and then make that the root again. So notice how quickly we can do that. And then I'll take this end bone here that is now one of the last childs, or an end child bone. I'll just take that and just delete it, because we don't need that, unless we were working with another object where we would need that bone. Alright, excellent. So that is a look at how we can quickly reroute our skeletons. A very handy tool for doing steps or procedures such as these. Well, with that discussed, that's the lesson. Now let's take a look at a tool in Maya that allows us to remove joints comfortably in a skeleton. This is lesson 09 start. Let's go to our perspective view. Okay, so let's say we had a character and the foot was a robotic foot, so there's not going to be any bending in here, unlike what we'd get with an organic foot. But let's say if it was just one plate. Well, what we could do then, if we had an extra bone in here, is just simply select the bone and use my very cool remove joint tool. Okay, so with that bone selected, that foot bone, if we were to go now to skeleton and go right underneath reroute skeleton, okay, and right before disconnect skeleton, if we select removed joint, notice what happens. Now that joint is comfortably removed from our skeleton. Notice its child bone has not disappeared. It's still there. Unlike if we were to just hit delete, then the whole bone here would be gone. Only thing that would be left behind would be this ankle bone, its parent. But notice how the child bone is still there, and it is a child now of the ankle. Okay, so if we were to move that around, notice, all right, so now we have more of a robotic foot here. Okay, if we ever chose to do something like that. Really a cool setup like that. All right, wonderful. So that's a benefit of using the remove joint tool. Another cool thing about it, if we were to use the binding method, if we were to bind our bones to this mesh, and let's say if we use the remove joint tool, well, we can use it comfortably without having to redo our bind, which in the past we'd have to do. But just one thing we'd want to keep in mind is that the points that were affected by that bone, or the vertices that are influenced by that bone, will have to be redirected to another bone. So you'd have to go ahead and do that. But other than that, it's a very cool tool. And again, that may sound a little bit foreign, changing the influence of our vertices to other bones, but we're going to get into how we can do just that so you can be more comfortable with the topic if you're not already. But that's a benefit of using the remove joint tool. Again, we can comfortably remove it. We still have the child of that bone preserved, and the rest of our skeleton is preserved, and we're able to really get some fun effects from it. Okay, and we saw one method for using it with a robotic foot. But with that now discussed, that is the end of this lesson. And in the next lesson, we're going to see how we can disconnect joints from a skeleton. In this lesson, we'll work with Maya's disconnect joints tool to see how it functions and how it can be used in the rigging process. The disconnect joints tool is probably one of my favorite tools in Maya. What it allows to do is, with the selected joint, once we select the tool, it will disconnect that joint completely from the chain that it was once connected to, and then it's going to add another bone where that joint does lie, that is going to be connected to what was once the disconnected joint's parent, so that we can still maintain its position if we ever wish to get right back to it. So let's go ahead and explore the tool. If we go ahead and select our arm bone, with that selected, let's go up to skeleton and we'll go to the disconnect joints tool, right underneath remove joint and right above connect joint. If we go ahead and select that, watch what happens. Notice, all right, now our joint has been separated from what was once its parent, which was our shoulder bone. Okay, so with that selected, if we were to go to our outliner, notice there's our shoulder and there is the arm that was once under the shoulder. But notice something else. Notice how this bone has also been created, and it's sharing the same orientation as well as the bone's position that was disconnected, as we can see. So now how can we use this? Well, you can get into some really fun connections, getting into constraints to have some a really fun looking shoulder movement, shoulder to arm movement as you move your shoulder bone or even shoulder control around. And we're going to be getting into constraints as well. So from that lesson, you may want to come back to this and experiment into some ways you can basically use in unison the constraints as well as this tool to get some really fun functionality. But so that's what it does. It allows us to disconnect our joints. Notice how its position has still been preserved, and it also has created a bone right above this, almost a duplicate, only this bone now is a child of what was once our disconnected joint. Okay, so with that done, that is the disconnect joints tool. And again, I would explore this because you could get into some fun things with it, and we do go over some of those things in our cartoon rigging kit. So if you're interested, please go ahead and check that out to see one of those fun type of setups you can do utilizing it. But that is the lesson, and in the next lesson, we're going to explore Maya's mirror joints tool. Now we'll see how we can very efficiently duplicate joints in Maya using its mirror joints tool. Here we have a joint chain for the left side of our character's arm, and what would be ideal is to have one for the right side. Now, we're not going to want to redraw an entire joint chain for the right arm and try to match up the positions that we're currently having on the left side. That would be kind of tedious. But thankfully, Maya has a tool that will allow us to very quickly achieve that effect. So let's go ahead and explore that tool. We'll go ahead and select our root joint for the chain, and we'll go up to skeleton, and right underneath connect joint and above orient joint, we find mirror joint. So let's go ahead to its option box, and we will reset our settings. Alright, excellent. So working our way down the list, for the mirror across, basically what this will allow us to do is tell Maya what direction will we like to mirror in. Okay, so the direction that we're going to want to choose is based off of our local rotation axis we see at the bottom left hand corner of our screen. So the way it works is basically, since we're going to be mirroring on this side, we basically look at this axis and say, alright, we know that Y is going to be one of our directions, and we also know that Z is going to be one of our directions. Imagine, if you will, if we were to draw a rectangle to complete this line. Okay, so we'd have a line going down from Y and going out from Z, and then we were to finish it to close off this shape. Basically, we will get a plane. So that basically would be our reflection plane or our mirroring plane. So that is how we would determine what direction we would be mirroring from. So if our joints, for example, were drawn out in a way where it was going from this direction here to the next direction, what would be on our right hand side, if it was perpendicular to what we see here, then we would want to choose a selection of YX. Okay, so that's how it works. So knowing that, we're going to choose YZ for our for our reflection plane. Now for the mirror function, this is very important. If you want to be able to have a mirrored result for your rotations, okay, then you would want to have behavioral. Behavioral is very cool for basically helping out in the animation process. Let's say if we were to animate on these bones and we wanted to be able to read our function curves in the graph editor, well, using behavioral might make that process a little bit more convenient, because it will allow us to have whatever effect we have on our left side, for example, in rotation, mirrored on our right, and therefore we'd have the same values. So let's go ahead and explore behavioral, okay, just to see what type of effect that's going to give us. And then for our search for and replace with, this is basically a really cool renaming feature that will allow us to take the names that we have here that are unique to this side, so that would be L for left, and we'll basically be able to look for those names and replace it with an R, okay, or whatever we like to do that with. And here's where this naming convention really comes in handy, because now we can basically say, alright, I'd like to search for, or I'd like you, Maya, to search for underscore L underscore, so we'll type that in, and let's go ahead and replace that with underscore R underscore, since I want to mirror to the right side, and I like my names also to switch. So now, if I go ahead and hit apply, notice what happens. Now we get our bones lined up in the same position as what we have on our left side, okay, and also notice this, our names have been adjusted as well, so we can very comfortably have them renamed already. Okay, rather than spend the time to go through and change the names, Maya has done that by our selection. So that is very cool. And here is the benefits of using behavioral. So let's say if we had our arm bone selected, both arms, so we'll shift select them both, and we'll go to our rotate tool. We'll hit E on our keyboard. Now notice if we go ahead and rotate in the Z, notice our values are set to -76, about -76 on our left side, as well as on our right side. Though they're giving us a mirrored effect, our values are maintained. So this is a very cool feature and commonly used for mirroring joints in the rigging process. So I would recommend that. And if you're curious to see what orient joint does, I'll go ahead and undo back the mirror joints. Okay, so I'll just undo that back, hitting Z a few times. So if we go to orient, that's simply going to give us a mirror duplication without giving us the result that behavioral would. So if we select both joints, in this case, and rotate them back, they're going to rotate as one would expect. Okay, so we're going to get a value of, let's say if we just rotated in the Z here, get a value of negative 49 here, and also it would show us the result of negative 49, being that this would be in the backwards direction for the opposite arm. Okay, so that is how orientation works. But again, what's commonly used is behavioral, especially in the mocapping process when we have to really read our function curves in animation. So we can go ahead and use that. What I also want to discuss, just a few more things. One, basically when we mirror our joints, if we had a parent joint on top of this that wasn't mirrored, the mirrored joint is going to be aligned or going to be parented right under the parent joint. So let's go ahead and explore that. If I were to select this chain and just delete it, if we now wanted to only mirror across the arm bone, not the shoulder, and hit apply, notice what's going to happen. Alright, the mirror is going to be a little bit different. It's not going to go all the way to the other side of the arm. And also notice this, that now this mirror joint is connected to the parent of what we have mirrored from. So that's very important to note. Also, when dealing with IK solvers, and we're just about ready to get into that in just a few more lessons, but if we were to quickly apply one, going to skeleton, going to the IK handle tool, and let's say if we drew it from the elbow to the hand, for example. Now, if we go ahead and mirror from the arm again, hit apply, notice that that IK handle is not going to update. But if we undo that and mirror now from where the root joint of the IK handle is connected to, which is the elbow, if we now go ahead and hit apply, notice that that IK handle is going to appear. So that's very important to note. And more often than not, you're going to be mirroring from, you may be mirroring from where the IK handle would be connected from the arm or to the, from the arm to the wrist. But that all depends on what type of setup that you're doing. So you want to be mindful of that. But I'm just going to go ahead and delete the IK handle and go back to what worked best for this lesson. So just mirroring from our shoulder to get a really nice looking result. Okay, with behavioral and with YZ. So that is our mirroring tool. Things to be mindful of, and a benefit, it can be really saving us time in the rigging process. Let's look at a few ways we can modify a joint's orientation in Maya. Before we get right into modifying an object's orientation, in this case our joint, let's first understand what our orientation is. Basically, it determines the rotate axis of our objects, and this is very important because this is going to help us to determine how our objects will be rotating. If it was slightly off, for example, in our finger, we would get some wrong rotation effects as we go to rotate our finger bone. We would not have that rotating properly. Another reason why the orientation is important is if they look to be as if they are flowing nicely down our chain, but if we have a different rotate or orientation for our bones, that can kind of confuse animators when they go to check out the animation for any further tweaks if that is necessary. So for example, if this bone was set to XYZ and another bone that needs to be rotated was set to YZX, when the animator goes to check out the graph editor, it's going to be kind of confusing to see, okay, why are the function curves different from this chain than they are from this chain when they should be similar because it is of a like object, the finger, for example. So you want to make sure that your orientation is going to not only be aligned so that you'll get the right rotation, but also match between similar objects so that you can comfortably do your tweaks if you ever need to from the graph editor in animation. And also this helps for when doing other connections that you may need to further enhance your rig. So this is a very important topic. So let's get right into how we can modify our orientation in Maya. Okay, we'll look at the way we can manually do that, and then we'll look at a way we can use a tool to quickly update that throughout our chain. So let's go ahead and select this bone here. We can use our index B bone. With that selected, we'll hit F8 on our computer, and what that'll do is change our status line to component mode. Okay, notice everything's highlighted blue here. So if we go ahead and check on the question mark, which will allow us to select miscellaneous components, notice we'll also be able to see our local rotation axis of our objects. Now, what's important is that when an object is parented to another object and you're viewing its local rotation axis, you're also going to see the axis of the parented object too. So here is our bone's local rotation axis, okay, the bone that we had selected. And then here is the local rotation axis of the object that it's parented to, which is this finger segment geometry. So that's very important. And also you're going to be able to see the local rotation axis of the child bones of that object as well. But now to manually move its position, you want to go ahead and select the local rotation axis. Notice it's now selectable, and make sure you are in your rotate tool, hitting E on the keyboard or going from the toolbar. Also make sure that you're in local mode. That is the most convenient way to manipulate this local rotation axis. So you can do that by just double clicking on the rotate tool and going to the local mode, just checking that on. Alright, by default it is set to local, so just make sure that's going to be checked on. Okay, from there we can go back to our channel box. Alright, so watch what's going to happen if we take the Y and just change its course, just rotate it just slightly off. Alright, now, and notice how, since we're adjusting its orientation, notice how its rotation is not moving. And this is for joints. If it was an object, you would see the rotation of the object update. But now if we hit F8 to go back to object mode, okay, notice what's going to happen. Here is where we see the problem. We'll go back to our shaded view, okay, and we'll rotate this down. And notice how our finger is twisting. It is not bending properly. So here is a reason why we really want to make sure our orientation is correct. Okay, so that was one of them. And also again, when it comes to reading the animation, if this was really twisted, it would be kind of confusing and a little bit unfair to the animator. So we want to make sure we give them the most comfortable rig they can work with. Alright, so now that we saw a way to manually adjust our orientation, let's go ahead and look at one of Maya's really cool tools to adjust it down our chain. So this time let's select our root bone, and we're going to go up to skeleton, and we'll go to orient joint options right below mirror joints. So we'll open that up. Alright, and we can make sure our settings are reset. Okay, so what I typically like to use, what I found most convenient, is XYZ, just the default, but you have a number of other choices. Now, if you were to switch the orientation, okay, if you were to determine or decide another orientation, just make sure that you are consistent with your rigs, just so that again, when you have animators working on your rigs, they can quickly read your F-curve. So make sure you determine which axis that you're going to be adjusting your orientation with. Now the way it works is the first axis we see, that's going to be pointed down the chain. Okay, so that's XYZ. The second axis is going to be aligned at the 90-degree angle between our first and third axis and pointing upwards. So in this case, what's pointing up is Y. And Z is pointing out from our chain. So if we were to go to check that out, we can see this. Okay, so here's X pointing down our chain, Y pointing up, okay, at the 90-degree angle of our first and third, and there is our third pointing out away from our chain. Okay, so that's how we determine that. So if we were to go to, let's say, ZXY, and with our root selected, we'd also want to make sure that hierarchy is checked on so we can update the joints of our skeleton. Okay, we could hit apply and notice how that updates. Alright, and because of our parent object having its connection, it has been kind of shifted, mainly because we did manually adjust that orientation. So again, we see another reason why we want to be mindful of adjusting our orientation, or we get some weird effects. That's if we have our orientation off when using this tool. Alright, but I'm going to go ahead and undo back before we rotated that joint. Okay, so now if we were to go back to our root bone and go back to ZXY, making sure hierarchy is checked on, we'll hit apply And notice now there's no shifting that occurs out of our geometry. And also notice now we have determined a different rotation axis. So we know it's ZXY because Z is pointing down our chain. X is pointing up at the 90-degree angle of the first and the last is Y pointing away from our chain. Alright, excellent. But again, what I like to use is XYZ, but we can go ahead and leave it at ZXY for this lesson just to see the difference. And we are able to determine the second axis world orientation. Okay, so we can adjust that if we like. This basically is determining what direction that our joints are going to be pointed in. If this was set to a negative Y, we hit apply. Notice how they flip. Okay, so now the up axis is pointed downwards. Okay, so that's something just very important to note. So if we were to go to X or ZXY and hit apply, notice now X is pointed downwards. All right, so that's if you want to flip that, if at all necessary. It might be necessary for certain parts of your rig. Okay, so that would determine the up and down direction, and then X would determine the X direction, Z the Z direction. All right, excellent. So let's just say we go ahead and flip this back for the finger and apply. All right, excellent. Now the last one we didn't go over was scale. That basically would also change or update the orientation of your scale as well, so you can scale along your joints the same direction as you are rotating them and with the same orientation. Okay, excellent. So that is how we can change the orientation of our joints, and that is also why it is important to be mindful of the orientation or the rotate axis of our joints. Also important to note before we close off this lesson is basically it helps us to determine just the direction that we're moving in as well as far as our objects. So notice as we rotate the finger down, we're moving in the negative direction. So again, that's very helpful for graph editor work. Well, with that now discussed, that finishes this lesson. In the next lesson, now we're ready to move on to discussing IK solvers. In this lesson, we'll understand what an IK solver is and its purpose in rigging. IK stands for inverse kinematics. Now, before we understand what that is, we first need to understand FK, which is forward kinematics. What that is just selecting one of your bones and rotating them. So whenever we rotate our bones, either for posing or animation, that is essentially forward kinematics. Now IK, and I just went ahead and undid that move so we can go back to the default position of this arm. But what IK does for us is just as it says, it's going to inverse the rotation of our joints based off of the position of our end effector that we'll be seeing very shortly when our IK handle is created. So that is going to allow us to accomplish things like animating arms or other limbs very quickly. And there are other solvers that can be used for animating things like ropes and tentacles or things of that sort. So it all depends on what you're going to be working with to determine what solver to use. So with that said, let's go ahead and check out the IK solver just so we can further understand how it works. And we've seen it before, but let's go ahead and really delve into it. So we'll go to skeleton and we'll go down to our IK handle tool right underneath the joint tool and check out its options. And do make sure that your settings are set to default. We'll just click reset tool so that everything is going to match the settings that I'm using. Alright, so working our way down the line, we first have our current solver that will allow us to switch between which solvers we use. RP, which we're going to be discussing first. This is probably the most popular IK solver used. What this essentially stands for is rotate plane, the R and the P. And what this does is allows our end effector to, our IK handle to follow the position of our end effector. Okay, so it just calculates the position. Now, the SC solver, which we'll get into a little bit later, that is position and rotation. So let's go ahead and focus more on this rotate plane solver. The first category we see underneath that is, or the first option we have underneath that rather, is auto priority. Now what priority is, what that does is tells Maya which IK handle to calculate first on a joint chain that has multi IK handles. So essentially how this works is if you have a priority set to 1, Maya is going to calculate that IK handle first. And if you have a priority set to 2, of course, that's going to be calculated second in line. Now, auto priority, getting back to this, that basically says that any IK solver that is connected from the root bone and on will automatically have a priority of 1. And any others following after the fact that will have a priority of 2. So if it's going from the arm to the wrist, for example, and it has a priority of 2, it's going to be calculated second. Alright, so that's essentially what that is. Solver enable, that will basically turn on our solver so that we can have it working for us. So we do want to make sure that's checked on. Snap enable, what that will do is help us to keep the IK handle aligned with the end effector that stays with our wrist bone, or with whatever is our end bone that we've specified. Sticky, what that does is takes the IK solver or IK handle and keeps it to the world so that when we move our root bone, for example, or any of our bones in our chain, the IK handle will not be moved at all. It will keep its position. And also something very important to note, when we do apply the IK handle, we will not be able to rotate our joints until we adjust one of our settings. But typically when you do set up an IK handle, you can't rotate any joints that are connected to that IK handle. Now the weight, that essentially is the intensity at which our IK handle is controlling our joint chain. And the PO weight, that basically is a relationship between our IK handle and the end effector. So with a higher weight, that'll have the end effector favor more of the IK handle's position and orientation. And with a lower amount, you get the opposite effect. Okay, so with that all said, let's go ahead and apply that IK handle now. So we'll go ahead and select from our arm bone all the way to our wrist bone. Now let's go to our channel box so we can get a bigger or a wider display. So watch what happens now if we go to our move tool and move this road to our RP IK handle. Notice what type of effects we're able to get. Very cool. So you can see here how much of a benefit it is for using this when working with bipeds and quadrupeds, characters that have limbs. Now, IKs and also FK do have their pros and cons. The pro of the IK handle is what you're seeing here. We can really quickly animate arm motion and things like that, of that sort. And it's also great for when wanting to plant the character's hands onto objects while moving the arm around. With FK, that is very difficult, and almost impossible to do. And if you were to actually attempt doing that, you may get some really jittery type of motion. So if you were to have a character's hand planted, I'd recommend using IK for that. Now the cons, with FK, it's very easy to get arcing motion, and that is very important. It's actually one of the principles in animation that help you to have a believable, natural looking animation. Now with IK, it's going to be a little bit more work to get arcs. So you'd have to really tweak the function curves so that you are getting a nice looking arcing result. So those are pros and cons of both IK and FK. Now before we move on, let's go ahead and delve into the IK handle a little bit more by looking at its input-output connection, so we can take a look at its end effector and also the solver that has come along with it. So I'm just going to go ahead and undo back to before the IK handle was moved. Okay, we'll just keep going back. There we are. Alright, now with it selected, we can go up to Window and go down to Hypergraph Hierarchy. So we'll go to there and hit F so we can frame up our IK handle. With it selected, let's view its input-output connections. So we'll select here. Alright, so here at the top we see our IK solver. This is what allows us to get the functionality we're seeing here. So that's essentially what that does, a tool that Maya has built in for us to achieve this effect. The effector, or what is called the end effector, gets planted right at the end bone of where we have specified for our IK handle. So this is what the IK handle is looking at whenever we move it around. Okay, so this is how our bones are able to move as they are. Again, they're looking at that end effector, and the handle that we're able to animate on is looking at the end effector. Okay, or actually vice versa. The end effector is actually looking at the movement of the IK handle, and we can see that because of the connection that it has for its translation. But that's another topic. We're not going to be getting too far into this. We're just understanding the basics of how this works. Okay. The other connections we see here are the root bone to this IK handle, as well as the actual handle itself. Okay. But with all of that discussed, that is essentially what an IK handle is, and we're going to be getting into some more fun topics like the attributes we can use to tweak our IK handles, and we'll also explore others that we can use in the rigging process. So that finishes off this lesson, and let's say in the next lesson we get to more of our IK handle attributes. Let's look further into our IK handle attributes. Let's go ahead and select this IK handle, and we're still working with a rotate plane solver, but we'll also explain some other attributes that we have that come along with it that can also be used for other IK solvers. Okay, so for those type of attributes, we'll briefly discuss them until we get to that section on this training. Now to start out with, we'll focus on the channel box, and then we'll move into our attribute editor and explain things further. So we're looking right underneath visibility. We see pole vector. Well, what is that? Well, that allows us to control the orientation of our IK solver's joint chain. Okay, so if we were to go to our pole vector X, and with that selected, okay, use the middle mouse button within our scene to move that around, you can see what type of effect we're going to be able to get with that. So we just hold down the middle mouse button and drag left and right, and we can see the channel update. Okay, so just going to go ahead and undo that so we can see what Y does and Z, and we should notice that we're getting a limited amount of control as we move these around individually. Now, we don't necessarily want to animate all three of these attributes individually. There is a way to control them very comfortably using constraints, and we'll check that out actually very shortly. Okay, but for right now, that's essentially what our pole vector does. That allows us to, again, control the orientation of our IK handle's joint chain, which helps us to prevent flipping in our IK handle. Okay, so if you were to, let's say, move the leg up in a position that would cause for flipping, okay, as we're seeing here, you can use the pole vector to adjust that. And this is mainly used for working with or animating things like knee or elbow movements. So we're going to be getting into some fun stuff like that, but I'm going to go back to the default position of this. All right, excellent. All right, now what offset does, offset and roll, they are for our IK spline solver. So we're not going to be getting into that yet, but that's what these two options are for. And the twist underneath that essentially works like our pole vector. So we can go ahead and twist that around to see how that works. So if you ever wanted to work without a control, let's say for your knee, a visual control, if you wanted to do that from the channel box, the twist would be the way to go for animating your knee movements, in my opinion. Okay, so that's what that does. Now, how about IK blend? Well, this is very cool. This allows us to animate between our IK working for us and FK. So let's say if we, after the person here has just gone through doing a really cool kick, okay, let's say if we needed to have this leg be controlled by FK to get some other motions that we wouldn't want to animate necessarily with IK. Well, what we could do is just go to our IK blend and switch that from 1 to 0. And now nothing much has really changed, but, or as we can see from our viewport, but watch this. Now we can go to our joint and move that around comfortably. And notice it's no longer constrained to the IK handle. So we can animate forward kinematics very comfortably by just turning off that option. And it can be blended to. Now, if we just try to use our blend now, notice it's going to snap. All right, it's not going to have a blend at all. But when using the blend, what you'd really want to do is set keys. And once you start setting keys and scrub back and forth, then you'll see the blend really working for you. So that is what our IK blend does. And I'm just going to go ahead and undo back those moves so we can get our IK handle back to where it once was. So that's what that does, and very commonly used in animation because you're not always going to want to use IK, and you're not always going to want to use FK. Okay, and we went over some reasons. One, FK helps or prevents you from having things like your feet or hands planted. Okay, and we went through other things that we'd want to use IK and FK for. So with this option, we're able to switch between the two and use them whenever needed. Okay, and we're actually going to be delving into this a little bit further, our IK blend, in an upcoming lesson. Alright, so now that we've gone through our channel box, let's go ahead with this selected, go to our attribute editor, and explain a few more things that we see. Now, starting with our IK handle attributes, we pretty much went through all of this. So let's go ahead and check out what sticky does. So if we were to check that on, okay, or even, before we even do that, let's go to our root of this chain and just move it around. Notice how the whole leg is moving, okay? Now, with sticky on, if we go ahead and now turn that on, okay, going to, our IK handle, that is. If we check on sticky, notice what happens now. When we select our joint chain, notice how our leg's position does not go past the IK handle. It is rotating down, and there is a way to keep the foot from doing this, from actually being planted, and we'll get into that as well. But notice what that does. Now the position of our IK handle is locked. So this is great for doing initial changes like this with your characters. If you decided to just work on animating the IK handle, you'd probably want to use an option like this to prevent you from having the bone or this chain here act as if it was in FK mode. So that's a very cool option we have. I'm just going to go ahead and undo that back to its default position. So that's what that does. Okay, we've explained everything else here. So now we could go down to our IK solver attributes, and we know what IK blend does. That allows us to switch between IK and FK. Now IK FK control allows us to manipulate our leg in FK mode even while our IK has been animated. So if we go ahead and check that on, and if we were to move our IK handle, okay, we're able to go to our leg and still move it around. So but one thing we want to be mindful of before we actually move that around is to make sure that sticky is turned off in this case. So when doing that, make sure sticky's turned off, and then you can comfortably go ahead and rotate your leg around. So even if that was animated, you can go ahead and pose out in FK, and we're going to see where we can apply this, where we can use this option in a later lesson as well when we get more into our IK and FK control. So I'm just going to go ahead and undo those moves back again. Alright, so that's how that works. Okay, our IK FK control. Now for the solver, we can change it from here if we like to we have the SC solver and the high IK solver. High IK solver, what we see here, that is basically for Maya's full body IK system. We're not going to be getting into that since this is just a basics kit, but if you were to look into that, the full body IK is a very advanced system that allows you to get really nice subtleties. For example, if you were to ever pull an IK, okay, let's say if you had a whole entire skeleton and you had IK set up, if you were to pull the leg, for example, and the IK handle was to go too far, the leg would actually start pulling, and then the rest of the skeleton would as well, as if someone were to, let's say, pull a leg. So that's a very cool feature in Maya as well. But again, since this is basically this kit, we won't be exploring that, but that's what the high IK is for. Alright, and we've went over what pole vector does. Notice how our offset as well as our roll have been disabled for our rotate plane solver, okay, because it's not to be used for this. Our twist, okay, we are able to use that if we control click and check that out. We saw what that does. Alright, excellent. Now, the twist type, okay, what this does, this allows us to basically determine how our object twists. So, with twist set to linear, we're going to get an even amount of twisting. Now, with it set to ease out, what that does is allows us to offset it so that there's more twisting that happens at the top of our chain than what appears at the end of our chain. Now, ease out is vice versa, so we'd get more twisting from the bottom than the top of the chain. And ease in and out will get more twisting from the middle of the chain. Now, these options are for our spline IK as well. Okay, so we pretty much have our pole vector and twist to control those twists the way our limbs twist, okay, for this, again, IK solver. Alright, so with that done, we've pretty much gone over all of the settings for this IK handle, as well as the one that we're going to be looking into after the fact. So that finishes this lesson, and in the next lesson, we're going to explore the SC, or single chain solver. Now that we know how the rotate plane solver operates, let's look into Maya's single chain solver. Let's attach another RP solver, or rotate plane solver, to this leg, just so we can compare the difference between the rotate plane solver and the one we're about to work with, the single chain solver. So we'll go back to our IK handle tool, either from our toolbar and go to the options, or again under skeleton, under the joint tool, IK handle tool, and go to the options from there. But either way, again, we're going to make sure we're using the rotate plane solver, and we'll connect it again from the thigh all the way to the ankle. Alright, so now notice something. If we look at the top where we've connected this IK handle, notice how it has this disc. Well, this disc is actually the twist disc that allows us to get the twisting that we were seeing out of our solver. So if we go to our twist, notice how we're able to get that nice type of twisting. So that's essentially what this twist disc is for. Enables our pole vectors to work. Now, if we were to undo before we've made this solver and now go to the single chain, going back to our options, this time we'll switch it to SC. Now watch what happens when we create our IK handle from our thigh bone to the ankle. Okay, so notice there is no more twist disc. Okay, we can't go to any of our pole vectors and try to move this around to twist it. We can't go to our twist attribute and move that around. Well, does that mean that this cannot twist? Well, actually it doesn't. We can twist this. We can go to our rotate tool, and with that selected, we're able to rotate our solver around, or rotate our handle around, and notice that twists our leg. It does the twisting for us. Very cool. Now if we were to go to our other attributes, twisting those, notice how, alright, those don't update. Well, they don't appear to here, but if we were to ever lift up this leg and then try using them, notice, alright, now we get more twisting happening. Okay, also in our X as well as our Y, even more so than the others. Now, if I were to go ahead and use a solver, I would stick with the rotate plane solver. Now, the advantage of the single chain solver is that it calculates faster than the others. Okay, that's one of the solvers that calculate much faster than its cousins. But more often than that, I'm still going to go ahead and use the rotate plane solver for something like a limb, because it's more predictable, since it only looks at the position of the end effector rather than looking at the position as well as the orientation, as what we get from our single chain. Now, as far as the other attributes that it has, notice it does have an IK blend, IKFK. If we were to go ahead and undo that to bring the leg back, if we were to go to the attribute editor, notice we still have other options we can work with. Okay, can switch the solver type. We can adjust the twist. Remember, okay. Notice how the pole vector is grayed out here. We can change the priority, weight, the PO weight. Can even turn on sticky. And notice if we were to go to the thigh bone and move that around, okay, it's going to work just as we'd expect it to. So that is a look at the single chain solver. And again, it doesn't have a pole vector, okay, so we can't get any twisting from there. We can, again, rotate from the handle itself. But again, it's less predictable than the rotate plane solver, so I would recommend using that for limbs. But yes, with this all now discussed, that does finish this lesson, and in the next lesson we're going to go over Maya's really cool spring solver. In this lesson we'll look into Maya's hidden IK spring solver. The IK spring solver is a very cool tool for when wanting to use an IK handle to have your joints move proportional one to another. So essentially we're able to evenly distribute our angle amount as we move our IK handle around. So this is very cool. But let's go ahead and experiment with it. We'll go to our IK handle tool, either from our toolbar or from skeleton right under the joint tool, and we'll go to its options. Alright, so let's go ahead and activate it, but where is it? Well, we can't access it from our current solver menu just yet. What we first need to do is activate the tool from our command line. So this is very cool. So let's go ahead and see how to do that. We'll go down to our command line, and from there, once we've clicked in, we'll type in as follows: lowercase ik, capital SPRING for spring, and capital SOLVER. Now make sure that everything is typed correctly or spelled correctly, otherwise the tool won't work. So once we've assured this, we can now hit enter, and now notice our menu has actually expanded. Let's go ahead and see what has now been added to it. Well, now notice we're able to get to our spring solver and even the high IK solver for the full body IK system. But let's go ahead and focus on this spring solver. We'll select it. Okay, nothing changes. We pretty much have the same options, but we do have it has its own unique settings, and we're going to get into those as well. Okay, so now with this done, we can go back to our channel box, and let's go ahead and connect it from the start of our leg geometry all the way to our end bone, not the root, but the start of the leg geometry to the end bone. Now, if we were to go ahead and move it around, let's see what type of effects we get. So notice here we see the effect of our angles moving proportional one to another as we move this tool. And you don't want to move it too far, otherwise you get a little bit of flipping. Okay, and there's ways to avoid that. One of them being using the twist. Okay, so notice it does have a twist disc. Okay, so if we move that around, we can move our pole vector. Very cool. And what it also has are some settings that will allow us to adjust our start angles as well as our end angles, or excuse me, our start as well as end angles. So let's go ahead and explore those. With our tool selected, we'll just go to our attribute editor, okay, and we'll scroll down till we get to the IK solver's attributes. Let's go ahead and open that up, and here we see that it has its own unique settings, okay, its own unique tab. So let's go ahead and open that up. Alright, notice we get to some pretty unique options in this tool's attributes. Okay, so starting down from the top, our rest pose basically sets what position we'd like our IK solver to be in initially. At default, once we create the IK solver, it's already at a rest pose, but we can set our own current rest pose by selecting that icon if we like. So that's essentially what that is. Now our selected position, it is a read-only attribute, but we'll see a way we can actually adjust this. But essentially this tells us where these markers here, which are our spring alias, our spring bias values, this essentially tells us where these lie on this plane. Okay, so these markers here, they're icons that allow us to adjust our angles, and we're going to be getting into them. Now our selected value, this is where the value of these markers lie. Okay, so looking vertically, okay, in position horizontal. So that's a way you can remember this. Now interpolation, this really doesn't matter for the spring solver. This is just what is coming along with our ramp node that has been incorporated into this tool to get this functionality we see here. So this isn't really necessary at all. So we'll leave it as is. But notice, alright, let's go ahead and really explore the tool. We can lift up the IK solver, and let's say we go to our first marker here and bring it down, and notice what that does. Notice how it changes the angle, lifting the leg up a little bit more, and if we move it down, notice what type of effects we get there, moving it backwards. So you can see what type of fun activity we're going to be able to get from using these angles, or adjusting our angles here. Okay, so you can really have more control as to how your insect leg should move. And here we see a great application for it, for an insect leg. Okay, and there's other ways to use this as well. So I would just experiment with this some more and really get comfortable with it, so you can use it to your advantage. So that's what our end angle does, and we could also move our end angle as well. Oh, excuse me, that's our end angle. This is what our start angle does for us, and we have control of moving this end angle back here. As we go ahead and adjust that, you can see what type of fun effects. And notice we are able to set the resistance of this solver. So notice if we adjust it as is, we can't really bring the solver too closer to the start of this leg's geometry without it flipping. So we want to be mindful of that. If we ever wanted to, we probably want to bring down our values a little bit more. And notice we have more control, and it makes the leg more flexible. All right. Now, the last thing we'll explore in this tool is this expanded window. If we go to this arrow pointing to the right of us, let's go ahead and select that. And notice we're able to see exactly what we see in the attribute editor. Okay, and what we're also able to do here is actually add icons to this to really get more control as to how our angles move. So that's as simple as clicking on this horizontal line. All right, now notice one has appeared, so we can move this as needed. Okay, and you should notice the difference as you do that. Notice how we're not able to get as close as we once were able to by doing that. So this is just for more finer control of your solver. And if you ever want to delete that, let's say, oh, I don't like that, you simply go to this X at the bottom that we see here that follows the marker around, and you select it. Simple as that, and you get right back to where you once were. Excellent. Well, that's a look at the Spring IK Solver, a very handy tool for, again, animating such things as insect legs or whatever else that you may find that you need that type of movement for. And if you are looking for a naming convention for this, we can label it as follows: SPRIK underscore leg, or even insect leg if you like, 01. Okay, so that's a naming convention we could use for this. And if it was on the left or right side, of course, you would label that accordingly. But that's, again, another look at the IK Spring Solver. And again, it's a little bit similar to the Rotate Plane Solver in that it does have a twist disc too. So we're going to be able to control its twisting with a constraint that we're going to get into a little bit later on as we delve into ways to control our twisting. But with all of this said and done, that's the lesson. In this lesson, we'll look into the benefits of using IK-FK blending. With all of the solvers that we've gone through so far, we are able to utilize the IK-FK blend attribute for them. What we have in this scene is just an IK leg. Okay, we just have the leg going up and down as we scrub back and forth. And what we're going to be doing is just setting up a few keys that will allow us to see how nice the blend is going between them. Okay, just so we also understand how that would operate if we were to ever add something like that onto our rigs. So when we select our IK handle, we want to make sure a few things. Let's go to our attribute editor. Under our IK attributes, we'll make sure we open that up. And we just want to make sure that sticky is going to be turned off so we can rotate our leg around. So let's make sure of that. We'll also make sure that once we've done that, we'll also make sure we'll go to our IK Solver attributes and make sure that our IK-FK control is checked on. So we'll be able to rotate our leg even in IK mode. As we can see with this checked on, being that we do have an animated IK, we can comfortably go to our thigh bone and move our FK bone around. Very nice. But if we were to scrub, it'll snap right back again because we don't have any keys to lock it in its position. So let's go ahead and do just that. We'll go to our channel box again, and we're setting up something very basic here. What we'll do is with our thigh selected, we'll hit Shift E on our keyboard on frame 1, and then let's go to frame 10, and here all we'll do is just rotate the leg in a different direction. Okay, simple as that, and hit Shift E again to lock in their position. Now as we scrub through, we won't really see anything because we now need to switch our IK blend from IK to FK. So what we'll do is on frame 15, we'll go to our IK blend with it set to 1, meaning IK. We'll right click and go to key selected. Now let's go to about frame 30 and now set the IK blend to 0 and watch what happens. When we hit 0, notice how our leg flips to the position that we had for our FK, and we'll right click and go to key selected. So what does this do for us? Well, let's go ahead and go to frame 1 and we'll scrub through and see. So notice with our IK handle selected, we see a drawing here, a display of our FK bone. Now it's not selectable. This is just a display helper, so we know exactly what or what position our FK bone is lying in. So as we scrub our animation, notice, all right, we see that our IK is coming up, but we see what position our FK leg is in. And as we scrub back, notice how nice the blend is as we scrub between the two. So this is a very cool feature. And again, this is just a display that we see in our viewport, not renderable at all. Okay, so if we were to hit play, you can even check out how smooth that transition really is. Okay, so again, here we see the benefits of utilizing IK-FK blending. You can really get some nice results, so I would highly recommend experimenting with it. So with that done, that does finish this lesson. In the next lesson, we're going to go over our last IK solver, which is the Spline IK. Now let's explore Maya's Spline IK solver. The Spline IK solver is great for organic effects in our deformations. For example, you can use it in a character's spine to get some really nice deformations as the spine moves, or we can use it for an example like this, creating deformations out of a wire and animating that. And if you'd like to get further into ways you can use the Spline IK handle or the Spline IK solver, we do have rigging kits that go over that, like our character setup, cartoon character rigging, as well as cartoon vehicle rigging. So I would recommend checking those out if you'd like to delve into its options. But what we have here is a grappling hook with a wire, and we're going to be hooking up this wire onto these, we'll basically be hooking up the Spline IK onto this joint chain that drives the mesh for our wire. So right now, our wire geometry is bound to these joints that we see here. And again, we're going to be getting into binding. But right now, our main focus for this lesson is going to be on the Spline IK. So let's get right to that. We'll go to Skeleton. And right there, from here, we'll go to our Spline IK handle options, right underneath the IK handle tool. Alright, wonderful. So let's go ahead and reset our settings, and we'll work our way down. The root on curve, what that does is it locks our root bone, or the start joint, to the curve that's generated with our Spline IK. Okay, and we do have the option of either creating that curve and using whatever curve that we have created, or we can use the curve that Maya generates from the tool by selecting another option. But we'll get to that option. So the next option we have is called Auto Create Root Axis. So if we check off Root on Curve, notice that that makes accessible the next option, Auto Create Root Axis. What that does is it makes a transform node on top of our start joint that we can then rotate. So we're actually able to use that transform node to rotate this joint that would allow us to that wouldn't allow us to do that otherwise. So that helps us to have more control over our start joint, and it also helps to prevent flipping in our Spline IK. Now, Auto Parent Curve does exactly what it says. The curve that would be generated, or that we would have created and applied to our Spline IK, would be automatically parented under the root bone or the start joint of this chain with this option checked on. And typically I like to leave it checked off, okay, but you can leave it on for certain rigs. Okay, so now that that's been discussed, we also have snap curve to root. We have the option of doing that with that checked on. We have auto create curve. So here's how we can create our curve automatically. And notice underneath here we have auto simplify curve. So if we check that off, notice the number of spans gets grayed out. Okay, but when we check it on, we can specify how many vertices we'd like to add to our curve. So 1 or a span number of 1 would mean that we'd have 4 vertices on our curve, and 2, 5, 3, 6, 4, 7, and it goes on in that manner. Now, root twist mode constrains our root joint to our curve so that as our curve twists, we'll also be able to have fall off on our root bone. Okay, but we won't have access to move our root bone with that checked on. So we want to be mindful of that. All right. So now that that has been discussed, we do have a linear twist type, and we went through these. The linear sets an even amount of twist throughout the chain. Ease in sets more of a twist at our end bones, and ease out more of a twist at our start, and then ease in and out more at the middle section of our object. So let's say we go through and just make our curve. Okay, we'll explore a couple of methods. Let's go ahead and work on creating the curve ourselves. So for that, we'll go ahead and check off auto create curve. And we can also check off auto parent curve so we can see where it goes. And we can also make sure that we check on root on curve. And everything looks pretty good from here. So once that is now done, what we now want to do is go to our create options and go to our CV curve tool. So we're going to be making our own curve here. And what I like to use is 3 cubic. That helps to visually see the nice organic deformation effects that we'll be getting. So we'll make sure that the CV curve tool is a reset. So we are at 3 cubic. And then from there, let's go to our 4 panel views and draw out our chain, or excuse me, our CV curve tool from the side view. All right, now we're not going to be lining these up precisely. I just want to show you how to make your own curve and the benefits of doing that. Sometimes you're going to want to specify how many verts you want in your that make up your spline IK. So what we'd want to do to start out with is just go ahead and go to show in the side view, go to show and hide our joints, or excuse me, not our joints, but rather our polygon objects, just so that we can comfortably snap to our joints. Okay. All right, so to start out with, let's hold V and click near our root bone, just so we can snap to it. And then we'll snap to a next bone. Okay, we're holding V. Again, holding V, just snap all the way down the line, just making a few curves here. Okay, all the way till we snap to our end bone. And we'll hit enter. All right, excellent. So now that that's done, now that we have a curve, and we could even label this, what I like to label the spline IK curves are is as follows: C SPL, capital SPL, underscore what it's for. So we can say that this is for our grappling hook, but that can be abbreviated to GH01. Simple as that. So we know that this is a spline IK curve for our grappling hook. All right, so from here we can go back to our perspective and open up our outliner so we can see the curve. Now we go back to our spline IK handle tool. Okay, making sure the options are still set. Great. And now we, to connect it, we basically go from our start joint, and then we want to also click our end joint, and we can do that from the outliner. If we go to our start joint, as we see, if we hold shift and click the plus sign to expand it, notice that's going to open up everything underneath. And now from here, we'll simply find the last bone, which is 51, and we'll hold control. We want to connect all the way to the last bone. Okay, and then we will go to 51, hold control, and left mouse button click. All right, now it's not ready yet. We just need to click one more thing, and that's our curve. So now we'll find it. We'll scroll back, and there it is. So now we'll hold control again and click. And now notice our spline IK has been created. So what are we able to do this? Well, with this? Well, if we go to our curve and hit F8 so we can just get to its components. If we go to our front view from there, okay, and just do a marquee select so you can grab the vertices, okay, any number of vertices that you've created with your curve. Notice what type of really cool deformation effects we're able to get out of this. Okay, so this is, again, for more of an organic feel in your rigs, and you can really see the benefits of utilizing this for something like a grappling hook and even a character. So this is very cool. Now what's also cool is that we do have the option of animating these verts, and what's recommended to do is actually adding clusters onto these curves. But before we do that, what we're going to do is check out another method for generating a curve that will allow Maya to automatically create it for us. So we don't have to go through the hassle of making sure that our verts that we create are even. But there are times when you want to do it yourself if you like to specify where you'd like to deform from. So I'll just go ahead and undo the moves back until the spline IK was made. And again, we go to our spline IK handle, we reset our settings, and let's say we use the settings that we see here, okay, except for auto parent curve. We'll check that off. And with that now done, again, going to our outliner and just showing the channel box so we could get a wider display. Okay, so we select our root bone first. Oh, I've gone ahead and selected that twice by accident, so you want to be mindful of that. You want to not select the same joint twice, but you go ahead and select the root bone, and then we find our very end bone, which is 51. So we'll control click that. And now notice that it has automatically been generated. Now the error message that occurred, it was actually a warning telling us that we cannot move this spline IK from our 3D view. So we can't do just that. If we wanted to control this spline IK, it would be from the vertices. Okay, so that's something very important to keep in mind. Now, with all of this discussed, what we're going to do is stop the lesson here, and in the next lesson, we're going to see a way we can quickly control the movement of this spline IK handle. In this lesson, we'll look at ways we can manipulate our spline IK solver. Let's go ahead and select the handle. With it selected, we now have access to adjust the offset of the handle, or we can adjust the roll, the twist. Okay, all of these, except for the pole vector, there's not going to be any twist this of that sort to control the pole vector with the spline IK. But if we were to go to roll, what roll does is rolls our whole entire joint chain. But twist, if we were to move that, that gives us a nice fall off throughout our joint chain. Okay, and we know what the IK blend does. Now with offset, if we were in our spline IK options, if we just double click that, with this checked off, we won't be able to adjust the offset of our curve. Okay, so basically this with it checked off, also we have the option of controlling our root bone as well. So you lose one, but you win one using that option when it's checked off. Okay, so now that that has been discussed, we'll select our handle, and we'll also go to our attribute editor to explain a few other things. So we starting from our spline IK handle attributes, or our regular IK handle attributes for that matter, we know what these are already. These options are similar. Okay, and we know now that we have access to move our offset, roll, and even twist attributes, and we could even adjust our twist type from here. But notice how our pole vector attributes have been grayed out, meaning that we cannot manipulate that. Root twist mode, what that will do is that's going to constrain our root bone so that it will also have a fall off twist as we move our chain. So that's what will happen when we check that on. The next option we have is our advanced twist controls. These are very cool. What these allow us to do is basically have an object control the world up axis of the twist within this chain. And we go over this in detail in our cartoon character rigging kit, as well as cartoon vehicle rigging. But essentially what you're able to do is control the twist of your objects from control objects. So that is a very cool option. We're not going to be getting into this topic since it's a basics kit, but again, these are very cool options to check out, and if you'd like a further explanation of that, I would recommend checking out those kits. Alright, well, now our objective is going to be to see how we can control our spline IK using those vertices. Well, typically what you want to do is add clusters to verts, not necessarily animate on the verts themselves. So if we were to just go to our channel box, just so we could get a wider view and scroll back, we want to get to our curve, okay, that we can go ahead and make sure is labeled as S spline or C spline, followed by our GH solver. Oh, sorry about that. Let me go ahead and undo, here is our actual curve that we've named before, but we're no longer using that, so we can just select that and delete. Alright, so we'll go to our newly generated curve and give that a label of what we've given the label of that last curve, just to keep things organized. And if you wanted to label this spline IK, I'd like to use a naming convention of SP IK underscore what it controls, GH01. So that basically says spline IK followed by what it controls, which is our grappling hook, and 01, how many there are. Alright, but getting back to controlling this curve, what we can do with our curve selected is go to either our polygons menu, or our edit NURBS menu, or we can go to our hotbox, and I do recommend using the hotbox because you could get to your tools very quickly from it. Now notice you can't see everything, and if you're curious how to use the hotbox, if you haven't used it before, it's as simple as holding the space bar on your keyboard. Okay, so once you hold to it, you can get to all of your options from here. But notice you can't see them. Well, all you need to do is left mouse button, click on Hotbox Controls, and go to Show All. And now notice, now we can see all of our options. So again, making sure our curve is selected, what we now want to do is make sure we left click on Edit Curves, and it is getting cut off in the video, but you want to go down to Selection. And what I'll do is I'll even make sure that our hotbox is a little higher up so we can see selection. So there it is, right at the bottom of this menu. So once there, we want to go down to the last selection of this menu, which is Cluster Curve. Now notice what happens. A cluster has been generated on each vertice that is made up of this curve that we've used for our spline IK. So watch what we're able to do. With this last one selected, notice we're able to control very easily our spline IK, so to get some really nice effects. So you can, if you like to animate with this, you can have a mixture of moving the curve around, followed by going to the spline IK and maybe adjusting the twist. So you could get some really fun effects using this. Okay, so we can go back to our other curves and move those around, and notice how nice our grappling hook is moving around utilizing these curves or utilizing clusters. Okay, and another important thing to keep in mind about the clusters, if I were to just select one and go to the attribute editor, you can see that it has relative checked on. You want to make sure that relative is checked on. What that's going to do is give you complete control over how your object is deformed. With it checked off, what Maya does is not only gives you control of moving this cluster and deforming your object, but the cluster handle also gets deformed along with your mesh if it were to ever move around as well. So you just want to make sure that relative is going to be checked on. Alright, so this is how we can control our curve here. And if you like to bring it back to a default, you'd simply put in a value of 0 for the translate. Okay. Alright, so you can get into some really fun things using clusters. Okay, and we also do go over how to really use clusters to effectively for your rigs in our rigging kits as well, such as the facial rigging kit, as well as the others that were listed above or before. Now, if you're having a problem selecting your clusters, one thing you could do is filter your selections. So let's say if I don't want to select the joints, I just want to get to that cluster. I don't want to select our IK handle at all. What we can do is check off these top options here. So the first one, if we click on that, that'll allow us to remove the selection of any handles, the next any joints, and the next any curves, and the next any geometry. So with all of these checked off, we should be able to comfortably select only our cluster and zero it out. Alright, excellent. So from here we can even label these. This first one, since it's pretty much the last one in our chain, okay, being that the root is at the back, we can label it as follows: CL for cluster underscore D01, since it's the fourth of our cluster set. So we can label the next one CL underscore C01. And if you like, you could get a little bit more descriptive. Now, if you ever get an error when you're labeling your clusters, it's really nothing to be concerned with here when you get an error that says no object matches name. All this is doing is saying that, okay, no object matches the name that this cluster once had, all right, which was as follows. But being that we changed the name, we that error really wouldn't matter at all. So it's, again, nothing to be concerned about. This is just an error I had reading that name, but it's very minor. So the next one we could call CL underscore B01, hit enter, and then select the last cluster and label that CL underscore A01. Okay, and also notice that no more error gets that. Sometimes you'll get the naming error, but sometimes you won't. So again, it really doesn't matter at all, because everything's going to function the way you like it to anyway. Okay, well, with that done, we've gone ahead and discussed several ways we can control our Spline IK handle. And we're also going to be getting into another fun topic using the Spline IK when we get later on in the training. But that is the lesson, and in the next lesson, we're going to be exploring control objects. Once we've gone through the process of adding joints and IK solvers to our rig, we're going to want a way to control them. So in this lesson, we'll discuss creating and setting up control objects. Some control objects come in the form of non-renderable curves. Actually, that's the form you'll probably see them more likely in when you view a character rig. And others come in as significant role-playing objects while controlling other objects in the scene. For example, a lever controlling the opening and closing of a door. And we're even going to get into how we can set up that type of relationship later on in the training. But essentially, you want to keep in mind three things when making control objects. One, you want to make sure that they're easily understood and selectable. That's going to help the animator to very conveniently animate, so he can easily select the control he needs to make whatever tweaks need to be made. Secondly, we want to make sure that they're efficient as they possibly can be. So we want to make sure that they can control as much as they can. So we don't have a clutter of controls. That's also going to make it very convenient for the animator or whoever is posing your character to come in and just pose the character as needed without having to say, okay, wow, what does this 100th control do and this 200th control do? So we want to make sure that we can just keep them as clean and also as efficient as we can. And the third, which I've just mentioned, is we want to make sure that they are as clean as they can be. Meaning, what we'd like or what we'd prefer to do is to be able to zero out our attributes, our animated attributes, and have the character go back to its originally created position. So notice here with the IK handle, if we were to go ahead and zero out this position, notice where that IK handle goes, right there to the origin of our grid. And it would be a little bit annoying if the animator had to just animate on this and remember, okay, these values to go back to this default position. So control objects serve as a way where we can comfortably get back to positions like this if ever needed. Okay, so those are three main things to keep in mind, to make them easily understood and selectable, to make them efficient, and also to make sure that they are very clean. So let's get into a way we can set up a non-renderable curve for a control object. And we'll also set up a relationship between that and this IK handle, and you'll get to see what I'm talking about as far as clean controls. So what I like to do is go up to Create and go to Polygon Primitives and make a cube. Okay. From there, let's go back to Create and go to our CV Curve tool, and we'll go to its options. So we'll open that up. And let's now go to One Linear. We'll select that and close. What we're going to be doing is basically drawing an outline of this box or this cube we see here and using that curve as our control object. So let's go ahead and do just that. What we want to do is just go ahead and snap with holding V on our keyboard and left mouse button clicking and snapping, so we can snap to all of the verts. So make sure that you go through and select them all, going right down or right around the perimeter, And it doesn't matter if any of them overlap, that's fine, because this is just a control object curve. It's not going to be rendered at all. So once we've assured that we have gone ahead and drawn a curve all the way around, we can go ahead and hit enter to lock in the curve. Okay, so if we hit 5, so we can go to shaded view, we can now select the cube, just select that, and hit delete. And notice we're left with this curve that is non-renderable. So with it selected, now we want to make sure that it is aligned with our IK solver, because this is going to help us to get back to our default position. So let's go to our channel box too so we can see what's happening. Alright, so now we simply can go to show and hide our polygon objects. Okay. Now we can select, or with this curve selected, go to our move tool, zoom in to our IK handle or even this joint, hold V on our keyboard and middle mouse button click and drag near the joint. And notice the pivot will snap right where we need it to be, right where the wrist is, or right where the IK handle's position is. Alright, excellent. So from here, our control isn't cleaned up just yet. We need to do a few more things to it. But let's go ahead and bring back our polygon object. Okay. And with our curve selected, let's go ahead and shrink this down. We're not going to want the box so large because then it may overtake other controls that we're using. So we'll just shrink it down to a good size. And what's cool is with this curve, what we could also do is, while keeping the pivot there, move its shape forward. So let's say if we wanted this control more where the hand lies while still keeping the position there. Well, we simply can hit F8 on our keyboard to go to component mode, make sure we are selecting our vertices. We could just right click, hold, and make sure that we're in control vert mode. And once we've assured that, we can now select these points, go to our move tool, and move them up. Okay, so we can reshape them, frame it so we can get a better view in here, and then just do some minor tweaks so that it goes over the hand. You can even select these front ones, bring them up. Maybe take these ones to the bottom left of us and just bring those up as well. Okay, so that looks pretty good. And then we can hit F8 to come out of component mode, back into object mode, and notice the pivot is still there because we've only moved the shape of this object. Now it comes to the part where we need to clean up this object, because we're not going to want to have it, remember, we're going to want to easily go back to our default position. So with it selected, what we can do is go to modify and freeze its transformations. You can even check out the option box to make sure that it is set to default. The settings we see here, you can simply go up to reset settings and hit freeze transformations, and notice what that does. That keeps it at the state it's in. We still have our pivot where it's at, and our attributes are set to 0. So we're going to really see a benefit of that very shortly. Excellent. So from here we could give it a name. For a naming convention for control objects, since this is for the arm, we can label it as follows: CC underscore arm 01. And if it was the left arm, you'd put CC underscore L underscore arm 01. Okay, and that naming convention will be fine for this control. So now we know what it is. Let's go ahead and have it control what we need it to control. So with this selected, or excuse me, with our IK handle selected, we simply would shift select our control object so we can parent the IK handle to it and hit P. What does this do for us now? Well, watch. As we move our handle around, notice we're able to control the arm now from this control object. So very cool. And if you're wondering, if you're curious, when you see this purple here, this just means that there is a connection between this object that we have selected. Okay, so in some way, this object, it has a relationship with the objects that are highlighted in purple, with the purple outline. So if you were ever interested in that, that's essentially what that means. Alright, excellent. So now watch this. Let's say if the arm was down here, and I'm like, and we decided that we wanted to bring this back to its default position. Well, all we would need to do is go to our translate attributes, or whatever we moved in, and put in a value of 0, and notice we're right back. So that's a benefit of control objects. And we could also do with them is recolor them. So if we went to our attribute editor, and we went to our first tab, okay, making sure we're not in the shape but the actual transform node, we go down to display, go down to drawing overrides, go to enable overrides, and let's say we give this a color of blue. So now notice we're able to color code it. Now how is this helpful? Well, if you were working with a character that had a left and right side, you can color code the left side to differentiate it from the right side so that it'll make it more convenient for anyone who is manipulating this character. But that's a general overview of control objects, and we do get into those in our rigging kits as well. Character setup, cartoon rigging, as well as cartoon vehicle rigging. So I would recommend you checking those out to see what type of other fun effects you can do with control objects. But with this said and done, that is the lesson. And in the next lesson, we're going to explore using groups for our rigs. Let's look into the major role that groups play in Maya. If we were to define what a group was, we can basically call it a container that contains objects within our scene. So groups play several major roles in the rigging process. So let's go ahead and take a look at some of them. We'll go to our outliner and perspective view. Let's say if we had a clutter of objects in our outliner that made up our rig. Well, we would want that to be cleaned up in some way so that we can just see a node rather than several nodes that make up our rig. So here's where groups can come in handy. What we can do is select our objects that we'd like to just condense the view of within places like our outliner, and we could hit Control G. And notice now a group has been made. And another way to make a group is to go to Edit and select Group at the bottom. But notice now, okay, a group has been made. So what does that mean? Does that mean I can't go to the shoulder bone and move that around? Well, you can still have access to the objects within your group. But again, one of the major roles that a group plays is to really clean up things in places like your outliner. Because notice now we only see one node. And what we can do is go to this group and label it what it holds. So that's GRP underscore arm 01. Okay. So notice now how much cleaner the outliner is from doing just that. And a lot of times I use groups for just organization within the outliner, not necessarily to move. You can move the groups around if you like, and that plays a major role as well, as we're about to get into. But let's say if you just wanted to clean up things within your outliner. Well, you wouldn't need to move the group then. So you just go to your translate all the way to about scale. Okay, your scale Z. Just go ahead and left mouse button click and drag to select them. Then you can right click and go down to lock and hide selected. So the reason why we want to lock them is so that the animator or anyone who's using this rig knows that, alright, this group is not to be moved. It's just for organization purposes. And hide would hide those channels that we currently see. If we just hide our selection, we're still able to move it around. So let's go ahead and go to lock and hide. And notice how much cleaner it is in the channel box. So now we know if we wanted to, we can go ahead and turn off the visibility of this group or turn it on, depending on what we'd like. But it's a really cool feature that groups give us. So now, if we were to try to rotate this object, hit E on our keyboard. And you should also notice that when we hit Control G, or do a default group from our edit menu, that will send the pivot to our center of the grid. But notice now if we go to rotate tool, we can't rotate it around. The move tool can't move it, nor can we scale the group if we were to try to do that. Okay, excellent. So that's one role that groups play, organization purposes. Now another role that groups allow us to have, if I go ahead and undo back to before we remove those objects, is to be able to either control or even not control objects contained in them. And that gets more into constraints. And we're going to get into constraints actually after this lesson. But basically what we're able to do, since this is just a parent connection, we're going to be able to control this object again from this pivot point. So in characters, you may find that they have this global control or this halo around the character at the base or at the floor. So that's essentially what a group can be for, to control the character's position. So if we ever needed to, we can rotate them from that point and move them from that point. So that's another very cool use for groups. And we go over that also, again, within the rigging kits that I've mentioned earlier, the cartoon character rigging, the cartoon vehicle rigging, as well as the quadruped rigging. So if you are interested in delving into groups further, I would recommend checking those out. But let's go ahead and check out another benefit of using groups, and this is what I think is very handy. In animation, sometimes when going to our control objects, animating on them, we want to go into a certain direction. Okay, so like in this case, let's say if we just wanted to animate in our diagonal direction going from our X and Z. What I'll do right now is just go ahead and constrain the Y direction so we could just move in the Z as well as the X. And you can do that by just control clicking the handle for the move tool. So whatever handle you control click, okay, that is the handle that gets constrained or doesn't move. So we can control click, and notice if we try to go to the center of this object, okay, where we see this yellow box and move it around, it's only going to move in the X and Z. Alright, so let's say if we just constrain that, and let's say if we wanted to move in the diagonal direction. Well, notice both of these attributes are going to update. Well, what's the problem with that? Well, when it comes to keying, if we want to keep our keys as clean as we possibly can, we want to try to animate in just the minimum amount of attributes as we need. Okay, so with this type of setup that we have currently going on, if there was no group, then it would be kind of problematic to do just that. Okay, but now I'm going to go ahead and undo back the move. Okay, and I'm going to also bring back the movement of this Y handle. You can go ahead and move it as it is constrained right now, but you just couldn't move it from the center. But if you want to disable that, you would just hold Control again and click on that yellow box. And notice now we can move in all directions. So that's just a tip. But let's say if I wanted to just move in one direction in that directional or that diagonal angle. Well, now we can use or rely on groups to help us to correct that position. So with our group selected, now what we can do is rotate our object in that direction, and now notice this. If we go to our control, making sure that our move tool is set to local mode so we could just animate in an individual channel, now we're able to move just in that direction. Notice nothing else is updating as what we had before. So that is a very cool thing we can do with groups. Well, with that now discussed, that pretty much finishes off this lesson. And just FYI, if you ever wanted to make sure that you are in local mode or whatever mode you are need to be in for your transforms, you can double click on the tool and that will tell you what it's in. So right now our move tool is set to local, and by default it's set to world, so we'd want to be mindful of that. And also that applies for other tools. So our rotate tool, we can be in local mode as well, and also for scales, but that's just FYI. But again, getting back to the lesson, that is the explanation of groups. Remember, they're containers that allow us to either organize things within our scene or even control or not control objects. And we'll understand that further as we get into constraints. And they also allow us to modify our pivots. Okay, so we can go to a group and even go to our insert key, so we can go to our pivot mode and move this up. And let's say if we wanted to rotate around the chest, this object, well, the chest would lie around there, and we can go ahead and rotate from that very position. Okay, and they also help us to adjust our local rotation axis so we can key very cleanly. So we want to be mindful of that as technical artists or as character setup artists. In this lesson, we'll start the process of going through Maya's major constraints, and we'll start with the point constraint. What the point constraint does for us is it allows us to lock in objects, translate information to another object. So essentially, what we're able to do is not only have that type of relationship, but also turn on and off that relationship if we ever need to. So this comes in very handy for control rigs. So let's look at an application of a point constraint with these two examples first, and then we'll see how we can apply it to something like a character's arm. So what we have here are just two locators. Okay, what we want to do is also go to our outliner so we can get to our example A group. Let's go ahead and open that up so we can get to the objects in it. So here's our object A, here's our object B. So let's say if we wanted object B to be aligned with the position of object A and to be controlled by just the translation, not rotation at all, but just the translation of object A. We would first select the driver, okay, so what is going to manipulate the object followed by the driven, or what will be controlled by the object. So that's selecting again the driver first, selecting the driven object, and then going to constraint and selecting point constraint. But let's go to the options. So just so we can understand what these are. What maintain offset would allow us to do is have an object in a certain position and not have it snapped together when we apply our point constraint. So essentially we can have our object positions preserved and still set up the connection and move our object around as needed. And we're going to get into that using the maintain offset in the next lesson. But here we have different offset settings that will allow us to offset where our object will lie as we do the point constraint. And we're going to see how to use that in this lesson. And constraint axes, this will allow us to determine what axes allow a constraint on. So if we wanted to just constrain in the x, we can do that, or the x and y, we could do that, or if just in the x and z, we could do that, or just the z, we can do that. So we have several options, or we constrain in all axes. And then for the weight, we're able to either, we can use this to turn on and off the how much of an intensity the object controls the other. But let's make sure that we are using our default settings, and we'll hit add. So notice what happened. Where did our B object go? Well, now it's aligned with our A object. Okay, so if we took A and moved that around, notice we're able to control the position of B. But if we went to our B object and moved that around, notice, okay, we're still able to freely rotate in our axes. All right, there's no constraint. And another way we can tell there's a constraint is because our attributes for our translate have been highlighted blue. So that tells us, yes, a constraint has been made on these attributes. So if we were to go to A and try to rotate it, notice B is not moving at all. But if we move it around, yes, it will then move for us. So this is great for when setting up rigs and for really getting specific to tell Maya, okay, I want you to have this object control its translate information, but not its rotate. Okay, I want another object controlling the rotate attributes. Another cool thing is that we can take object A and let's say we tried to move its pivot. Well, it's also going to move the B object around since the B object is constrained to the pivot of our A object. Okay, so that's something very important to note. So essentially what we can do, if we went ahead and undid that move back, hit insert, and just went to deleting our constraint, and we could do that by going to our node here, and here's another way we can access the constraint. All right, so if we selected that point constraint and just hit delete to remove it, and we took our B object and placed it back, just putting a value of 0 in, and also zeroing out our A, what essentially we can do, let's say if we wanted our object here to be constrained to the pivot of this object, but not to its shape, we can go to our insert mode, move it, okay, and if you want to see the pivot of an object and even snap to it at all, using holding V on your keyboard and vert snapping, you can select the object you'd like to see the pivot of, go to display, transform display, and turn on the local rotation axis. And also make sure that handles are checked on so you can see that. But let's say if we now wanted to take this object and constrain it to the pivot of this object. We'd select our driver first, followed by what we'd like to constrain, and then we go to constrain and set up that point constraint, and notice now it's going to go to its pivot. Okay, so if we try to move this object around, selecting it, can control it from its pivot. So again, this comes in very handy for the rigging process. But another thing about constraints, again, we can go to them and turn them off if we like. So if we turn it off, notice that B object is going to go to the position where it was constrained at originally. In this case, the A object was constrained at about, or we constrained the B object when the A was a little bit lower, as we can see, because of our B object shifting. But if we turn that back on, we can go right back to its position. All right, and this can be animated, and we can use setup switches on our rigs to do just that, to turn on and off the weight. And we're also able to animate on top of constraints, and we go through that in our introduction to animation training, so I'd recommend checking that out if you're interested in that process. Great, so now that we've checked out what constraints can do for us here, And also, if you're wondering what our offsets do, well, basically we can adjust the position of our objects from just influencing these attributes. So that's essentially what those do. But now that we've gone through an explanation of our point constraints, let's see how we can apply it to a character. So what we can do from here is simply go ahead and go to our group object. Oh, also FYI, if you'd like to get rid of your local rotation axis, that's as simple as going back to display, transform display, and local rotation axis. But let's go to our A example and we'll just turn that off. And we'll even collapse it. And let's go to our B example and turn that on. And here we should see an arm within our scene, the control. Alright, so if we wanted to just point constrain this object to our IK handle, making sure that it's in its position in the same position that the IK handle is lying in. So if this control object was ever here, let's say, we'd want to set up the point constraint where it's aligned to our IK handle first so that the IK handle does not shift at all. So we can maintain the position of our arm. So we can turn off polygons with that control selected, hold V on our keyboard and vert snap to its position, and then from there you can freeze its transformations like we discussed, cleaning it up if you ever needed to, and then show back the polygon object. So now now that we've assured that it's at the same position as the IK handle, you then can select your control object, shift select the IK handle, go to constraint and do your point constraint. And now notice this, if we go to our point constraint or point constraint controller, which is this control object, and move it around, notice what we're able to do. We're able to control the position of this IK handle. And if we want, again, we can turn that off. So if we went to our objects in the B example in the outliner, went to our IK handle that is constrained, turned off its constraint, which we could also get to from the channel box of the selected object. If we turned off its constraint, put in a value of 0, notice it'll go right back. The control object will no longer be affecting this object until we turn its constraint back on. So that's a look at what point constraints do for us. I'm just going to go ahead and bring this object back to its default state. So with that now discussed, in the next lesson we're going to bring our attention to working with orientation constraints. So we know that the point constraint controls an object's position. So now let's look at a constraint that controls an object's rotation. The orient constraint is similar, very similar to the point constraint in that it controls specific attributes. So in this case, it's going to control our rotation rather than position. But other than that, they're very similar in that they have the same settings. So if we were to go to our constraint options, okay, for the orient constraint found right underneath the aim constraint, let's go ahead and open that up, and I'll just reset the settings. Alright, so once we've made sure of that, again it works just like how we've done before. We first would like to select the object we'd like to be the driver, followed by what we'd like to constrain. So let's say we take the A object and have it control the B object's rotation. So if we use our default settings and hit apply, notice, okay, we have a connection made. So what does that mean? Well, when we take A, go to our move tool and move it around, okay, notice the B object is fine because it's not controlled at all by position. But if we take the A object and rotate it, now we're able to control the object's rotation. So this is great for rigging as well, as we'll see very shortly. Now, something important to keep in mind with the orient constraint is maintain offset. So here's where we're going to really use that. I'm just going to go ahead and undo the moves that we've made before we even made the constraint. There we are. Now, let's say if our object was turned this way. Okay, we just added some rotation to it, and we wanted to set up an orient constraint that would allow this position to be preserved, but still allow us to rotate it as we moved this object. Well, we can do that with maintain offset checked on. So when we check that on, we'll go ahead and make sure we first select our A object, and then we'll shift select our B object. And with that selected, with maintain offset checked on, when we hit apply, notice the position is still the same. Well, can we rotate it? We sure can. Watch what happens as we rotate our object. Notice now we're able to still control the rotation just as we would without maintain offset. Only this time we're able to preserve our position. So this is a very handy tool. Use it a lot. More than likely when I'm doing orientation constraints, I'll leave maintain offset checked on for that very reason. So we've seen how this looks with our locators, and of course we have the option of turning the weight on and off. Okay, we can also adjust our offsets from the Y, the Z, or the X from here. And again, we could even turn off the weight from this. Okay, all right. So we have a number of options. We could even adjust the interpolation type of these different settings. Really, I use it for average, but you may find that these other attributes may work best for you. So again, I will just go ahead and experiment with that to see what you may need that for. But personally, I just leave it with the default settings for the orient constraint. Alright, well that's an explanation of how we can use it, how to use the tool. Let's see a practical solution for this tool. If we go to our outliner, we can go to our A example and turn that off. Okay, and go to the B example and show it. So we're pretty much left with the arm that we worked on for the last lesson, going over our point constraint. But now, notice this. If we try to move our arm around, okay, it looks pretty good, but how are we going to keep our hand in a planted position if we ever wanted to? Let's say if we had the arm here, we went to the IK handle, and we moved the twist. Notice how that hand is twisting too. Well, how can we control it so that the hand stays planted while the elbow moves? Like, for example, if we were to rest the hand on, let's say, a countertop, okay, while our elbow was moving. Well, here is where we can use a combination of not only our point constraint, with which what we already have set up, but now our orient constraint. So watch this. If we were to just go ahead and hide our polygons so we can see our wrist, and if we now take our control object, which we would like it to control the object, let's even bring that back to its default position of 0. So if we take our control object and we take our joint and we go up to constraint and do an orient constraint, notice, and here's where we see a benefit of keeping maintain offset checked on, because we have some rotation values in there, and if we didn't have it checked on, these would flip, this joint. But let's say after we've done that, we go ahead and bring back our arm here. So what is this going to do for us? Well, watch. Now, notice, as we move the control, notice how the hand stays flat palmed. It is not rotating at all because our rotation is now being controlled by our controller. Very cool. So we can wave, have the character wave at the screen. Hello, how are you doing? Can have it move all sorts of ways. We can have it planted on the countertop if we wish. And watch, as we go to our twist and move that around, notice how the hand stays planted. There's no movement at all. So this is a very, very handy type of setup for doing this type of feature for your arm, okay, or this type of functionality for your arm, where you'd want the hand to stay planted on a certain object. So that is an explanation of the orient constraint. Now you may be wondering, all right, this is pretty good information, but why would I really need constraints? Why would I really need control objects? Well, there's three main reasons why you would want to use all three rather than just animating on the joints or IK handles themselves. One, for selectable reasons. With control objects, you can go through and just really quickly select the objects no matter what position it's in. Notice here how it's kind of difficult to see the IK handle because of it being covered up, but you can always go ahead and access that control object. It's easy to see. Also, it's for efficiency, getting back to making sure our control objects control as much as they can to keep everything clean within our scene. If it wasn't for this, we'd have to rely on keying our IK handle as well as trying to key our joint. And how else would we have our joint locked in rotation without setting up that orient constraint? Also, it also helps to it helps to prevent anything from breaking within our rig. Sometimes you may notice when you're working on a rig and you hand it off to someone to work with, if you get it back, they may need you to fix something on it because they accidentally broke it, maybe doing a stress test on it. Well, with the control objects, this helps us to prevent that type of situation from happening. And if you ever had it happen to you, you know the importance of using control objects for that very reason. So again, that's a look at our orient constraint, and you can see now what we get with our both the point and orient constraint combined, what type of powerful functionality we get from our rigs. Let's bring our attention now to Maya's parent constraint. The parent constraint takes not only our position but also the orientation into its control. So if we were to select this root joint for this hand, we can see that a parent constraint has been tied to it. Notice how both our translate and rotate attributes are constrained. Okay, so imagine a parent, a regular parent, but the functionality to turn that on and off by its weight. So what we're going to be doing in this lesson, if we were to scrub back and forth on our timeline, we could see this hand moving backwards, and we want this cube to be controlled by our hand. So we're going to look at another application of how we can use our constraints. So let's go to our outliner and perspective view, and to parent constrain this object, again, first we want to select the driver object, which is not going to be this bone here, but the control that's also controlling our bone object. And here I want to stress something very important about constraints. You want to try to avoid adding constraints onto objects that already have constraints tied to them. Doing stuff like that can cause you to run into something called a cyclic error, or even other errors. But basically what the cyclic error does, or what it means, is that, let's say if we had three objects. We had object A, object B, and object C. Let's say that object A was controlling object B, but object B also had an influence of object C. Well, we wouldn't want object A to also be controlled by object C, because that is where the cycle would, or the cycle error would come in. So we want to be mindful of that. You want to try to add your constraints on objects that are, for the most part, clean, that have no type of connections like that. So with that said, let's go ahead and work on our parent constraint and check out its options. We'll select our control curve, and we'll also control click our Rubik's Cube group. And let's go up to constraint, and we'll go down to parent constraint, and we'll go to the options for it. Okay, so here we see several settings, but they look similar to what we've worked with before. Unlike the the point and orient constraint, now we're dealing with two of our object attribute groups, the translate as well as the rotate, so we can specify, alright, just constrain the Z of our translate and the Y of the rotate if you like. But we're going to leave that set to all, and we can adjust the weight. Now maintain offset, notice how it's checked on because by default it's already on. If we were to reset our settings, if we were to choose any other options, okay, and reset our settings, notice maintain offset stays on because that's the best setting for it. So with all of this said, and with all of our objects selected that we need, remember the hand first, the driver followed by the Rubik's Cube second, we'll hit apply and see what this does. So let's go ahead and scrub the timeline to see what we get. Notice now the cube is being controlled by our hand. So if we were to select our hand and rotate it around, notice how it's completely controlling it in rotation, and if we were to move it, okay, in position as well. So this is a very cool option for our parent constraint, and we do have the option of turning that on and off. So if we wanted to, we can go to our Rubik's Cube group, go to its parent constraint, and again you can find that if we were to expand the group, it'd be right at the end there, the parent constraint. So whichever way we select it, we can turn off its weight. Okay, or so if we wanted to, we can set up a control that would allow our control object, to not be controlled by another object. Okay, so we can get some more control out of it, and we go over that thoroughly in our rigging kits as well. Okay, so I would recommend you looking into that. But yeah, so if we didn't want an object to control the object just yet, not until later on in time, then we can set up a switch, or actually key on the parent constraint. But I like setting up switches just so that it's a lot more convenient to get to this switch. But basically, we can adjust the weighting whenever we like, so that the object will have no control over what was once its driver object, or when we turn it on, it will again have complete control. So that's another powerful feature of Maya, being able to do that, being able to turn on and off the intensity like that, so that we can get the most amount of control out of our objects. And also I do want to mention groups can come in real handy here, because if we wanted to go into our parent constraint, let's say we select it and just delete it. Let's say if we then took our Rubik's Cube group, okay, we'll take that and let's hit Control G on it to group it again, to have a group above it. So watch what we're able to do, and we'll label this GRP underscore Rubik's top 01. So let's say we had that group, and let's say we took our control object and control clicked that group, and we went to constraint and did a parent constraint. So notice, okay, everything's going to move just as we need to, but watch what happens if we were to go to the group underneath that. We're able to still easily get in here and animate on it. Okay, so easily just go in and set whatever pose and set whatever keys, but it is going to follow the hand. So if you were to do that, you'd want to go ahead and first set up a switch and key it, turning the parent constraint off, so at a value of 0, so it won't affect. Okay, now notice how it did shift, and that also is why you'd want to just be mindful of how you'd move your objects if you ever to do a setup like that. And again, our rigging kits go over how to very comfortably do this, like for example, again, the cartoon rigging as well as the vehicle rigging. So again, if you're interested, I would recommend checking that out as we delve into that process a little bit thoroughly in those kits. But going back to our object, we can go ahead and zero it out so it goes right back into the character's hand. And that is a look at parent constraints, the benefits of them. And remember, they're just like parenting an object, save we are able to turn on and off its intensity, and also we're not controlling its scale at all, just its position and its rotation. In this lesson, we'll look at a constraint in Maya that will allow us to control things like our knee and elbow motion. That constraint is called the pole vector constraint. What that's going to do is allow us to not rely on the pole vector attributes or even the twist attribute to control things like our knee swivel. So let's go ahead and look at an application of this. What we'll do is create a control object. We'll go to create, and we'll go down to NURBS primitives and make a circle. And I do have interactive creation checked off just so we can quickly make a circle. From there, let's go ahead and rotate it 90 degrees in the X just so that it'll be facing towards the character. And we'll also go ahead and hide our polygons. And with the object selected, go to our move tool and snap it to the knee. So we'll hold V on our keyboard, middle mouse button, click and drag right by the knee so we can snap its position. From there, let's go back to our polygons so we can scale down this control. We don't want it so large, just to about here, the size that it needs to be so we can comfortably see it. And then we can clean it up. We can go to modify, freeze transformations. And when making controls from the menu that we've made it from, so like for example, just making a default circle, you may have inputs that you want to have cleaned up. Okay, remember, we want to get into the habit of cleaning up our controls as much as we possibly can, just to keep everything organized within our scene. So we do have a few inputs we can clean up. The transform geometry that came from our freezing of our transforms, and also this make NURB sphere that came along with generating this NURBS object. So what we need to do is simply go up to edit, delete by type, and clean it up with deleting by type history. So now it's all cleaned up and good to go. From here we can give it a name. We can call it CC underscore knee 01. And if you like, you could even go ahead and give it a color. So selecting the object, going to the attribute editor, we can go to the first tab, go down to drawing overrides and check on enable overrides and give it a color of, let's say, blue. Okay, a light blue. Alright, excellent. So now that this is done, we're ready to make our connection. So that's going to be between our control object and our IK handle. And we're going to notice that what gets constrained is our pole vector attributes. So let's go ahead and check that out. If we go to our control object first, the driver, followed by what is going to be constrained, the IK handle's pole vectors. With both of those selected, we can now go to constrain, and right underneath tangent, we see pole vector constraint. If we were to check out the options, we could see there's just one to control its weight. So let's go ahead and hit add and watch what happens. Let's say if we wanted to lift the character's knee up. Well, we'd want to first move out this circle. If we just move this out, notice how the knee is going to twist back because the pole vector is now looking at this object to control it. So if we were to move this forward, notice how that corrects our twisting. So notice how convenient it is now to control this character's knee. And the same applies for the elbow. This is a very popular setup for controlling things of this nature. Okay, so we can move the leg however we like. Okay, rotate it however we'd like and be able to control the object's knee very comfortably. And this allows it so that the animator does not need to rely on the IK handle to control its pole vector. Notice how it is constrained, and we don't need to control our twist from here as well. Now there is an option where we can set up a direct connection between a custom attribute and this twist object on our control if we wanted to clean this up even more, getting rid of this pole vector constraint and just controlling the knee from the twist of our IK handle. We're going to be getting into custom attributes very shortly, so you will have the functionality to be able to control it from the twist if you felt that having this control for the knee was a little bit too much in your scene. So again, we're going to be getting into how we can set up custom attributes and how we can set up connections between them. But that is essentially the lesson. So what we can now do is select our feet and bring that back to 0. If we ever wanted to go back to the default position, we'd also want to take our circle and bring it back to a value of 0 here. So that's a look at what we can do with our knee controls. And I do want to mention also that there are times where you can have your knee control pointed outward, not necessarily aligned with the knee joint. But sometimes when you have your legs at an angle like this, it's going to be best to just make sure that the control is lined up with the knee, just like with the steps that we took to create this constraint. But with that done, that does complete this lesson, and we now know how we can comfortably control our knee as we move our character's either foot or arm around. In this lesson, we'll look at a constraint that will allow us to very comfortably control a character's eyes. Within this scene, we have a locator that we're going to use for our eye control, and what we also have is a character's head. And I'd like to thank Justin for modeling this for us. This is actually from our Creating Digital Humans training, so if you're interested, we do have training on that as well. But getting right into the lesson, let's say we as technical artists were given the responsibility to rig a character's eyes. Well, we wouldn't want the animator to have to go in and rotate the eyes around, especially when dealing with eyes that have multiple pieces of geometry, like in this case, right? Well, Maya actually has a constraint that will allow us to very conveniently do this type of connection. It's called the aim constraint. What it does is it sets up a relationship between two or more objects that will allow us to control an object's rotation by another object's position. So what does that mean? As we translate our control object around, we're going to be able to control our other object's rotation, so it will look at this object. So let's get right into the lesson so we can really explore what the tool can do for us. We'll go to our outliner and perspective view. From here, let's go to our Claire group and we'll open that up so we can get to Claire's eyes and open that up. Alright, so here we get to the groups that we're going to want to select to add our aim constraint. Now, we'll use our left eye for the initial example. For it, remember we select our driver and then we'll control click our left eye. Now with that selected, we go up to constraint and we go to our second selection, the aim constraint, and let's go to its options. And I'll just reset the settings here. Okay, now working our way down, it does have a maintain offset setting, and you'll probably more than likely want to use that, because notice from default, if we just hit apply, okay, our eye flips, and we're definitely not going to want that. So I'm just going to hit Z to undo that. More than likely, you're going to want maintain offset to be checked on. Now, as far as our other attributes, we have the aim vector that controls how our object points. We have our up vector that controls the rotation of our object. And the world up type basically specifies how this object is controlled with the aim vector. So vector tries to line itself up as close as possible to the world. And we have a number of options: scene up, object up to specify an object, or even object rotation up as well. And these are more advanced options. So what I typically like to use is the vector. Now the world up vector specifies what direction that a vector is going to be in. Okay, so we can control that from here. The constraint axes, we're able to again tell Maya what axes we would like this aim constraint to control. Okay, right now we're going to use all, so we can control all of the rotation of our eye. Okay, and then the weight, we know what that does, so controls the intensity of our constraint. So with all of these things said, let's go ahead and work on having this locator control our eyes. We first would select the control object, again, followed by the object to control, okay, and one at a time here, and we'll hit apply. So notice, all right, what has happened? Well, if we now select this control object, notice what's going to happen with the eye. I'm just going to minimize this option box and also just focus in on the perspective. So watch what happens as we move this control around. Notice now we're able to control Claire's eye from this constraint, and it looks kind of a little bit off because we don't have the other eye being controlled, but you can see very quickly how we're going to be able to control an object's rotation by another object's position. So this is another very cool feature. So let's go ahead and zero out our eye control and set up the right eye. Again, going back to our options, okay, making sure maintain offset is checked on. We'll also go to our perspective and outliner view. We first select our control object, followed by the object to constrain, which is going to be our right eye this time, and we simply hit add. Now notice, okay, the connection has been made to the right eye, and notice how it's just the rotation of that, and I'll just deselect so we can see that it's just the rotation of that eye. So if we were to go to our perspective again and move this control, notice how cool this really is. We can have our character really focus on certain parts in our scene. Okay, so if she ever was walking and needed to look over here and maybe a friend, you're like, hey, how you doing? Oh, what's that? Okay, so you can really get into some fun features with this. And a locator would be an ideal control too, because again, we can have the locator positioned at a certain spot in our scene so that Claire here can focus on that. But that is a look at the aim constraint, the benefit of utilizing it, not only for eyes, but even for setting up a character's biped rig in the torso, for example, or even for our shoulder connections. We have several options to use the aim constraint at. So I would also recommend checking out how to use that tool and just some fun connections you could do utilizing it. But with this lesson now finished, the next topic we're going to be getting into is setting up custom attributes for our controls. In Maya, custom attributes allow us to make our very own unique channel to control specific attributes. Here we've gone back to our leg example where we've made the pole vector constraint. Now we're looking at an alternative solution where we can control, this time our twist, making a custom attribute on our foot control, so we can keep things even cleaner within our scene, as we'll see at the end of this lesson. So let's work on that. With our control selected, we'll go up to modify, and we'll go down to add attribute. Now with that selected, let's go all the way to the top and work our way down to understand what these settings do for us. So here's where we can name our custom attribute, and if we check this option on this is where we can give it a shorter name, a more convenient name if we had a longer attribute name to work with. So we can leave that checked off. We won't need that. But underneath we have make attribute. So here we can specify if the attribute is going to be keyable. It means we can key it or animate on it. The other is displayable. I like to use displayable for category names for attributes that are animated too. So in this case, if we were to make a displayable attribute for this foot control, what we can do here is just basically say that this is for our knee underscore control, and then simply hit add. And now notice it's grayed out. Okay, so we're not going to animate on this attribute. It's just there for a category name. So what we'd want to do then is make another attribute that this time is going to be animated on. So we'll call that twist, or if you like, you can even specify that even more and call it knee twist. And that will also help us to not conflict between different attributes. Okay, just so we don't get confused at all. Alright, so we have a label for it. It's knee twist. And as we get to data type, basically we have several options here. The vector will create 3 attributes that will give us vector positions, that will allow us to control just vector positions from those 3 attributes. The integer will allow us to move our numbers, okay, or move our attributes based off of whole numbers. A string, this is for when we're dealing with things such as file names, so we can use that. Float, which is what we're going to be using, will allow us to get float point values for just one attribute. Boolean is great for doing things like controlling visibility, so turning things on and off. There's no in between. And enum is great. If we go ahead and select that, let's go ahead and check this out. What is cool about enum is that we have these letters or words here we can work with, and we can actually rename these words if we like. So this is very handy for doing things like setting up smooth node connections between a custom attribute and the divisions that come along with the smooth node. So essentially how it works is the first attribute here is 0, the second is 1, and the third is 2, and we could keep going down on and on. And basically what you could do is set green to, let's say, low, blue to high, and 2 to really high. And what that can do is once you connect it into your divisions, you can quickly switch between low division or really high division depending on your settings. So this is going to make a drop down menu for you. And we do get into this in the vehicle rigging kit, setting this up very quickly with a custom attribute. But let's go ahead and go to float. Now when we get to float, and just FYI, scalar, this section here is for particle use, so we're not going to be focused on that. But when we get down to our next settings for the minimum and maximum and default, these do exactly what they say. Here we can specify the minimum value for our attribute, the maximum value for our attribute, and the default value. We're going to be making a limited value in the next lesson when we go over set-driven keys. But for this, we're going to make our value limitless, so we don't have any limit to our control. And that's something I do want to stress to you. You want to try to give your animators that are using your controls as much control as possible. That's going to allow them to comfortably animate. So let's make sure that we do have float selected, and we make sure also that we have our attribute labeled, and we'll hit OK. So now we have this custom attribute. If we select it and move it with the middle mouse button, notice we're going to have complete control to move this however we like. So let's look at a few ways we can connect this to our twist attribute. With our foot control selected, we'll shift select our IK solver or IK handle, and let's go up to window, and we'll go down to our hypergraph hierarchy. With that now there, let's go ahead and quickly go to input output connection so we can see both of them and everything that makes up these objects. Okay, so from here we're able to get to a various amount of controls to be able to basically set up direct connections between the two. So if we wanted to, let's say if we wanted to connect our controls, our leg controls twist attribute that we made for it to our twist attribute on our IK solver. One way we could do that is to go right to the right hand corner, our right hand corner of this node, our control node. Okay, so what is going to be our driver node, very important. We right click and go down to our custom attribute, okay, which should be knee twist. So let's make sure that's selected. Now this line comes attached with our node, our driver node. So now we want to have it connected to the twist of our IK handle. So what we want to do now, okay, and I'm not holding anything at all, just moving the mouse. But now what we want to do is right click on the next node where we can get to our IK handle, and now we want to simply select twist. notice what happens. Another connection has now been made. And we can know that a direct connection has been made because our attribute has been highlighted yellow. So a couple of reasons or a couple of ways we can turn our attribute to yellow. When we do direct connections such as these, or via what we're about to check out very shortly, or if we set keys on an attribute with multiple parent objects, or with multiple objects that control that one attribute. So now that we have this direct connection, what does this do for us? Well, let's go ahead and close out our hypergraph. If we go to our foot control, notice when we get to our knee twist and move it around, we're able to very conveniently control our character's knee. So we can select the knee or select the foot control and move it up, go to our knee twist, and notice how comfortably we're able to control this knee now. Okay, and notice we don't have any pole vector constraint control in here moving this knee. It's just this custom attribute tied to the other. So if we were to bring this to about a value of 7 and go to our IK handle, notice that is also a value of 7 for the twist. So again, it's a direct connection. So that's one way we can set that up. So I'm just going to go ahead and zero out the foot again and also zero out the knee twist. That's one way we can set it up. And also I do want you to mention, note, that when we do direct connections, the object that is being connected to, or the driven object, is going to share the same value as the parent object or the driver object. So in this case, since it's a value of 0, the twist is also going to be set to a value of 0. So you want to be mindful of that. But let's now look at another way we can set up that connection. What we want to do is go to our IK handle, and if we want to no longer have this connection here, we simply would right click and go down to break connections. Okay, so let's do that. Right click and break connections, and notice there's no more connection on this twist attribute. So another way we can set up a connection is via the connection editor. We can find that under Window, General Editors, and going to the third selection, Connection Editor. And I'm just going to bring this over. So what we see here on our left side is our driver side. Okay, and what we see to the right of us is what is going to be driven. So what we want here is for our IK handle to actually be on the driven side. So we'll reload the right side to select it. Now, depending on what you're viewing in here, you may need to go in and just make sure you can see all of your attributes, or just the ones that need to be keyed. So you have several options to do that. From here, you can show all attributes that make up this handle by going to show readable. Okay, or you can specify output connections, input connections. You can go to, if you uncheck non-keyable, show non-keyable, that will only show keyable attributes. So that could really clean up your view in there. And you have several others to choose from. So let's make sure we have these shown, and we have unchecked non-keyable. Now, with that on the driven side, we select our control object and reload that on our driver side on the left. And then we could go to our left display here, and again uncheck the show non-keyable, so we could just see what we need to connect it to. So now we simply want to go to our knee twist, and with that selected, let's connect that to our twist attribute for our IK handle. Now notice when you do that, it should highlight with a color of whatever your system has been specified to. But right now we can't see that, but we know a connection has been made by looking down here by our command line. We can see, all right, here's the result. We have connected our leg knee twist to our IK handle's twist. So if you can't see the highlight, just look towards the command line, because that will also tell you what has happened. So now with that done, if we close this out, notice we get the same connections. We can go ahead and move our knee around very comfortably. So notice how clean our controls look. For this leg control, all we have to work with now is just the control. We don't have two controls tied to it, the knee nor the foot. We only have the foot control. We don't have the knee control visible. So what we can do from here, and what I normally like to do, is just hide any joints and go to show and hide any IK handles, and notice how much cleaner everything looks, and it still functions properly, okay, just as we need it to. So that is a look at our custom attributes that we can use for controlling specific items or specific attributes within Maya. In the next lesson, we're going to look at how we can use custom attributes to control set-driven key relationships. In Maya, a set-driven key gives us the functionality to have an attribute's value be controlled by another attribute's value. Set-driven keys are prominently used in rigging. With them, again, we can control value to value or have value to value relationships. So let's explore how we can do just that. What we'll do is go ahead and select this yellow half circle, and this is basically where we're going to add our custom attribute to control the curling of our index finger. From here, what we'll do is go to modify, and we'll go down to add attribute again. This time we are going to be using a float again, but this time we're going to be giving it a min and max value as well as a default. So let's go to our long name, and we can call this index underscore curl. Once it's labeled, for our min value, let's give it a value of 0. Our max, we can give it a value of 1. And the default, also a value of 0. From here, we can hit OK. And now we have our custom attribute set. So from here, let's go ahead and work on that set-driven key relationship to control the curling of our index finger. Okay. So what we want to do from here is now go up to animate and go to set-driven key right under hold current keys. That's set-driven key, set options. Now this dialog window appears that allows us to establish our driver objects at the top and the driven objects at the bottom. So our driver object is going to be our custom attribute. So we'll select our yellow half circle, and with it selected, let's go ahead and load it as our driver. Okay, notice here is the keyable attribute we can see for the index finger. So now what is going to be the driven? Well, that is going to be a number of our joints in this chain. So let's go ahead and select them. So we'll select our index finger. We'll shift select our mid finger. Okay, so we'll select the index root, the mid of the index, and the end of the index. And no need to grab this end bone here. So now we'll go ahead and load the driven objects. So here we see something very important. We can have multiple driven objects controlled by one driver object, but we can't have more than one driver object controlling driven objects. So that's just something very important to note. But now if we select all of these attributes and select their rotation Z, that is going to give us our curl, and we can see that from going to Maya and rolling the rotation Z constraint ring. So we can see that this is the type of effect that we're going to want to have. So let's now go ahead and zero out our rotation Z. And with all of these selected, first, when you set your key, you want to make sure that you do have your objects selected. So it's going to be index finger to our rotation Z. Okay, and again, you could have multiple attributes keyed or tied to one attribute. But again, we're just going to be using this rotation Z. So once both of these are selected, the driver and then the driven object, we will also want to make sure that they're in their default position, okay, at a value of 0. And we can select our controls from within here. So if we select our finger controls, this yellow circle, we can quickly get to its attribute. Alright, so we want to make sure that we start out with our default position. Okay, and notice if we go back to our driven objects, they are also at their default position of 0. So once we've assured that, then we can hit key selected. And now notice a key has been set, alright, on the value of our rotation Z controlled by our index curl. And we're going to see that relationship and also how to edit that relationship via the graph editor. So once that's done, now we're able to specify our max position. So we want to go to our finger control and this time put in a value of 1. So once you set your initial key of your default position, then you go to your driver, put in the max value, and now we need to go to our driven objects, and we could select them all, just left mouse button click and drag down, and we'll curl the index finger. So let me go ahead and move the menu over, and we'll curl it in so that it reaches about the palm of our finger or of our hand. So now once we have in a value, and I'll just put in a value of negative 70 just so that your values match mine for the rotation Z, and we'll press key selected. So what does this do? Once we've established this, now if we go to our finger curls and go to index, notice as we middle mouse button click and drag to move the finger, notice how we're able to now very conveniently control the curling of our finger. So this is just one way we can use set driven keys. It has a lot of really cool functions that we can use with it. Okay. Now let's say if we wanted to adjust the interpolation of our curling of the index finger. What we can do is go to selecting our bones again. So we'll shift select them all. And we could go to animate and go down, or excuse me, go to window and go to our animation editors and go to the graph editor. And now with our driven object selected, okay, so again, you want to make sure that the objects that have the set driven key, which are our driven objects, are selected. When we do that, notice in our graph editor we get to seeing our driven object at the top, at the left hand corner, our left, and at our bottom right we see the driver object, which is the index curl. Okay, now if we were to hit F to frame this, we can see not the interpolation, not the movement or the animated result of this finger, because it has nothing to do with time. If we go ahead and scrub through the animation, we can see that there is none, because it's not a relationship between time but value to value. So that's very important to keep in mind with set driven keys. If you want this to move, you'd have to animate your custom attribute. Okay, but I'm just going to hit Z to go back to our curve. But with this, we can control how our object moves. So if we go to the selection of our control and go to our index finger, notice how it moves here. But if we were to go back, just hitting undo, and if we were to take one of our tangent handles, go to our move tool, hitting W on our keyboard, and middle mouse button click and drag that up, you can see what type of difference that's going to happen with your movement. Notice now the finger goes up and then comes back down. So that is how we can adjust our interpolation. So if you ever are working on a set driven key and the motion is not the way you'd expect, not as fluid, definitely go ahead and check out your key. So in a situation like this, I'm just going to undo back to the selection of our joints. But in a situation like this, what would probably be best, if dealing from just a min of 0 and a max of 1, what would probably be best is to select your F curve here and set it to a value of linear so you can get a nice smooth result. Now if you are working with a min and a minimum of -1 where the finger raises, and then a maximum of +1 where the finger lowers, then you may want to use spline with your middle selection, which would be about a value of 0, or your default position. Alright, but that's essentially how we can use set driven keys. Very cool, and just a really cool feature in Maya that also allows us to tweak how the object moves. So again, it's not a time to time relationship or a time to value relationship, but rather a value to value relationship. Okay, and before we close off the lesson, I do want you to note that you are able to either edit your custom attributes values. So if it's selected, we can right click and go down to attributes and go to edit attribute. Okay, or you can go to delete attribute. You have that option too, and even adding attributes and duplicating attributes. But if we go to edit attribute, from here we're able to select whatever custom attribute we have, and we can change its name. We can also specify its new min and max values, and we can make it either keyable, displayable, or hidden. Now if that was getting cut off or hard to see, another way you can do that is by going to modify and going to either edit attribute, and we get the same dialog window. And if you go to modify delete attribute, that will give you a list of attributes that you have, so you can just select it and hit either OK or delete if you want to keep deleting any attributes in your scene that make up this object. Well, with that now done, that is the explanation of our set driven keys, ways we can set them up, ways we can also modify them, and we also explored how we can adjust our custom attributes if we ever need to go back and add any more set driven key relationships. So with this lesson now finished, our next task is to go through ways we can deform our objects. Let's look at a way we can deform objects using Maya's lattice deformer. The lattice deformer is really cool for getting some fun deformations out of your meshes. You can use it to either warp the shape of your mesh. Okay, so you could use it for modeling, or you can use it for, let's say, having a character go through a tight spot in your scene. Okay, so you could get some fun effects with it, and we're going to explore that as well. So let's go ahead and just get into using the tool to get comfortable with it, to understand what we're able to do with it. Now, if we want to add the lattice to our whole mesh, we can simply select it and then go up to Edit Deformers and select Lattice. Okay, and here's our default lattice setting. Okay, so notice how it gets connected to just our selected mesh. But I'm going to go ahead and undo that, because what we want to do is just select the vertices that we'd like to connect the lattice to, and we can do that as well. And we'll also grab our eyes into our selection. Basically, we're just going to be controlling the deformations of our head, but not necessarily the neck. So what we want to do is go to our side view, and from there, let's go ahead and select our head geometry, and we'll hit F8 to go to our component mode. From there, let's go to the lasso tool, and we'll draw out a circle from about where the neck starts, or where the neck meets the head, maybe a little bit lower than that, just following my mouse here. We'll draw out a selection of that sort. Okay, we'll also just make sure we have our other verts in our selection. If you want to add to your selection at all, you can use Control Shift and select objects, and notice that is how we add to our selection. But that's just FYI. I went ahead and undid that. But now that we have our vertices selected, let's go to our perspective view, and we can go to our outliner and perspective view and just control click our left and right eyes. Now that these are selected, we now want to go up to Create Deformers again and go to Lattice, and this time we'll go to the option box and reset our settings. Okay, so working our way down, the divisions specify the divisions of our lattice. So depending on these values will determine how many points we're able to have, or vertices we're able to have, to influence our geometry. Now for the local divisions, this is basically the fall off of the lattice. So we'll notice that this setting here is pretty low, and we'll notice what happens as we increase it. Now here we get two options for centering the lattice around our selection. We can do that. Or we can group the lattice as well as the base object. What the base object of the lattice does, essentially it works with our lattice deformer, so that as we transform the points of the lattice, Maya knows how to deform the object. So that base lattice as well as the deformer lattice work together hand in hand. And by default, the base lattice is hidden. Okay, you can select it to show it, view its visibility, but typically you want it to just be hidden. Next we get to auto parenting our lattice to our selection. Okay, so we can do that, and we can freeze our geometry mapping. What this does is it disables the movement of our mesh if we were to try to move it with the move tool, whatever mesh we have tied the lattice to, or even the vertices that make up that mesh. We wouldn't be able to do that with freeze geometry turned on or checked on. So basically it's just for objects that should stay within the lattice. Now outside lattice, what this does, and we can get to some cool things with these options, what this does is tells Maya, with this first option, this tells Maya that, okay, I won't only want you to deform the object when it's inside the lattice. When it comes outside, remove any type of deformation effects, bring it back to its default, and we'll see what that does. And we also have other options for transforming all of our points. So that means that any object that comes outside of the lattice, it'll be as if it was still inside. It's still going to keep its deformations. The fall off, this is what I was mentioning before, where we're able to have a character go through a tight spot and squeeze right out of it. So we could essentially set up a lattice so that as the character moves through the lattice, it squishes, and then as it comes out of the lattice, he goes back to his default or normal state. So you could get some cartoony effects with it. So it essentially works as our first option or default option, except we're able to get a nice fall off. So we're going to experiment with all of these. Okay, but first we'll start with our default setting here, and we'll just hit create. So notice now, alright, we have this cage around our character. And if we were to select this lattice and move it around, notice, alright, it's controlling all of those vertice points, but not with a fall off as we'd like. So we're going to explore that. But also notice here is our base object. Okay, and if we were to deselect, notice we can't see our base until we select it. Alright. Okay, now let's go ahead and see how we can manipulate our points of this lattice or vertices. With it selected, we would just hit F8, and that should send us back to object mode. So we'll need to just hit F8 one more time, just so we could get to its vertices. So if you were in component mode, adding the lattice, once you go ahead and hit F8 again, that's just going to send you back to object mode. So you need to hit it again one more time so you could get to your vert points. So that's important, just in case you think that the vertices aren't showing up on the lattice. But now if we select one of our points and move it around, notice what type of fun deformations we're able to get using this lattice. Okay, so we could really have fun warping our character's mesh, okay, if we ever needed to for whatever reason. Okay, and this could get into some fun effects with things like blend shape deformers as well, and we're also going to be getting into that too. Okay, but now notice, let's say if we wanted to go ahead and adjust these lattice points. Let's say if we wanted to add more points, because we're not able to really adjust the middle of this because of where our points lie. Well, if we went to our lattice shape that we see in our channel box and put in a value of, let's say, 3, notice what's going to happen. We're going to get an error message. It's going to tell us that we can't influence our lattice because we've already adjusted the points on it, so we can't add any more divisions. So how can we do just that? Well, what we're going to need to do, if we hit F8 to go back to our object mode, is either go to Edit Deformers and then go to Lattice and reset our lattice, which would allow us to go back to our default state, but we're not going to be able to add any divisions if we go ahead and tweak our model again. Or we can go to Remove Lattice Tweak. So let's go ahead and select that. And with that option selected, now we can comfortably go in and now put in, let's say, a value of 4 for our lattice, and notice we don't run into any problems. Alright, great. Now I do want to explain the freeform deformation that we have here. So if we were to add a fun little deformation to our character here, just bringing down some verts here and then going to the verts above that, or underneath that, the vertices that is, and move those down. Notice what type of fun effect we're able to get with our character. He looks like a totally different person. We could even select the vertices underneath that, go to our scale tool and scale those out a bit more, just to have a fun looking effect. Alright, so let's say we were to take these vertices, and let's say if we thought that our deformations were a little bit too blocky. Well, what we could do is go to our freeform deformations, either from here or our attribute editor, and notice what happens if we increase this value here to 4. Notice how we get a smoother fall off. So if we were to go ahead and deform our lattice points or vertices, notice how much nicer the fall off is as opposed to what we had before. So we could get some really organic, fun looking effects with this. And again, you can tie this all into your rig, and we go over that in the vehicle rigging kit to look at connections that we want to be mindful of when doing these type of setups. Okay, and we're also going to be looking at a way we can comfortably control our lattice vertices using clusters. So we're going to be getting into that as well. So that's what our freeform deformation does. But I'm going to go ahead and undo back these moves just a little bit, just to show you the difference here. If we were to go back to our freeform deformation and put in a value of 2, notice what happens. Whoa, our object just really flattens based off of the vertices that we have, okay, being that they're at a lower amount. So if you want to work with a lower amount of verts, which is or vertices, which is probably recommended, just so you have less tweaking to do, unless you're really detailing an object, you'd want to go ahead and crank up your freeform deformation to about a value of 4. I think works very comfortable. Okay, great. So again, I'm just going to go ahead and undo our object back. Now, let's go ahead and explore some ways we can tweak our object with the lattice, okay, besides using its points. So here's where we're going to get into our attribute editor. Let's go back to our object mode, hitting F8 on our keyboard, and we'll go to our attribute editor. From here, we have several options. We can get to the lattice shape. Okay, so that is these basically are for our lattice divisions. But here's where we want to get our freeform deformation tab. So here's where we're able to adjust the fall off. And notice here, outside lattice. Now, it's set to inside right now, so watch what's going to happen. Here we'll see a visual example. If we select our head and take it, go to our move tool, and just try to move our object outside of it, notice what's happening. Ouch, our character's geometry is really going back to its original position in a sharp way. So that's how we can use inside lattice. But watch what happens when we use the next selection underneath, set to all. Now it's going to basically say, alright, we're going to keep your lattice deformation, so no matter how you move your object in or outside of the lattice, you're going to still be able to maintain that shape. You can still go to your lattice, go to its points, and it will be as if you really hadn't moved your lattice outside of the mesh. But we are getting a few deformation tweaks that would cause us to move our points in the opposite way. Okay, so that's just something that we want to keep in mind if we were to ever tweak our points with our objects outside. Notice you'll get a type of mirrored or opposite effect as you move your points around when your object is outside of the lattice. But I'm just going to go ahead and undo that and bring the character back inside. Now what we're going to explore is the last option we have for outside lattice. If we select that, notice what's going to happen here. As we move our character out, notice what type of smooth fall off we're able to get as it moves inside and outside the lattice. So again, here's where we can use an example of our character going inside of a tight spot in a cartoony type of effect and then coming outside of that tight spot. So we can use the lattice to get a really fun effect such as that. But with this now done, that basically is the explanation of the lattice. And again, we do have kits that go over how to really get some fun effects with the lattice. So if you're interested, I would recommend you exploring those to really understand some type of interesting capabilities you're able to get using this deformer. But that does finish our lesson on the lattice deformer. In the next lesson, we're going to explore binding our characters to our bones that we've created for our mesh. Once you've made your bones and control objects, you're then ready to have your bones influence the vertices that make up your mesh. In Maya, this is called binding. Binding is a very cool feature in Maya. With it, we can have our bones, our 3D bones, act as our bones do in real life. As our bones move and deform our skin, so can we, with our 3D mesh, deform our object, our geometry, with our 3D bones. So this is a very cool feature, and we're going to be exploring the two ways we can bind in Maya. One is smooth skin, which is used commonly for film and cinematics as well. What that's going to allow us to do is get a more smoother fall off as we deform our bones, and we're going to explore that first. The other is called rigid binding, more used for game characters to get a faster calculation of how our bones deform our mesh. So we're going to explore both of those. So to start out with, let's go ahead and explore the smooth binding process. So what we want to do is go to skin, and we'll go to bind skin, and we'll go to smooth bind and go to its options. From there, let's go ahead and reset our settings. Now, working our way down, starting from bind to, what this tells Maya is, alright, would you like to bind to your whole entire skeleton? Well, you can use this option. Now, underneath this, we have selected joints. What I like to use more often than not, this allows us to tell Maya, alright, I'll only bind the bones that you have in your selection. So this helps us to get rid of any bones that should not influence our skin. So, for example, we're not going to want this very tip bone in our joint chain to be influencing any part of our mesh. Okay, it's not really necessary. So whenever you have end bones like that, I think the best option to use is select the joints. So we can have that selected. But for object hierarchy, that's going to tell Maya that any objects that you have within your selection for the bind process, the whole object is going to get bound to the bones within your hierarchy. So that is what this does. Now, the bind method, this basically tells Maya, all right, what bones would you like to have influence your skin? Would you like the ones that are closest in your hierarchy or the closest in distance? I like to use closest in hierarchy because that helps us to prevent things like our arm bones from influencing our leg bones. And the distance, it works in a similar way, only we have more of a possibility of other bones influencing verts that we really don't want them to. So let's go ahead and use closest in hierarchy. Max influence tells us how many bones we'd like to influence one single vert on our mesh. So right now it's set to 5, so that means that 5 bones can influence 1 point on our mesh. So depending on the character you're working on, this might not be a bad number to work with. Now under this, where it says after bind, maintain max influence, if we leave that checked on, that will say that, okay, you can only have a max influence of 5 or whatever number we specify in this text field. So with this checked on, if we tried to use 6 bones to influence our skin, it's going to cancel out one of those bones. So we want to be mindful of that. And I like to leave that checked on, but it all depends on the character you're working with. Drop off rate, this controls the fall off of our bind. So basically, as we increase or decrease this number, we're able to control the sharpness or smoothness of how our geometry deforms as our bones move. Okay, so we're going to leave that set to a value of 4. So the higher the number, the sharper the fall off, and the lower the number, the smoother the fall off. Now remove unused influences. What this says is that any bones that should not influence your vertices, so any bones that would have a value of 0, let's say, or farther from your selection, will not be calculated as you deform your objects. So it's basically going to remove their influence from your list. Okay. Now, colorized skeleton, what that is does for us is it acts as a helper, so we can see what vertices are being influenced by what bones. So let's go ahead and leave that checked on to see what that does. So now, if we select our skin and just hit apply, notice we're going to get an error message because we need to tell Maya what bones we want to have influencing our mesh. Okay, it doesn't know automatically, so we need to add that to our selection. Typically, what you want to do is select your mesh first, and then shift select your bones afterwards. Okay, and remember we want to use our selected joints for our bind too. So with our mesh selected, we'll go ahead and shift select our bones. Okay, and if you find it easier, you can also do so from the outliner, just adding them to your selection. But I'm going to go ahead and select all of these bones here, and again excluding the tip bone. With that now done, watch what happens when we hit bind skin. Notice a few things update. If we were to look at our bone, for example, we can see that there is a bind pose, and there's also a skin cluster. The bind pose, which we're going to be getting more into, allows us to get back to our default position very quickly that we have bound to. So in this case, if we were to move our skeleton and we were to use our bind pose, we can quickly get back to this position. Okay, but we need to discuss this further because there's some important topics that we want to keep in mind when using it. The skin cluster makes our bones able to deform our mesh. So that's what that does. So watch what happens now with the smooth bind if we were to select our control object and move it around. Notice what type of deformations we'll get. We're able to have our 3D bones act as our bones do in real life. So notice how we're able to deform our mesh based off of how we move our bones. So this is where bones really get interesting. Okay, so here we can see how we'd want to use smooth binding for more of what we'd see in film or cinematics, or even what we'd see on TV. So here's the option we'd want to use for that. Now there are a few issues as far as our bind goes, or our deformations go. Notice how our geometry around our knee is collapsing. Now that is not natural, but we do have ways to edit our influence, okay, or edit how our bones influence our vertices, and we're going to be getting into that. But if we were to just zero out our controls and go ahead and select our mesh, notice, and I'll just go ahead and deselect just so we can see that all of our attributes, our transform attributes, have been grayed out, telling us that they are locked. So this happens so that our bones can completely control our mesh. If they weren't grayed out, what would happen if we tried to unlock them? We'd get a double transform effect, and we're going to be explaining that actually in the next lesson. But we don't want any double transforms within our scene because that causes our deformations to not act right at all. So we'll explore that in the next lesson. But also something to be mindful of, if we select our mesh and hit F8 to go to component mode, notice how our verts are now colorized based off of their associated bones. So what this helps us to know is that, okay, any of these verts that have this brownish color go to this brownish bone. Any of the verts that go to this yellowish bone have more of a yellow color. And for this lime green type of color, we have lime green verts that are associated with it. And for this blue-green color, we have blue-green verts. So this is very helpful, again, for when tweaking or editing the influence between our mesh and our bones. So with this now discussed, our next topic, again, is going to be explaining what happens with when our objects double transform. So we can learn to avoid that if we ever run into that type of situation. Double transformation effects are something we want to avoid in the binding process. So let's understand what they are and look at ways we can avoid them. A double transformation effect is what happens when we have a bound mesh being controlled by a joint more than once. So, for example, what we're going to be doing is taking our character's eyes and having it be controlled by our joint, also being bound. So right now they're just parented to this joint. But let's see what happens when we now take these same eyes and bind them to our head bone. So what we'll do is go to a shaded view. We can hit 6 on our keyboard if we like to see our eyes shaded. And we'll go ahead and just shift select both eyes. And with them selected, we'll go ahead and select now our head bone object. With that now selected, we will go up to skin and use our same settings, bind skin, smooth bind. Now watch what happens if we go to our head control. We can hit 6 on our keyboard again. But watch what happens if we go to our head control and try to rotate it around. Notice how our eyes are moving in an extreme manner. So here's where we see an example of a double transformation effect. So how can this be avoided? Well, it could be avoided in a number of ways. One, when it comes to our eyes, for example, we're probably not going to want to bind them, but rather just keep them with a parent relationship to our bone, since they won't really need to deform at all. So that's one way we can avoid them, to simply get rid of the bind and just have them be controlled by either a parent or some other type of constraint. Or we could go the other route and get rid of the parent connection or get rid of any constraints and work with just the bind. So for eyes, it wouldn't be recommended to do that. You'd want to just go ahead and select both eyes if they were bound and you were getting the effect. Just select them both and go up to skin and select detach skin to remove the smooth bound effect that they once had. So that's how you can also get rid of your smooth bound settings for your object. So if we go back to our head control and move that around, notice we're no longer getting any double transformation effects from our eyes. So that's something we want to be very cautious of when working on our rigs. So we've just looked at what a double transformation effect is, and we've also explored a couple of ways we can avoid them. Let's look at a few ways Maya allows us to edit our smooth skin influences. As stated before, we are able to adjust the way our vertices are being influenced by our joints. So one method we're going to look at is via the component editor, and what we're able to do there is to really put in fine settings for how much influence we would like to have our bones have on our mesh. So let's go ahead and bring our mesh back to its default position. Okay, what we're going to do is go to Window and go to General Editors and go to the first selection, the Component Editor. So here we could do a lot of things as far as not only our bind is concerned, but adjusting weights for other deformers, and even particles. So we could do a lot of things from this component editor, and we have kits that do delve into this subject, okay, for whatever topic that interests you. But here we want to focus on our smooth skin setting. So notice when we get to this tab, when we select our smooth skin tab, we should be able to see our joints that make up our skeleton, okay, that we've bound to. And over to the left side, we'd see a column that tells us the vertices that we have selected. And then we're going to see numbers in here that we're going to be able to influence to either increase or decrease our weighting for our selected bones. And the slider allows us to increase our value as well. So let's go ahead and explore using our component editor. So what I'd like to do when working on binds is set up a few keys that go through the character's default position and then go through the character having the limb deformed to see how the weighting is looking, and it also helps for painting weights, which this process is called. So just shrinking the component editor, if we were to go to frame 1 and at the with our foot control selected, hit Shift W to key our translate attributes, and we can see that if we go ahead and select or reselect the control again after deselecting, we should see keys being set. So now if we were to go to about a value of frame 10, move our leg up, and then press Shift W again to set more keys, now we have this transition from key to key. So what can we do with this? Now we can say, all right, let's try to adjust the vertices at around this point, okay? Because at times we won't want to go all the way to the max and adjust our verts. It might be best to go to a more in-between setting so we can easily select them. So it all depends. But now that we have this, what we want to now do is select the verts that we would like to influence. Okay, so we know that it's the verts around this section here of our character. So knowing that, what we can do is go back to our default position on frame 1, go to our 4-panel views, and let's go into our side view. From there, it's best to work with either your wireframe in this situation, but when painting weights in general, you do want to have your wireframe visible along with your shaded. That's recommended just so you can clearly see where your verts lie and how they're being deformed. But here, let's make sure in our side view that we just are viewing our wireframe so we can see the verts that we're selecting. And we'll hit F8 to go to component mode. And let's go to our lasso select tool again, and we'll select the verts that are being a little bit problematic here. So let's go ahead and select these verts around this area. We'll just grab these in our selection, and we'll deselect some. So let's go ahead and deselect these couple of verts. It looks like one, but sometimes you'll go ahead and select or deselect verts that look like they're just one selection, but they're actually two when we do that from orthographic view. So for example, from our side view. But let's go ahead and even add a little bit more in our selection. So we'll grab a few more of these verts here, just following the path of my mouse. Alright, great. So once we have selected these, notice, alright, now we're able to see values. So the values tell us the weighting that these verts have on our selected bones. Alright, 0 is the least amount of value we're able to have, and 1 is the max value. So you can see that these verts are being mostly influenced by our knee bone. Okay. Now the total here, this must equal 1. So basically, if you had an evenly distributed amount throughout here, your total is always going to be set to 1. So it's basically adding up all of the values that you have here to be equal to this maximum value. So the total, again, is just a summary of how much weighting we have throughout. And again, it's always going to be equal to 1, or should always be equal to 1. So now that we have these verts selected, let's see what happens if we give them a full weighting of 1 for our knee. We'll select our knee top text field, scroll all the way down, and then shift select the bottommost text field and put in a value of 1. Now notice the rest of the verts have been zeroed out, saying that there's no more influence there. We have a full weighting of 1 for our knee. I do want you to also mention, I do want to also note that under options, if you're not able to see all of these categories, make sure that you have hide zero columns checked off. What that does is basically hides any columns that already have a value of 0. Okay, so just make sure you have that checked off so you can see everything if you're not able to. But again, once we have this set to 1, let's go ahead and see what type of deformation effects we're able to get. I'm going to go ahead and minimize the component editor now and go back to the perspective view. So as we scrub through, now notice the deformations are much better than what they once were on our mesh. Now this is looking a little bit more realistic. And right now, even though it looks like our verts are interpenetrating, at times that's fine, and at times that's even recommended because we'll get some nice pinching effects. And we'll even explore that. But alright, so we can see that our bind is looking a little bit better, but notice we're getting some verts that are going a little bit too far because they're having a full weighting. Well, in order to adjust this, here is where we experiment with another tool that Maya offers us for quickly editing our influences. So this is called the Paint Weights tool. So what we can do with this, let's go ahead and go to about where our mesh is deformed at this angle on frame 3, and we'll hit F8 to go out of component mode. So when using the Paint Weights tool, make sure you're out of component mode and you have your mesh selected. So once we've made sure of that, we now want to go to Skin, Edit Smooth Skin, and go down to the Paint Weights tool and go to the option box. So now notice what this does. This shows us the weighting of our verts for each selected bone. Here is the hierarchy or the selection area for our individual bones that we can see. And the white areas tell us the areas that have the most influence, the gray areas that have the more of an even distributed weighting, and the black areas mean that we have no weighting occurring in these areas. So let's say if we wanted to influence our mesh a little bit more so we can have a nicer, smoother effect. Well, we can go to our thigh bone, and here is where we want to adjust some of our settings. What Replace does is it basically goes ahead and gets rid of the weighting that we have for selected verts. So if you ever wanted to remove weighting on an area, you can use Replace set to a value here. Okay. Now what I'm even going to do is just reset our settings so that your settings match mine. So when we do that, we can see Replace is the default selection. Now what Add does is the opposite. It allows us to add onto our vert weight. So basically, if it'll take the vert weight we currently have and continue to add more of a value to it based off of the value we have in our value field. And then we can set our min and max for our slider here, or our value here. So what we can basically do, and what I like to do, is set the minimum to about a value of -1. So what this will do, if I go to add and set that to negative, I can remove influence from it. But what we want to do is add influence to our a few of our verts here to smooth out their position, and there's also, or smooth out their deformations, and there's also a smooth setting that will allow us to smooth out our verts. Now what scale does is allows us to just scale the influence of our verts. So that's what that does. But typically I like to use Replace, Add, and Smooth. So with Add selected, let's go ahead and increase their value just slightly, okay, just so we can add a slight amount of influence. And now once we're ready, once we see our brush, we're now ready to start clicking on our verts, and notice what that does. We are now ready to add more influence to our vertices. Now that might even be a little bit too much, so we can decrease that some more. How about to about a value of 0.04 in our value? Let's see what that does. Now we're able to decrease our weighting even finer. So this is very cool. So we can go ahead and add some more, okay, to adjust that. We'll probably want to adjust these vertices so that they come up a little bit more. So we can do that by now going to keeping Add, but this time going to our knee and just adding more of a weight to our knee vertices. Okay, so notice what that does for us there. Okay, and then we can see what Smooth does. So if we go to Smooth and we just start, notice how our values get grayed out because it's giving a smooth result for all of our verts that we are influencing from each bone. So if we go ahead and set to or select smooth, notice what type of effect we're going to get. It can be very helpful. What's a common workflow is to either add or remove influence, and once you have it generally to a deformation effect that you like, then you could use smooth to get more of a natural or finer result. Okay, so that's what we can use with that. So with all of this done, let's see what we're able to get now as an effect from our bind. If we go ahead and scrub back and forth, notice how this is looking much better than it did before. We're getting a much nicer deformation effect. Now watch this. If we take this leg here, okay, once we have made our controls, once we have bound our leg, if we now take it and we go to our hotbox, again holding spacebar, and make sure that you are showing all of your settings. But once we go here and go to mesh and select smooth, notice how we're able to get a smooth looking leg, and watch what happens now when we select our control and move it. Notice now we're getting a much more natural looking effect out of our character's leg as we deform it. So here is where we really start seeing what we would typically see in either a film or what we see on TV or a game cinematic. So that is how we can utilize our painting weight tools that Maya provides us with. Very cool tools, and they really help to bring to life our characters. So with that now discussed, that is the lesson, and in the next lesson what we're going to be doing is focusing on a way we can take our influence on one side of our character and mirror it to the other side for efficiency. In this lesson, we'll learn how to speed up our weight painting workflow using Maya's very efficient Mirror Weights tool. In this scene, if we were to scrub the timeline, we'll see that we have our left leg lifting up and then descending, going back to a planted position, and then as we scrub past, our right leg does the same. If we look at the left leg, we can see that its weighting around the knee is pretty good. It's corrected. But when we go to our right leg, we can see that, okay, we're getting the default bind or default influence of our weights and the verts for this object. So what we're going to do now is explore Maya's very efficient Mirror Weights tool and see how that can really save us time in this process for redistributing our weights to the opposite side of our character and save a ton of time in that process. So what we want to do is go ahead and go up to Skin, and we'll go down to, this time, Edit Smooth Skin, and go to Mirror Skin Weights. And let's go ahead and open up the option box. So here it is, and we'll make sure we reset our settings. Okay, just so that, again, your settings are going to match mine. So working our way down, the mirror across is similar to how we've mirrored our joints over, if you remember that lesson. So we're also able to now mirror over their influences, and we can specify what axis that we're going to be doing that in. So remember, that's going to be the YZ axis because of the position or where our objects are located. Okay, and again, looking right at our local rotation axis of our scene. So we'll choose YZ. Now the direction determines if we're going to be mirroring on the from the left to right side. So basically the positive to negative side, or the negative to positive side. Okay, so right now with our option checked on, we have it set to positive to negative side. So this is the default, and this is actually what we want to use, because right now on our positive side we have our weights fine, but our weights are not fine on our negative side. Okay, so that's the default, which we're going to use. Closest point, this basically looks at the closest points between our vertices, and it samples between them, giving us a nice smooth fall off as it transfers our weights from one object to the other. So this is the setting I like to use. Raycast, this is what Maya used previous to Maya 8.5, that basically does a raycast and samples our points from object to object. So that's essentially what that does. And also closest component, this was a non-smooth effect for mirroring weights over. It basically looks at our vertices and transfers their weights without adding any more influence or any type of fall off. So that's what that does. But again, let's go ahead and use closest point on surface. Now, for our influence association, what this does, this is pretty cool. Basically, we're able to do mirror weight passes with these. So our first pass, whatever we specify, it would go through, and then we could even choose a different pass if we like, just to seal home our weighting of our objects. So the first one we see here is closest joint. This is the default, as we saw when we reset our settings, but this looks at the closest joint and basically mirrors based off of that. One-to-one looks at our hierarchies, and if they're similar, it will go ahead and mirror our weights over with that. So if you have similar hierarchies as what we have here, since we just have a mirrored effect of our joint chain, we can use one-to-one. Now label goes based off of our joint labels. So if we wanted to, we can label these objects. Okay, we can label this the left side, okay, and leg, and so on and so forth. And the right side we label similar, except it'd be the right side. And then basically look at those labels and say, all right, since you have that set, I'll go ahead and look at your labels and distribute your weights accordingly. So that's another cool feature. What I typically like to use is the middle selection for both, one-to-one. So it's not only going to go over once, okay, with the first association, but then it's going to go back a second time, and it usually happens lightning fast. So with these options selected, what we can do is either select our geometry to transfer all of our weight, or we could specify what points we would like to mirror over. Okay, so looking at the options again, if you were to ever if you were ever curious with how to use the tool, you could always go up to, let's say for example, the mirror weights tool. You could go to edit smooth skin and just mouse over, don't click, but mouse over the mirror skin weights, and there it'll tell you you have to either select a single skin or the source skin and the destination skin. So we can see the description of that right below the command line. So that's just a quick tip if you're ever curious. Okay, so in this case, let's say we go ahead and select our source skin, and then we'll shift select our destination skin, and watch what happens when we click mirror. Okay, so notice it happened lightning fast. Alright, here's our left leg if we were to deselect. Let's see what our right leg does to us. So we'll bring our camera over and scrub, and notice we get the same effect on the right side as what we're getting on the left. So notice how much time this has saved us in this process. Okay, so what one can do as their workflow is just paint weights on one side and then use this tool to finish off the job by distributing those weights on the opposite side. So it's a very cool, very efficient tool, very time saving, and I would recommend using it in your workflow. But that's a look at how we can mirror our weights. The next lesson is going to be the last lesson on our smooth skin settings that we can use, or basically smooth skin tools we can use. We are going to go over how we can add influence objects to add even more to our bind. Now we'll see the significance of using influence objects on our bound meshes. Influence objects are a very handy thing for bound meshes. What they allow us to do is have an extra amount of control over the movement of our vertices that make up a bound mesh. So with them we can simulate a muscle movement or even create the illusion of jiggle effects. So we can manually control that or apply certain dynamics or other deformants to do just that. So what we're going to do in this lesson is basically make this arrow we see here an influence object that will control this arm's bicep muscle. So we can see a very practical use of using influence objects. So what we have here, if we scrub back and forth, what I've gone ahead and did was set up a set-driven key between the elbow we see here that's rotating and the translate X, or whatever direction is pointing outward of this control. Okay, so as we can see, as we scrub back and forth, as we rotate the arm, our arrow is moving, and what is going to happen when we apply the influence object is that our vertices are going to follow along with this arrow. So this is again going to be some very good information that we're going to want to consider when working on our bound meshes. So let's get right into the lesson. What we want to do is make sure we're at bind pose, okay, or going to our default pose that we initially set our bind at. You want to get into the habit of doing that when setting up things like influence objects, so we can quickly get back to a default state very comfortably, or getting back to a default pose. So make sure that you are in bind pose when doing this for that reason. And the way it works, similar to joints, you want to go ahead and select your geometry first, and then you can shift select your object. From there, we want to go to Skin, Edit Smooth Skin, and go to our first option, Add Influence. And let's go to the option box for it. Now I'll just reset the settings here, again, so your settings match mine. And we'll work our way down the list. So geometry, what this is good for is, let's say we were working instead with a polygon sphere for a muscle rather than this curve. Well, we can check on use geometry, and what that will tell our object is that, okay, we want our vertices of the object to follow as best as it can with our sphere, so that they do not, don't interpenetrate. So it tries its best not to interpenetrate with our geometry by maintaining volume. So that's a very cool option to check on. Our drop off, we have an idea of what that does. That basically controls our fall off. Okay, so if the higher the value, again, the harder or the sharper our fall off is going to be, and the lower the value, the smoother our fall off. Okay, now when it comes to our polygon smoothness, what this does is tells Maya, all right, when we're dealing with a polygon object, depending on this value, we're going to try our best to make sure that the verts follow along with the way that object moves. So the lower the number, the less it's going to do that, and the higher the number, the most it's going to do that. And we want to be very conscious of the settings that we're using, because we don't want our scene to really lag. Okay, now there are times when you can avoid that, but that's when things like setting up proxy meshes come in hand. Okay, where we split up our geometry. Okay, as we've been exploring prior to getting to our binding phase. Now, for NURB samples, that essentially does what polygon smoothness does, only it looks at our NURBS objects and it samples them. Now, when we get to lock weights, this is a very handy setting that I really enjoy using. What this will allow us to do is tell Maya, when this influence object is added, I don't want to redistribute my vertice weight onto this influence object. I want to do that manually. Now, you might wonder, why would you want to do that? Well, you may spend a whole lot of time on just making sure the influence of a certain part of your character or object that is bound is just right. And then you can pretty much just throw all of that work out the window if you don't have lock weights checked on. It's going to redistribute your weights, and some areas may be messed up. But what I love to do again is just leave that checked on and leave the default weight with a value of 0. So it says, all right, when we go to add this as an influence object, again, lock its weight so that no weight can be influenced in this category. Okay, and also set it to 0 so I can manually add weights to our verts as needed. So we'll essentially be able to keep whatever influence we have on our verts as is with this setting. So with all of these things discussed, let's go ahead and hit add. And now notice when we select the arrow, it is a part of our geometry. Okay, but as we scrub through, it's not controlling anything just yet. So let's see how we can add some influence to our object. So one way we could do that, if we select our surface and go into shaded view, we can go back to our paint weights tool, double click, so we can get to its options, and notice now we have our bicep control or bicep influence object in our list, and it does have a hold on there. And if you want to turn off the hold, you can either click it from here, okay, and I'll show you another way you can do that from the component editor, but we can turn off the hold on that weight from here. Okay, but we can, if you like, go ahead and leave the hold on and still be able to influence the verts while having this just maintain its values without having any update or any other redistribution. So hold works out great, not only for influence objects, but for bound objects altogether. So we can use our paint weights tool, but one method that I like to use, especially for when dealing with low poly type of models, as what we see here, is the component editor. So let's go ahead and switch to that. I'll just come out of the Paint Weights tool, go back to the channel box, and we'll go to Window, General Editors, Component Editor. And I would recommend you getting a little bit more comfortable with the component editor if you aren't already, because you could do some really cool things with it. And we do have kits that go over the explanation of the component editor, ways you can use it to your advantage. Now, if we right click, go to our vertices, or if you like, you can go to component mode, hitting F8. But either way, what we now want to do is focus on our arrow here. So we'll go also to our wireframe view. In the component editor, let's again find our smooth skin tab. And notice it's in alphabetical order here, so our influence object is right at the front. Okay, and it still has its hold weight. So all we need to do, since we're working with low res geometry here, is take these 3 points that we see here, and possibly even the one adjacent to it, and really add just some slight influence to them, and we'll see what's going to happen to our mesh, especially as we add a smooth node to it. So this is going to be pretty exciting. So what we'll do is go ahead and select these points, or these vertices, and we'll scrub in our timeline so we can move our arrow up. Okay. Once we've done that, now we go to our influence object and move up these verts, so just increasing their weight by going to the slider, left mouse button clicking and dragging on it to increase their weight, just slightly. Okay, it all depends on how much you would like that to increase. Then what you could do is select the outer vertice and have that increase even more, just to get a better illusion of a bicep muscle. And then from there we can take this vertice adjacent to it and just give it a minimum amount of weight, just so it looks like the skin is pulling as we added this influence. So what does this do for us? Well, let's go ahead and see that. If we close out our component editor and we were to go to our shaded view, coming out of component mode, hitting F8 on our keyboard, notice as we scrub back and forth, we have just simulated a bicep muscle. So this is very awesome. Okay, so as we scrub back and forth, because of our set driven key, moving our arrow, notice how we're able to now control the motion of our bicep using that influence object. So here we see the significance again of utilizing it for our bound meshes. So even if our arm was rotated upward, okay, because of that relationship, we can still have our bicep moving the way we need it to. So here we see a collaboration of not only our set driven keys, but using our influence objects. I'm just going to go ahead and undo back the shoulder move. So that's how we can use them. Now watch what happens if we select the arm and we go to our hotbox again and go down to mesh and smooth. Let's see what type of result we get. Well, as we scrub back and forth, notice we have this really nice organic looking muscle deformation. Okay, so you could see also why the component editor would be very helpful for a situation dealing with a low res arm. With it you can get to just a small amount of vertices to tweak. Okay, if we set the division from the smooth node, selecting that from the inputs and put in a value of 0, if we just tweak those really a small vert count, when it goes to adding the smooth node, that can make a big difference, as we've just seen. So if we brought this back to a value of 1, again, you could see the benefits of using it are just prevalent. All right, excellent. So with that now done, that does finish this lesson. We went over adding influence objects, and we went over techniques we can use when adding influence objects. You don't always need geometry. You can use NURBS curves if you wish and really get a nice result. But with this now done, that finishes this lesson, and it also finishes our section on smooth binding. So our next subject to discuss is rigid binding. In this lesson, we'll discuss rigid binding in Maya. Here's where we're really going to see the difference between smooth binding and rigid binding. What rigid binding does is takes all of the vertices that make up our mesh and either gives them a weight of 1 or nothing at all. So we're really going to have the rigid bind speed up the calculation of our bind as we move our control objects around. So that's one of its benefits. But what we're going to do is apply our rigid bind and look at more benefits that we can use the rigid bind method for. So let's go to skin, and we'll go to bind skin, and we'll go down to rigid bind options. And let's go ahead and reset our settings. Okay, so working our way from the top down, our bind to will basically allow us to bind to our complete joint hierarchy, or go to our selected bones, or force all. What that does is not only sets our weighting to the selected joints, but also to any other joints, even if they don't have any influence at all. But we're going to go with selected joints. We'll also check on coloring so we can clearly differentiate between our vertices, which bones are influencing which vertices. Now, for our bind method, we have closest point, or we have our partition set. Now, what the partition set does, which is automatically generated with our rigid bind, but what that does is it allows us to isolate our components so that we have no other influence on them save whatever object is linked to its partition set. So we're going to explore that in our hypergraph. But let's go ahead now and use these options and rigid bind our mesh. So we'll select our mesh and we'll shift select the joint within our chain. Once it's now done, again excluding our toe joint, we'll now select bind skin. Now notice the update. We can see in our outputs that we have a bunch of skin cluster nodes that have come along with each joint in our hierarchy, okay, that we have selected and added to this bind. And we also have a bind post, and we're going to actually get into that after we discuss rigid binding. But now watch this. If we were to go to our control and move along our leg rig, we can see that, okay, we definitely see that our weighting has been set to about a value of 1 or no weighting at all, especially when we get to areas like our knee. Okay, as that deforms, we can see how rigid or how rugged that looks. So again, Maya has taken those vertices that we've added to our bind and have set them either to a full weight or no weight at all. Now, this can be very beneficial for working with game characters. So with game characters, you're going to want them to update very quickly within your scene, okay, so that they don't lag down your game at all, or especially not when working with them in Maya. So in that case, what you're going to want then to use is a rigid bind. And we actually have a way to kind of fake a smooth bind effect on hinge objects. So areas on our rig that would deform as our knees or elbows would. And we're going to experience that very shortly. So let's go ahead and bring our control objects back to a value of 0. We'll select our mesh, we'll hit F8, and we'll select a few of our vertices for our thigh and for our knee area. Now it doesn't matter which vertices you've selected, we're just going to see how this looks in our component editor. So we'll go to Window, and we'll go to General Editors and go to the component editor. Let's also make sure we're under our Smooth Skin tab. And once we're here, we notice exactly what the tool does. So here we only have a complete weighting of 1 or no weighting at all. And we see that from our blank areas. So what would happen if we were to zero out our numbering here? Well, let's go ahead and check that out. If we were to just select our control in object mode and move our control up, let's say if we took one of our verts or vertices and selected one and just put it or set it to a weighting of 1, or 0, you can definitely see what's going to happen. It's going to really mess up our bind because it's attached to this thigh skin cluster. Okay, now when we set it to a weight of 0, it doesn't really know where to go, but it's still going to follow with our rig, just not the way we'd like it to. So if we try to move our object around, going back to object mode, notice we're still able to control our rig, but right now it has been set to the default position of where our leg object once lied. So if we were to zero this out, I'm just closing the component editor. If we were to zero out our thigh, notice it goes right back to its bind pose position. Okay, so that is what would happen if we were to ever zero out our weighting. But I'm just going to go ahead and undo that back so we don't have that type of weird effect. But looking at this rigid bind, it doesn't appear to look too bad on our characters. Now, there are certain times it will, like especially if we take this leg to an extreme, bringing it back, we can see, wow, that is something that we don't want to have happen with our binds. But again, with a game character, it really wouldn't mind, especially with the low poly count we'd be working with. Now, before we close off the lesson, let's go ahead and look at how our partitions look in the hypergraph so we can get an idea of what they are. So we'll go to Window, and we'll go to our hypergraph hierarchy with our mesh selected. And let's go to view our input-output connections. So what we see here are our hidden clusters, okay, that basically have been connected between our joint and the vertices that make up our mesh. Okay, so notice we have a cluster for each of our bones. And now where are our partition sets? Well, we can find those to our right. So here we have a set for our thigh, one for our ankle, and each bone that has been established in our rigid bind. Okay, so that's our partition sets. And again, they hold our vertices so we can link them to our bones. And that is how the rigid bind is able to function. Well, with this now discussed, our next task is going to be to look at ways we can influence our rigid bind. So that's going to be our focus for the next lesson. Let's look at a way we can fake a smooth bind effect on rigid bound objects in Maya. Though rigid binding gives us some really rugged results when it comes to deforming our objects, for example our knee, what Maya has built into it is a way we can actually enhance these type of areas so we could get a more smooth looking effect. Now those objects, or the tool I'm referring to, is called a flexor. So that's what flexors do. They enhance our rigid bound deformation effects. So what we're going to be doing is applying it to the knee to see what type of effects we're able to get and to see if we can really improve this area. So we want to go up to Skin, Edit Rigid Skin, and go to our first option that says Create Flexor. Now, with that selected, we have a number of options that we can choose. We could use a lattice, and we're going to get to that. We could use a sculpt tool, and we could use a joint cluster. So we're going to get to all of these, and we'll start with the sculpt tool. Okay, now by default you should have lattice selected, but let's make our way to sculpt, and we have a number of settings we can choose from. So we can tell Maya to add it to a selected joint or all joints, or to a selected bone or all bones. I'm just going to leave it with selected joint checked on. Next we get down to our sculpt options. This allows us to control the maximum displacement, or essentially the distance that the sculpt geometry tool is able to affect our vertices. The drop-off distance tells it, okay, similar to our drop-off rate that we've been through before, just basically a more fall-off type of effect between our vertices. And then from our drop-off type, we can specify how our drop-off occurs, either linear or none at all. Okay. The next is for our mode. We can either set that to stretch or flip or project, so whichever would work best in our situation if we were to ever use this deformer. And then next we have the inside mode, which basically allows us to either evenly distribute our weighting throughout the verts using this sculpt tool, or just really affect the points inside the sculpt tool, pushing them outside using ring. So if we were to select even and just use these settings here, you can go ahead and adjust your drop-off distance a little bit if you like. We could bring that to 0.14 if we like. And with all of these settings here, we could just hit create just to see what type of effect we're going to get. But we do want to make sure that we select our knee first, and then we can hit create. And now notice what happens. All right, we have this region and where our knee geometry just really bulges out because of this sculpt deformer. So if we wanted to bring this down, you don't want to move the bone. Right now our bone is selected. We want to select the the sculpt deformer that surrounds the geometry. So with that selected, we could go to our scale tool and scale that down to a better size for our knee. So let's see what type of effects we get as we move this. Okay. Alright, notice it's okay, and we may find areas where we would want to use this deformer, but I don't think it's really going to apply to our character's knee here. This locator, this isn't really to be moved at all. Notice what happens as we move it. It just follows along with the sculpt tool. So it's just generated with our sculpt deformer. But that's what that does. Now I'm going to go ahead and undo that. Back before we added that. Let's go ahead and explore our last option, the joint cluster. So we'll select that, again using selected joints, and hit create. Now notice what happens as we use this and deform our leg. If we select our leg object, our control object for it, and move it, notice how we're getting a much better deformation effect. And if you also notice, we're not getting that major interpenetrating that we had before, where our thigh and our thigh geometry was interpenetrating with our foreleg or shin geometry. So this is very cool. And also notice the type of effect we get from our knee. Very nice looking for a rigid bind. Okay, so now we're really being able to get that knee bulge utilizing this tool. So we can see where this can come in handy for not only knees but elbows as well. So that's what the cluster does. Now the one that I find most commonly used is the lattice. So let's go ahead and use that. Essentially, we're able to make a lattice on our bone and have that act as, again, an enhancer for our deformations for the rigid bind. So we can adjust our settings here, okay, as far as our S, T, or U divisions, okay, and we know what those do. And we can specify if we'd like it to go to all joints or all selected bones if we wish. And the position, we're going to see what that does. Notice what happens if we just hit create. Alright, we get this rather large lattice, and it doesn't seem to be facing in the right direction. Alright, if we try to deform this, okay, notice, alright, that's not looking bad at all. That's actually looking pretty good using the default settings. But if we undid that and said that we wanted to, let's say, reposition this lattice, oh, notice what's going to happen. Because of that lattice being tied where it is, it's going to be controlling all of those vertices. So how can we reposition it? Well, that's where position the flexor comes in. So if we undo the lattice, select position the flexor, and then hit create, Maya is going to give us the opportunity to shrink this by scaling it down, and we can even rotate this if we wanted a better angle here. Okay, the angle that we were actually working with was pretty good, but if we ever wanted to rotate this a different way to see if we could get a better result, we can sure do that. We can even move it back. But once we deselect, when we reselect, we're not able to do it again, because notice how now that lattice is affecting the geometry. So if we go to our foot control and move this around, notice what type of deformation effects we're able to get. So a lattice and the cluster seem to have been really nice results to use for things like our knee or elbow deformation areas. Well, with all of this said and done, that is how we can enhance our rigid bound effects for deformation areas. So with this all said and done, the next lesson we're going to spend the time looking at a way we can copy and paste our flexors to speed up this workflow. In this lesson, we'll learn how to edit and copy flexors. Within this scene, we have a default flexor, a lattice flexor, and I do want you to note that the wider the flexor, the better fall off we're going to get on those deformation areas. So that's just something to note. You'd probably want to leave it at a larger size so you can get a better looking effect. But we are able to edit our flexor settings. So notice with our flexor selected, we can come down to our shape, and notice it has several options we can choose from for our flexor. So if we like, we can adjust the creasing, and notice what that's going to do to areas like our knee or even elbows. That's going to allow us to get a nicer, more defined joint. Okay, so in this case, it's really helping our knee as we decrease this value. Now what rounding is going to do is even enhance that effect, so we can really define the character's knee, for example, or elbow. So what we're going to do for creasing, let's just go ahead and give that a number of negative 0.6 to almost round that off. And then for our rounding, I think 1.3 is working well for us, so we can leave that as is. And now let's explore our other settings that we have. The length in, notice what that's going to do. That's going to either push our vertices in or out. So depending on what type of effect you're looking for on your character, you can adjust these settings. Length out, that is going to push our vertices up and down. So we'll probably again want to leave this set to 0 as well as our length in. Okay, that works best for this situation. Now for the width left, that's going to push our vertices either more to the left. It will push them slightly to the right, but it's going to favor more of the left direction as we increase our value. Notice it does have a limit to it as well. But let's go ahead and leave that to 0. And width right is going to do the same except push our vertices in the opposite direction. Okay, or the right direction, our right. So that's what these settings do for us. And again, I think that just leaving these set to 0 except for the first two, creasing and rounding, would be best in this situation. So now that we have this, let's work on copying and pasting our flexor to the other knee. Now I do want you to note that this is only for lattice flexors. It won't work for our cluster flexors, nor will it work for our sculpt flexor. But what we want to do is first select our flexor, and then we will shift select where we'd like it to be pasted to. So that is our other knee bone. With that selected, we would just go up to Skin, Edit Rigid Skin, and go to Copy Flexor. And notice our values are even copied over, and if we were to scrub in our timeline, we can see that it is preserving our knee just as it is on the left side. So this is really cool, and we still have the option of selecting this flexor and editing its roundness or creasing. So let's say we brought even this rounding up just to make it a little bit different from the left side, just really defining this knee a little bit more. All right, excellent. So we can see how fast that's going to be when it comes to fixing these type of areas. Great. So with all of this done, let's say if we no longer wanted the flexor anymore. Well, we could simply select the flexor and hit delete. Notice our vertices are going to be fine. Okay, it's not going to mess up our bind at all. It's just going to bring it back to its default setting. Okay, but I think it'd be best to have that lattice back on. Now, it's probably going to be best to just reapply it rather than undoing. Okay, and also to note, when we are copying our flexors, make sure we're in our bind pose or default position or original position that we have bound in. That is our bind pose, and we're going to get more into that for our binding procedure very shortly. But we do want to make sure that when we copy our flexors over, okay, or pretty much when we're working on our character and we're doing things like copying our weights over, that we want to make sure we're first in bind pose, because that's going to allow everything to redistribute comfortably. But again, when we want to copy and paste our flexors, it's probably going to be best to just reapply it rather than undo. I try to avoid undo just in case, just to try to avoid any type of issues. So with the lattice selected and then our knee selected, we go up to Skin, Edit Rigid Skin, Copy Flexor. And then again we can come to our rounding and bring that value up to about 1.9. Notice it's not going to adjust until we really start seeing the deformation effects. So that is how we can edit our deformers. That's how we can copy and paste our deformers, and we know that it's only for our lattice deformers. And that's also how we can delete our deformers as well. So what would be nice to do next? Well, simply to give this a name so we can organize within our scene. So we can select the name of the left flexor, copy it. Notice it's already named, and we could simply paste it. And then switch our L to an R. All right, wonderful. So that's better, much more organized. Okay, and it looks better within our outliner as well. If we were to go ahead and find that flexor, we can see that our lattice flexors are grouped. But if you're looking for your other flexors, simply go to the bone that it is connected to, and you'll be able to find it within your hierarchy. But that is how, again, we can copy our flexors over and ways we can adjust them to get much better effects. The last rigid binding tool we'll explore will allow us to modify our meshes without affecting our bind. If we ever wanted to come back to our mesh even while it was bound and tweak out our vertices some more, let's say increase our forearm, which we're going to do in this lesson, we wouldn't want to do that while our mesh was bound. But with rigid binding, Maya has a very cool tool that allows us to tweak out our meshes while maintaining our vert weighting or vertice weighting. So let's go ahead and explore that tool. If we go ahead and scrub through our timeline, we can see what we have. Just an arm bending back and forth. But let's say again, if we wanted to go ahead and increase the forearm, make it more buff. So what we can do is first go to our options to detach this skin. And that's under Skin, Edit Rigid Skin, and Preserve Skin Groups. Here we see a whole bunch of options, so let's go ahead and rip off or tear off this panel or this menu, okay, just by selecting those dividers, left clicking on them. But once we get here, we have a number of options. The first two are going to allow us to detach our skeleton, so that's all of our joints, just so that we can tweak out all of our verts or vertices. Or the next detach option we have is just for specifying a bone to detach. So in this case, we can detach our forearm bone. Then we have the option of reattaching to our skeleton or reattaching to our selected joint. So what that's going to tell Maya is, okay, you're done tweaking. Now I'll go ahead and allow your bones to again affect your mesh while preserving the adjustments you made to your model. So this is very cool. So let's go ahead and explore using the tool. If we go ahead and select our forearm bone and detach it, so we'll detach our selected joint since we don't want to affect our whole entire skeleton. Notice what's going to happen when we select our mesh. Notice now it is no longer locked. But if we go to a bone, any bone, we can see that there's still an influence there because of the color of our wireframe. But if we went to our arm and moved it around, you can see, all right, our forearm vertices are not being affected, okay, because Maya's going to give us the opportunity to fix those if we need to. So I'm just going to undo back. And also something very important to keep in mind about the tool is we want to make sure we are in bind pose when doing this. So make sure you're at your initial state that you bound in. But getting right back to the tool, let's say we now go ahead and go to our forearm and affect its vertices. So let's say we just really increased our verts. And I'm just going to take these vertices and shrink those down just a little bit more because I have to have some pride in my work even though I'm not necessarily a modeler. Alright, so I think here would be fine. Great, so from here, can hit F8 to come out of component mode. And now we need to work on retaching this joint. So all we need to do is select the joint again. But watch what happens when we go to reattach selected joint. Make sure we are at bind pose or frame 1. And we'll select that. Notice how our lattice deformer or our flexor has really been skewed. Well, we need to be mindful of that. If we undo back that and we then select reattach skeleton, what that's going to do is allow us to preserve our flexor while still allowing us to keep the modifications we made to our mesh. So we just want to be mindful of that when using flexors. But with that, we have gone ahead and added an adjustment to our mesh while still preserving our vertices with Maya's very cool Preserve Skin Groups. And we know what those tools do for us now. So with this discussed, that is the lesson. In this lesson, we'll discuss the purpose of Maya's bind pose node. Let's see if, as we were testing out our bind, we select this IK handle and move it up and down. Let's say if we wanted to do that to test out our deformations for our bind, whether smooth bound or rigid. And then for this example, for our rigid bind, let's say we said to ourselves, okay, we need a flexor for this knee. Well, let's go ahead and add a flexor to see what's going to happen with it in this angle, okay, with our IK handle moved. We'll select our knee bone, go up to skin, and go to edit rigid skin and add a flexor. Okay, so we'll just use the default lattice and hit create. Okay, I don't even want to see what's behind this window. If we go ahead and close out our window, we can see, wow, our mesh has exploded. That's because we didn't add this connection at bind pose. So here's where we're really going to see the benefit of adding or going back to bind pose prior to making our connections. If we go ahead and undo that flexor, what we can now do is select our bone object, and with that selected, we can go to skin and go to bind pose very comfortably. Notice our leg goes back to the original position it was in when our leg geometry was bound to our joints. So what does this mean? Now we can do connections like our flexor. We can select our knee again, go to skin, edit rigid skin, and create a flexor, again with the lattice. Okay, and now notice there's no exploding. Everything has been made just fine. And if we go to our IK handle and move that around, notice the flexor is comfortably back to the position it should be in. Our knee geometry is fine. There's no exploding happening at all. So those are some things we want to be mindful of when working on adding connections to our rig. First, make sure that you're in bind pose so you can have a comfortable workflow. And even with this flexor attached, we can go to our leg and still comfortably go back to bind pose with it if we ever needed to do anything else. Now, I'm going to go ahead and undo a few times so we could bring back the IK handle to where it was at in bind pose. Okay, just so it's back to the floor, so we can experience something else. Let's say if with our IK handle selected, we go to our attribute editor, either hitting Control A to get there very quickly, or going to our icon. But either way, what we want to do is make sure that stickiness is turned off. Watch what happens when it's turned off. So we'll just turn on sticky, go back to our channel box, again hitting Control A from the attribute editor, or going to our icon. Then we can lift up our leg again, and let's say, alright, I'd like to add that flexor again. So let's go ahead and select the leg, and go to skin, go to bind pose. Notice we get an error message, and I'll do it again if we hadn't seen that. We get an error message, and it's basically telling us to look at the script editor because it's given us some reasons why Maya thinks our bind pose is not working. But we know why it's not, because we've added sticky to this IK. Basically, it has constrained or locked our bones in this pose, so we can't go back to our bind pose. So we need to free them up by making sure our IK handle has been set back to stickiness off. So that's something you want to be mindful of. Also, other bind pose limitations, if I just go back to the channel box, notice now quickly we can get right back to our bind pose very comfortably. But other bind pose limitations are such things as constraints. If you were to add constraints onto your bone objects, you can run into some hassles where you can't go to bind pose, or if you had any expressions as well you were working on. Now, to avoid that, what you can do is go to modify, evaluate nodes, and here is where you can turn off the or turn off or activate certain nodes. So we have IK solvers, constraints, expressions, all of these. So if you ever are working with constraints or working with IK solvers that are giving you a hard time, or even expressions, what you could do is come to evaluate nodes, and what I like to do is just ignore all. And notice what's going to happen. All of these nodes are going to be turned off, so we can comfortably do things like go back to our bind pose. And once you're done with your connections and you're ready to work with your rig again, you can simply go to evaluate all. So if we tear off this menu and select evaluate all, notice how that's going to update, and now everything is going to be working as it once did. So that's just something you'd want to keep in mind. Also, you can, Maya has a new feature that will allow you to go back to multiple bind poses, and that's simply selecting your mesh and going to skin and go to bind pose. So this works great for having multiple binds on your leg, meaning let's say if you detached your skin for whatever reason and you rebound, you can have a different type of a bind pose. Notice if we select our leg here, we have a bind pose 3 attached to this. That means that I've gone ahead and done that 3 times. Well, what does this do for us? Well, if we were in a different pose, and we're just going to use our default bind pose for this example, but if we were in our default pose and we selected our skin and we went to skin, go to bind pose, we can specify what bind pose we'd like Maya to go back to from just selecting the skin object. Now this only applies again for multiple bind poses. If you just had one bind pose and you tried to do that with the skin selected, you would get an error message. But that is Maya's bind pose node, and we also went over ways we can avoid any bind pose limitations. So with this all said and done, that finishes this lesson. Maya actually gives us the capability to transform or morph an object shape into another object shape. These type of shapes are called blend shapes. As stated in the intro, we're able to deform an object into another object using our blend shape tool. So this is very cool, and it's commonly used for facial animation. So we're going to be able to get some fun facial animations and then be able to either use sliders to adjust them and set keys, or what we're going to be able to do is make control objects that drive those blend shapes by set driven keys. So let's go ahead and learn how to make a blend shape. What you want to do, and what we have here, is just a bound head. If we go ahead and select our character, we can see that there's even some animation on it as well. Okay, but we have this bound head, and with this we're going to be able to learn some techniques that we're going to want to keep in mind when we apply blend shapes onto our bound meshes. So with our object selected, which is our head, what we're going to do is duplicate it, but before we do that, let's go ahead and also grab his eyes. Now why would we do that? Are we going to apply blend shapes to the character's eyes? No, the eyes serve as reference. So if we were ever working on eye blend shapes, what we'd want to do, or what we'd want to get into the habit of doing, is selecting our eye geometry too, just duplicating those to act as reference so we can know how our skin around the eyes should deform. So that's just a tip to keep in mind. But with our head selected, we'll shift select the eye geometry and hit Control D. Now what we saw before when we duplicate a bound object is that the transform information is going to still be locked. It's not noticeable here. We can go ahead and find what we have selected within our outliner. Okay, and here is our duplicated head. If we were to select that, notice how it is it has its connections locked. So one thing we could do, let's go ahead and undo to make sure we have our duplicated eyes still selected. We could just select all of these channels that are locked, even though they don't appear to be locked. That's because we have our left eye also in our selection, or added to. So we can't necessarily see what's locked, but we know it's locked. So Maya will allow us to still select those channels, right click, and go down to unlock. Okay, so unlock selected. So once we've gotten there, now we're ready to take our move tool and move our objects. Now if you're ever moving an object and they're going all over the place, one is going up, one's going down, and one is following your mouse, well, you just want to make sure that you are moving with a world. So if you ever run into that, you can just hold W on the keyboard, hold the left mouse button, and here's another way we could get to our options for the transform. So notice it's at a local right now, but again, you may run into situations where you're getting that type of effect. So just simply use the world transform tool for the move tool and you'll be just fine. So that's just another tip. So once we've done that, we could go ahead and move our character's head over. Now another thing we want to do, we don't want to just start making our blend shape just yet. Watch what's going to happen when we select our head and move that around. Notice because of our eyes being parented to our bone, which is being driven by our control, what's happening here is that there's a connection still between these eyes that we've duplicated. So a fix for this would be to simply select those eye objects and unparent it just like the head geometry is. So we could select the eyes and hit Shift P to unparent. And now here are our duplicated eyes. Wonderful. So as we move our control around, we could even scrub back and forth on our timeline, and now there's no connection here. Alright, excellent. Now, just FYI, you shouldn't delete history on, or excuse me, you shouldn't freeze your transformations for your blend shapes. And we have settings where we'll look at to understand why. But when you freeze transformations, what's going to happen is as you apply your blend shape, that blend shape head is going to go back to the world position or the origin from where it was duplicated from, which is our base head. So you want to be mindful of that. Okay, so it's okay to delete history on our blend shapes unless we have connections that we need on them. Let's say if you tied one blend shape into another and you want that blend shape that has that connection to be tied into your main shape, you can have connections as that, but if you delete history, you'll remove all of that. So you want to be mindful of that too. Okay, but let's go ahead and work on our blend shape so we could also learn a few of the terms involved. So now that we have this, let's go ahead and work on our shape. What I like to do, we'll just deselect, is go to shaded and go to wireframe so we could see the points that we're working with. And for quick deformations, what I really recommend is the soft modification tool of Maya. That will allow us to get some really nice fall-off effects as we tweak out our object, so we could get some nice organic looking fixes very quickly with it. I wouldn't use it most of the time, or excuse me, all of the time, but just most to get those major shapes blocked in. So the blend shape we're going to be working on is just an eye squint for both eyes. So we'll just focus in on our perspective, making sure our soft mod tool is selected without selecting our geometry so we can tell Maya where to apply the soft mod. And we'll start with the right eye. We'll just select above the eye. Okay, and if you need to, you can hold B on your keyboard and that will get to your brush size for the soft modification tool. And with that, you could hold the left mouse button and drag in or to the left or to the right, depending, to either increase to the right or decrease your brush size. Okay, but let's go ahead and bring it to a good size so we can just start bringing our vertices down. And then we could go to the inner eye. We're just doing, again, a really quick eye squint. And if you're interested in blend shapes, we also do have a training on how to make blend shapes for facial setups. Okay, and then later what we do is take that very same rig and learn how to do facial animation. So if you're interested in those topics, we do have training on those subjects. But I think that would be fine for this eye squint. Okay, if we wanted to, maybe we can make it a little bit more exaggerated, just so that it's more prevalent. Okay, so just change the brush size a little bit more, bringing down the eye squint down. Not too necessary, but if we want just a more noticeable eye squint, we can do that. Alright, excellent. So now we can definitely tell that we have our character squinting. So we could do the same thing for the left side. And the reason why we're doing them on both is because we're actually going to use the Blend Shape Paint Weights tool and see what type of fun effects we're able to get using it. So we're going to be getting into that topic very soon. So we'll just adjust our eyes. They don't have to be exactly like what we did on our right side, and actually it's better if we don't do the exact same thing at times. The reason why is because our face in real life is more asymmetrical than symmetrical. So if you want to get a more realistic looking effect, you can add a slight offset to your deformations. Okay, so I think this is just about done. Maybe we could go back to the soft mod tool and just bring up the geometry just slightly here. Okay, so that'll be fine. Alright, so once we have modeled out our shape, now we're ready to apply our blend shape. So we select first what is called our target shape, followed by shift selecting what is our base shape. So even if we had multiple shapes, we would first select all of our target shapes in the order that we'd like them to appear in our blend shape window. Okay, that we'll also be checking out. And then shift select our base head shape. Okay, so with our base head selected last, now we go up to create deformers and we go to blend shapes and we go to the option box. And let's make sure everything's reset. So here we can label the blend shape node. So we could call this face shapes 01. For the envelope, that's basically the weight of our blend shape, how effective it is. The origin, here's where we were discussing our target shape going back to its origin or original position. If it's set to local, we'll be fine as long as we don't freeze our transformations. If it's set to world, the head's going to move right back to its original spot. So we want to be mindful of that. In-between shapes are pretty cool for when doing stuff like morphing your blend shape into a series of actions. So let's say if you wanted the face, for example, to bubble up a bit, what you can do is create several target shapes, okay, with different poses, and then you would tie them all back to this blend shape and use in between. And what that's going to allow you to do is combine all of your blend shapes into one attribute, so that as you move that one attribute, you'll be able to target through all of your blend shapes. Okay, so you only get one attribute with this in between. Now, check topology, we're going to leave that checked off because we're going to have our just an attribute for this blend shape. But check topology, what this does is it looks for our topology that we're using for our blend shape and says, okay, if you would like, I will make sure that they both have the same vertices, or just double check to make sure that they have the same vertice count, so that we can smoothly add the blend shape. And I would recommend using blend shapes that have the same type of topology or same vertice count. That's going to allow your blend shape to run much smoothly, or much smoother. Now, delete targets, what that's going to do, if we check that on, it's going to delete our target shape and just give us the baked information of that blend shape. So we're able to delete our blend shapes after they are made very comfortably. But what's going to happen is, if we want to go ahead and go back to tweaking the blend shape, we're going to lose the history information between the two, and therefore it's going to make it much more difficult for us to go ahead and tweak out a certain shape. Okay, so we're going to leave that checked off. Now, with all of these settings set, we can hit create, and notice what happens. We get a blend shape node right on top. So if we go to this node, watch what happens. Okay, just selecting our head. If we go to the node, okay, just selecting blend shapes again, we can go to the character's head and move the blend shape, and notice what happens. Now we have the same squint that we made over here for our target shape. And this action that from blending between our base head and also our target shape using this is called the blend shape. Okay, so this is what the blend shape actually is, morphing our base head or base object. Excellent. Now, here is one way we can move our blend shape. Another way is to go up to Window, go down to Animation Editors, and go to Blend Shape. And notice this window appears, and this is going to show us all of our blend shapes for each node. And we're going to get into also adding blend shapes as well, because we need to definitely discuss some important topics when it comes to that. But notice if we adjust this slider, we're able to also adjust our blend shape from it as well. And we're also able to animate it with it too. Now, what's recommended when working with blend shapes is to give them a label, just to make sure that you are being organized with your names, because there'll be times where you're working on several shapes and you're going to want to know what each does. So this one we can call our B shape underscore squint. So that's just an idea, okay, to just stay organized. Okay, and it also updates in the channel box too. But that's how we can create blend shapes. But let's notice something. What's going to happen if we move our head? Well, notice, all right, our head seems to be moving fine. Let's see what happens when we activate our shape. Okay, what has just happened here? Well, we originally had our head following our rig until we activated the blend shape. So we're going to understand why that has occurred in the next lesson. In this lesson, we will discuss deformation order. Continuing from our last lesson where we discussed our blend shapes, we saw that when our blend shape wasn't activated, our rig was moving along fine, controlling our mesh points. But once we activated our blend shape, again selecting the object that has it, the node, and going to our blend shape node and activating it, putting in a value of 1, we saw that it disabled our blend shape. Well, why is that? That's because of our input list. Our blend shape currently is in the wrong order in this input list. So we have a number of ways of fixing this. We could either manually do this, or what we can do is adjust our create blend shape option so we can avoid this problem altogether. So let's go ahead and explore both methods, and we'll go through doing this manually. And I do want to also mention that if you were working with an object that didn't have a bound mesh, this more than likely wouldn't be a problem. But if you're still experiencing difficulties, you should go ahead and check out your input order list to make sure that it is at the correct has the correct order. So to manually do this, we just select the head that has the incorrect list, right click, and go down to Inputs and All Inputs. So with that selected, a window should appear that gives us our input list. So here's our blend shape at the top, and we're going to need this to be between our skin cluster and tweak in order for this to work as we need it to. So whenever adding target shapes, okay, to your node, or whenever adding blend shape nodes, I should say, you want to make sure in order for them to be activated to add them again between the skin cluster and the tweak. And we're also going to discuss whether we should add several target shapes to one node or several nodes for each shape. Okay, so that's going to be discussed in the next lesson. But getting right back to our lesson, in order to switch our list, we simply would middle mouse button click on our blend shape right at the top and then drag it on top of the skin cluster. And notice that fixes our order. It's not updating in the channel box yet until we select our object, but our order has been shifted. So if we close out our window now, and if we reselect our head, we can see now the channel box has our updated list. And as we scrub through our animation with our blend shape activated, notice now it's moving along just as we'd like it to, with the rest of our mesh, as it is controlled by our bones. So that's something we want to be mindful of. Now, another method of doing this is to adjust this from our Create Blend Shape options. So let's go ahead and explore that. So we'll also get into how we can delete our blend shapes too. First off, let's figure out how we can delete our target shapes. If you'd like to do that, you would just select your target shape followed by the base shape, and you go to Edit Deformers, Blend Shape, and go to Remove. So we can open up the option box, and here we can either specify or tell Maya to delete all target shapes in one node, or if we had several target shapes for one node, we can specify what node we'd like to delete out of all of those target shapes if we just wanted to delete one specific shape. And we'd want to make sure that all of our naming is exactly as how Maya has it in its input. Okay, so we want to spell it correctly. Also to note that if you were dealing with several nodes, if you wanted it to update automatically for the blend shape node area and you don't see the name within here, you could just go ahead and drop down the list and select the name. And if it still doesn't update, you can just type in the name exactly as how it's spelled. But since we're going to delete just our target shape, we can just hit apply. And notice, if we go to our blend shape node, the node is still there, but the target shape isn't. So this is for deleting our target shape. But what if we wanted to get rid of the node altogether? Well, we can do that. Let's go ahead and close out this remove window. What we do is select the object that we have the blend shape node to delete, and we could go to Window and go to our hypergraph. Once there, let's go to our input-output connections, and we'd simply find our blend shape node. So here it is. We can select it, and here we see it within the channel box. So with it selected, we can simply hit delete on our keyboard. And now notice it's gone. Okay, nothing has messed up. Our blend shape and target shapes are still there. And if we select our head, notice that the blend shape is no longer there. So that's how we can delete both our target shapes as well as our whole node altogether. But let's go back to creating our blend shape and fixing our order. So we'll go ahead and select our target shape and head. Go back to Create Deformers this time and go to Blend Shapes and go to its options and make sure that they're reset. So from here we'll put in our name. We can call this face underscore shapes 01 as we've done before and leaving everything. But now we want to bring our attention to advanced. Okay, so we have a number of options here. By default, you may see default selected. What that is going to do, we saw what that already has done. That put our blend shape at the top of our list in our inputs. So that's what default is more than likely going to do. And before, that works the same way. It's going to put our object right in front in our list. After, it's going to put it after within our list. Split, what that does is it basically sets up two inputs connected to our one base head. So that's essentially what that does. Parallel will do exactly what it says. It will put our inputs together between our blend shape objects. But here's where we want to focus, our front of chain. With that selected, notice what happens when we hit create. Now, our blend shape is in its correct order, right between the skin cluster and tweak, automatically. So that's how we can do that without running into the hassle of manually adjusting our blend shape. And now notice if we were to select it and activate it, put in a value of 1, okay, it's working fine, and as we scrub back and forth, it's still working fine. So with this now discussed, that is how we can adjust our deformation order, and this comes in handy especially for working with other deformers like clusters, for example, and we'll be getting into those type of deformers. But you want to be mindful of that when making your connections, because that's going to make a difference whether your blend shape is going to work or if it's not going to work. But with that now discussed, our next topic is going to be how we can add blend shapes, and that's going to be important because we need to know some things that's going to improve the way we rig our characters to have blend shapes. Now we'll learn of ways we can add blend shapes in Maya. Within this scene we have a couple of blend shapes, one for our mouth and one for the eyes. What we're going to be doing is exploring a couple of ways of adding blend shapes, one that will generate two nodes for each of our targets, and another that is going to allow us to add blend shapes to one existing node. And we're going to see which one is going to work best for this situation, and we'll also get an idea of where this can be applied for other situations while in our rigs. So we'll start by just applying our mouth shape first. We'll select the target shape followed by the base head, and then we'll go to create deformers, go to blend shapes, and we'll give this a name. We could call this mouth shapes in case we were to ever add any target shapes to this that had to deal with the mouth. So mouth shapes 01, and then we'll go to advanced and double check to make sure that it is set to front of chain. So as we hit create, it automatically is in the right order. Great. So as we go to our mouth shape and activate it, there it is. We have a nice little smile there. And then as we scrub back and forth, notice the smile blend shape is following along just as needed. Excellent. So let's say we now go ahead and apply our eye shapes. What we can do is just cancel out our mouth shape right now, just putting in a value of 0. And then we'll select our eye shape followed by our base head, again target to base, and then we'll go up to create deformers again and go to our blend shape options. Now we could call this node the eye shapes, eye_shapes 01. Again, double checking advanced to make sure it's front of chain, which it should be. We can now hit create. Okay, so now we have two nodes. So let's see what happens if we just go ahead and activate our eye shape. We'll just put in a value of 1. Alright, notice it's fine. If we go ahead and move around our rig, yes, it's following properly. But watch what happens when we try to then activate our mouth shape. We'll go to our mouth attribute and middle mouse button click and drag, and notice it's canceling out our eye shape. So as the smile shape is activated, the eye shape is again being canceled out. Well, why is that? This is basically telling Maya, when we add two nodes, it tells Maya, okay, I'm going to use one or the other, but you're not going to be able to have a blend of both with this type of setup. So depending on what we're working on, what type of rig, this might be best in that given situation. But for facial animation, you're going to want a blend of things like eye movement and mouth movement, so you can get some realistic effects. So let's go ahead and undo back and explore a way we can add blend shapes, which is going to be a better solution for things like facial animation. So I'm just hitting Z to undo back before we added our mouth shape. And if you run out of undos, you can always delete your blend shape nodes from the hypergraph. But once we're back to our base head, no blend shapes, we'll start again by adding our mouth shape. Okay, so we'll select that target shape, select our head, and go to create blend shapes. And let's go ahead and label this the face shapes 01. since this is going to be, we're going to be able to add our shapes onto this. So this is our node name, and our target name is whatever name that this target shape is. Okay, so once that is there, and once front of chain is selected, we can hit create. All right, wonderful. So we have our mouth shapes. Okay, we know that that's working fine. But now let's see how we can add our eye shapes. Well, again, we could go ahead and just deactivate our mouth shape. And now we'll select our target shape for the eyes, shift select our base head, and this time, instead of going to create deformers, we'll go to edit deformers. We'll go down to blend shape, and we'll go to the add blend shape options. So here we have a number of options. We can specify a node we'd like to add our blend shape to. So in this case, we want to use our face shape. So let's make sure we check that on. And Maya is going to update our list with our current node, blend shape node. And you may need to, if it doesn't update, just to type in the name or go down the list and select it. So that we're going to want that checked on so it knows what node to add it to. Add in-between targets. We know what in-betweens do. They allow us to have one attribute that controls our blend shapes. Okay. Now, what this is going to do is take our existing target and add another target on top of that. So that's what this would do. Okay. If we had the in-between checked off in our create blend shape options. And we know what the target shape options do. Okay. Check topology. That's going to tell Maya, all right, do these share the same vertices? Well, if so, then we can go ahead and I'll go ahead and double check that for you. And remember, we want to use the same topology when we're doing our blend shapes, or at least the same amount of vertices, so we can get a nice even effect. All right, so once we have all of these options set, now we can hit apply and close. So notice what happened if we go to our target shape. Okay, selecting our head and go to our node. Notice we can get to our smile, and if we go to our eye shape and activate that, notice what happens. Now we're able to get a blend or a mixture of our eye shapes as well as our mouth shapes. So that is a very cool feature. So again, this is most popular use for doing things like facial animation. This is what type of setup we're going to need to get those realistic type of effects. So that is how we can add our blend shape objects. In the next lesson, what we're going to do is explore painting blend shape weights onto our base mesh. Let's look at some fun things we can do with painting blend shape weights. Maya allows us to either increase or decrease the weighting that our blend shapes have on our object. So we'll see what type of fun things we can get into using that. One option we have is going to the component editor. Okay, so if we selected our blend shapes, selected our vertices, and deselected the ones in the back. Okay, it doesn't matter which ones we select, just the ones that we have tweaked in this blend shape. Okay, so we could just marquee select and deselect any others. But if we do that, and going back into a shaded view, hitting 6, if we go to Window, go to General Editors, and go to our component editor, notice we see the weighting that our blend shapes have. And they're going to have a full weighting on all of our verts since we added the blend shapes to our entire object. Okay, but if we were to ever zero any of these out, we'll see that we're able to control the intensity of our blend shape. So if we wanted to, we can zero some of these numbers out and go back to an original position of these vertices. Now we do want to be mindful that if we try to do this and we don't like our values, we can go ahead and select the vertices again and give them a full weighting again, or whichever we like, but it's not really undoable. So you want to be mindful of that. But that's what we could do from the component editor. And notice it's the tab. If you're looking for it, it is right after the rigid skin and before the smooth skin option. So we have our blend shape deformers tab. So that's what we can do here. So I'll go ahead and close this out. Now another way we can paint shapes, which is pretty effective, is the blend shape weights tool. So if we select our object, we can go to edit deformers and go down to the paint blend shape weights, and we'll go to the option box for it. With that open, okay, now we see what type of weighting that our blend shapes really have on our object. Notice we have a full weighting on both. And our other options are very similar to our paint skin weights. So this tool is essentially the same as our paint skin weights, except now we're controlling the intensity of just our blend shapes. So let's say if we wanted to go ahead and decrease the amount of weights we have on one of our eyes so that it almost gives us a squint. Well, we could go to our smile shape, or excuse me, our shocked shape for our eyes. And here we have several options. Okay, and we could even reset our settings just so that your settings will match mine. So we can use replace, set to more of a negative value. Okay, so if we put in our min value here of -1, we have more control over the intensity at which we're able to replace. And that also applies to opacity. We can either increase or decrease that for the intensity of our tool as well, of our brush. Now, so if you wanted to, you can bring this to about a value of 0.8. Okay, and it all depends. You might even bring it to a lower value if you want to get some really fine control. Now we know what replace does. That will replace our weighting. Add will allow us to continue adding weights on top of our vertices, just like similar to the paint weights tool for our skinned objects. So it's going to keep adding or subtracting weights based off of our value. Now that can be good or bad, because with it we're able to continue to either increase or decrease influence. It's not going to bring us back to a default weight. So replace is probably going to be best to go with. But scale will scale our values, and smooth will give us an average result throughout the vertices of our blend shapes. So let's go with replace, and we can set our replace amount to about -0.05. Okay. Now if you're curious what clamp does, that basically allows us to have a limit as far as how much we can paint weights, if for our values, that is. So if we had it set to upper and then we put in a value of 0.8, it's not going to allow us to paint weights anything greater than that value 0.8, even if our value here was greater than the upper number. And same thing applies with the lower, except it's for limiting for our lower values. So we wouldn't be able to paint anything lower than what is in this text field once this option is checked on. And flood is going to evenly distribute our amount based off of our value. So we once we've gone through these tools, we know that we'd like to decrease some of the weighting that we're getting for our shocked for the left eye. So make sure we have replace -0.05. We can go to our eye, making sure that the shock shape is selected, and start painting. And notice that's going to bring us back to our default shape and nothing past that. Okay, so we can just remove the influence here. Now watch what happens if we go back, just go into our select tool. Now we have a pretty fun looking shape for our object. So this is a type of fun effect we can get with painting our blend shapes. Now there is also a way to mirror blend shapes over. We wouldn't be able to necessarily do that from using that tool, but we go over that in our cartoon character rigging kit. Okay, how to use Maya's tools effectively to accomplish that. But if you're also interested in more blend shape information, we have our quadruped rigging kit, as well as our facial rigging and even vehicle rigging. Some fun things we do with blend shapes in that too. But that's our blend shape options that we're going to go through in this training, and we have gone through a lot of information for them. So I'd recommend you really experimenting with the tools that we've gone through on your own characters and see what type of fun effects that you can come up with. But now that our blend shape lesson is complete, our next task is to go through some of Maya's other deformers and see what type of effects we can use with them. Let's take a look at Maya's cluster deformer. The cluster deformer allows us to take a selected amount of vertices and incorporate them into one node so that we can transform that node and even animate on it. So we could get into some fun effects with it. What we're going to be using it for in this lesson is to create a character's blink. So we're going to get into not only creating the cluster and things we want to be very mindful of when making the cluster, but we'll also see how we can paint weights on the vertices of that cluster to get in an improved blink effect. So we'll just add it to the top lid here. What we want to do to start out with is go ahead and select our mesh and go to our paint selection tool. That should send us to our component mode, selecting our vertices. And we'll just go ahead and use the paint select tool to grab a number of our vertices here. And once we've gotten a good selection, we can go to our selection tool and go to our wireframe mode and just make sure we haven't grabbed any vertices that we do not want to add to our selection. Okay, so we'll decrease some of these to the side, and we'll also make sure that we have selected what we would like to have selected. Alright, this looks pretty good. Okay, so we could also make sure that there's no other vertices selected in the back or anywhere else in the head. And what I like to do is use the move tool, go into that just to make sure that my selection has been centered to where I have specified. Great. So once we made sure of that, we're ready to make our cluster. So let's go ahead and do that. What we want to do is go up to Create Deformers and go down to Cluster. And let's go to the option box and we'll reset our settings. The only setting that we really want to be mindful of here is making sure that relative is going to be checked on. So let's do that. The reason why is when we go to parent this cluster to our head control so that it will move around, if relative's checked off, Maya is going to also look at the transform effects that are being caused from our head control to our cluster, and then we're going to get an additive result with our vertices as we move our head control around. So relative, having that checked on, that's going to give us complete control over our cluster. So once we made sure that relative has been checked on, and before we even do that, let me go ahead and even grab one more vertex in our selection, okay, just to make sure that we have a good amount selected. Okay, so once we've made sure that relative is checked on and that we've grabbed all of the vertices that we'd like to add as a cluster, we'll go ahead and hit create. Now notice a cluster has been made. So let's hit F8 to go back to object mode, and we'll also open up our outliner so we can see where the cluster lies right within our scene. And if we were to go to our move tool with the cluster still selected, notice we're going to be able to control these vertices. Now a couple of problems here. One, all of those vertices have a weighting of 1. So notice that's not looking like a good blink at all. We're going to need to adjust their weighting so that we get a better blink effect. Okay, and also notice that the cluster, what's convenient is that it gives us a 0 value within our transform, so we could quickly get back to the default position the cluster was created in. Let's give it a name. We'll call it CL underscore R underscore I01 to stay organized, and we're also going to want to make sure that it follows along with our head control. So we can go ahead and shift select our head control with the cluster still selected and hit P. And now it does say that the cluster has been grouped to preserve its position. So that's essentially what this group is for. So we want to be mindful of that and even label the group so we know what it's for, especially when dealing with a lot of clusters within our scene. So with the group there, we can hit F in our outliner, making sure our mouse is we mouse over our outliner so we can quickly find the group. We'll give it a label. We can call this the GRP underscore and the cluster's name, CL underscore R underscore I01, and hit enter. Alright, so now that that's labeled, if we select our head control, move it around, we should be able to comfortably move our cluster. Okay, great, being that it's set to relative. Now what we're going to do is go to our cluster. Let's open up its group, get to the cluster, because we can't move the cluster by going to the group. It has to be from the cluster itself. So let's make sure that's selected, and we're going to adjust its pivot so that we could get a really nice looking blink. So what we'll do is just go to our perspective or 4-panel views, go to our side view, hit 4 to go into wireframe. And with it selected, we'll hit insert on our keyboard, making sure we were first in our move tool so we can see our pivot. And we will move its pivot so it's about behind the eye, just so we can correct its orientation when we go to rotate our cluster. So now if we hit insert again and we go to our perspective view, notice what's going to happen if we now go to our rotate tool, hitting E on the keyboard, go to our rotate X and move that. Now we're going to get a much better blink effect. So now all we need to do is start painting weights on our vertices. So we can do that a number of ways. We can either do that from the component editor, okay, first selecting the verts, going to window, going to general editors, and going to the component editor. From there we'd want to make sure we're under our weighted deformers tab, right before the rigid skin tab and right after advanced polygons. So you'd want to do your fine tweaks from the component editor. We could do that here. Or we can just start painting weights on our vertices and see generally how the weighting looks on our selected clusters. So with our geometry selected, let's go to edit deformers and go down to paint cluster weights, and we'll go to the option box. Alright, so now we're having a full amount of weighting. We can see that, okay, and we want to view this in our shaded view. If we try to go to our wireframe, it's going to be difficult to see, or won't really be able to see our weighting at all. So let's make sure we're in our solid view, and then we'll reset our settings from the tool and go ahead and start decreasing the weight that we have for some of our vertices. We could even set up an animation so that we can have a blink. So that might be a more preferable. So we'll go back to our perspective and outliner view, and quickly just go back to our channel box and come out of our weight tool, just so we can add a quick animation to this cluster so we can see its deformation, and so we can see what vertices we'd like to take weight off of or add weight to. So on frame 1 with our cluster selected, we'll go to our rotation X, key selected, and about frame 12, let's go ahead and rotate the cluster down to about, let's say, 18 to round this off. Okay, so that looks pretty good. So from here we could just go to key selected, right click, and go to key selected. Alright, so now we're having a blink effect. So let's go ahead and select our character again and go back to our paint cluster weights tool. We'll decrease our brush size. Okay, and then we'll also just double click on the tool and zoom in and start painting weights. So let's go to about frame 8 or so we can see these vertices on the outside and just take off some of their weight. So what we can do from here is just go to add. We'll also bring our min size to -1, and we'll use add to start removing some of the weights and give us a small value here. Let's see what -0.03 does for us. So we'll just click once on our vertice to see what type of effect that gives us. Alright, so this is going to be nice for doing some subtle fixes using that low amount. So we could keep bringing that up to a good height and just keep clicking on our vertices so we can bring those up and get a nice fall off effect. Maybe even bring this one up a little bit higher. Okay, sometimes this could be really time intensive, but the time you take to do this process is can be very rewarding in the end. Okay, that's why we really need to know the tools that we're using before getting into them, so we can use them as efficiently as possible. We could probably go ahead and decrease, or decrease its value somewhere to about -0.05 to see what that does. Alright, so that's better. Alright, great. So from here, if we scrub now, we can see, alright, we're getting a nice fall off effect from these upper vertices. Okay, maybe we could adjust them a little bit more to get an even better look. Scrubbing back and forth. Great. So from here, we can go to our next row and start removing some of the weight there, and even go to a later frame. Okay, I'm not going to get too far into this, but I'm just showing you what type of cool effect you can do with clusters. And we do go over the use of clusters and our facial rigging, as well as our cartoon vehicle rigging. And the principles taught in cartoon vehicle rigging are not only applied to a vehicle, you can also use them for characters. Okay, so that's just FYI. So let's go ahead and continue scrubbing. Alright, notice how much better our blink is looking from the tweaks that we've made. Can add a few more adjustments to this. And scrub. Alright, great. So I'm just going to stop here with the cluster. Okay, and then we can go back to our channel box view to see a wider display and just focus in on our perspective. So now what we get is our eye blinking. And if we wanted to, we could set up a control that controls by a set-driven key our eyes blinking from this cluster. So if we took our head control even and rotated that, what we should see as we move our cluster is that our eye would continue to blink. Very cool. Excellent. Well, that is our cluster lesson. In the next lesson, we're going to look at another one of Maya's deformers that allow us to add a follow-through effect on its components. In this lesson, we'll look at another deformer that allows us to add an automatic follow-through effect on our objects. The deformer I'm referring to is called the jiggle deformer. Now what's cool about this is that we can add a jiggle effect onto all of our objects, or to the entire mesh of our object, or we can tell Maya what vertices we'd like to add the jiggle to, and this works out great for doing jiggles for calf muscles or even arm muscles, for example, and things of that nature. Or we can add a jiggle to a NURBS curve, which is what we have here. This is our grappling hook from the lesson where we've set up the spline IK. I've gone ahead and hid the joints as well as the IK since we don't need to focus on that right now. I've also animated the grappling hook so we can see what type of effect we want to get. So it's basically hitting this wall here. And we're going to apply the jiggle deformer not onto our entire NURBS curve. If we were to go ahead and go to our layers and just turn off the visibility of our grappling hook by clicking the V to uncheck that, we can see, alright, we're not going to apply the jiggle onto the whole curve, otherwise the whole thing's going to shake. But Maya again will allow us to apply the jiggle onto selected control vertices. So that's what we're going to be doing. So with our NURBS curve selected, okay, go into frame 1, we can hit F8 to go into component mode, and let's select the two vertices that we see, okay, in the center. Alright, these two. And if you can't see them, just right click and make sure you're in control vertex mode. Now once they are selected, we're ready to add the jiggle deformer. So we'll go to create deformers and we'll go to jiggle deformer options. And you can just make sure that your settings are set to default. So here's our default settings for this tool. Now what stiffness does, that controls the rigidity of our jiggle. So the greater the number, or the greater the value, the more rigid our effect is for the jiggle, and vice versa, or basically the opposite effect will occur if we put in a lower number. Okay, so you might want to experiment with that. For an organic character, a lower stiffness might be the best solution, but I would experiment with that once we're finished with this lesson. Dampening, what that is going to do is either make our jiggle more resistant upon increasing our value, or less resistant upon decreasing our value. So if you would like a smoother effect, you can also decrease this number very slightly. The weight controls the intensity of the jiggle, and when we get down here to jiggle only when object stops, this does just as it says. It's going to jiggle only after the object has come to a stop. And so depending on whether we check this on and off, activates or deactivates that, and we'll explore this option. And the next option we have is to ignore transform. What this does, let's say we were working on an animation where a character was jumping and talking at the same time. What we can do is turn on ignore transform, and Maya will look at the animated vertices that make the character talk and add the jiggle to those vertices, but it will not look at our translate, rotate, or any of our other transforms that are a part of our character jumping. So that's what that does. So with our settings set, let's go ahead and just hit create and see what happens. Now we get a jiggle deformer, okay, called jiggle1, and also a jiggle cache, which basically shows us our jiggle name. But let's go to our jiggle deformer. We have several options here. Envelope, that's the intensity of our jiggle. Enable, this is what happens when we just use our default jiggle without checking on enable only after our object stops. So let's see what type of result we get with this. If we go ahead and check this on, our visibility for our grappling hook, and hit play, let's see what the jiggle does to our object. Whoa, notice how intense the jiggle is. Wow, it's really, our jiggle is really warping our mesh. So we're going to want to change some of our settings. But let's see what happens when we check on enable only after the object stops. So just holding down enable, the enable attribute, we can get to enable when object stops. So we can hit play, and now nothing really occurs until our jiggle object stops. And we are getting some major and majorly intense results as we check out what our jiggle is doing. But notice, if we started over our animation and hit play, we can see that we get a less intense effect when we have enable only after object stops. So you want to make sure you cycle your animation over again back from its start in order to check out the effect for enable when object stops. And disable will disable our jiggle. So if we start back over, our jiggle will be disabled. So what we're going to do is just leave it at enable, okay, right now, just to see what happens when we decrease the weighting of these vertices. But let's go ahead and work our way down the list here. So ignore transform, we have discussed that. Force along normal, that is going to tell Maya how much of an intensity we'd like to have our jiggle move along the object's normals. And the same thing applies for tangents, force along tangent. Motion multiplier, this is for when we have our setting set to enable only after object stops. What that's going to do is tell Maya, okay, after the object stops, how intense would you like the jiggle? Would you like it great, or we could lower this number for a lesser effect? And we know what stiffness does in dampening. What I'd like to do is take dampening down to about 0.3. Okay, and we can notice the effect. It's still going to be kind of abrupt, but that's going to help us to achieve a nicer result. So we'll leave dampening set to 0.3. The jiggle weight, that's going to control our global intensity of our weight. So if we brought this down to 0.9, watch what's going to happen when we hit play. Alright, notice now our jiggle is going to have a lesser intense effect, and it actually is looking pretty good. So we can leave our jiggle weight at about 0.9, our global jiggle weight, and then we'll see a way we can go in and modify these individually. Our direction bias, this tells Maya what direction we like to jiggle in, either going along our normals by putting in a positive value, or going into the negative value, like a -1 for example, will cause the jiggle to move opposite or away from the normals of this object, in this case which is our NURBS curve. So that's essentially what these options do for us. Now, if we have left our jiggle weight to a value of 1, we'd notice that our jiggle would keep going on and on and on. So if you would like to just have it stop after a while, then you can lower this jiggle weight number. So even if we had our weighting of our vertices set to a value of 1 for our jiggle, you'd probably want to crank that down to at least 0.9 as the max, so you can get your object stopping after a while rather than continuously going on. So now that that's done, we'll explore a way we can now decrease the weighting of our verts individually. Now, if you are working with a polygon character, okay, or you've applied the jiggle weights on a character, you can go to the Edit Deformer and Paint Jiggle Weights tool, and it's very similar to the tool we've used for painting other objects. So you could use that for characters to get some more finer results. But since we only have 2 vertices to work with, let's go ahead and look at another solution, and that's going right back to our component editor. So once there, we'll make sure that we're under our Weighted Deformers tab. And here we see our weighted deformer for our cluster, and we have it for our jiggle. So here's where we're going to focus on. So let's say we took the vertice for our first vert here, actually our second to last in the chain. Let's say we took that and gave it a weight of about 0.8, since it's close to the base of our grappling hook. And then we took our other vertice, finding it, and we brought this to a weight of about 0.9 since it's more closer to the middle, and that's going to shake a little bit more. Let's see what type of effects we get now. If we minimize our component editor, start back the animation from the beginning, and hit play. Alright, excellent. Notice how much better our jiggle is starting to look. Okay, and it still gets a little bit intense. It also depends on the timing involved for the jiggle as well. So if your object is moving pretty quickly, you want to be mindful of the intensity you give the jiggle, because that is going to take into effect. Well, let's go ahead and play with a few more of our settings. We'll just go back to our jiggle inputs. We could even select one of our control vertices. And let's say we switch enable to enable only after object stops to see what happens now. So we'll start over and hit play. And notice how much better the jiggle looks from this setting. And of course, we're going to get a more randomized result until we were to, let's say, render the scene, and then we'd get to see the real effect that the jiggle is having on our objects. But with that discussed, that is a way we can apply our jiggle object or jiggle tool onto our objects, and the benefit of doing that. So you could get to some fun effects with this, and I would again experiment with this some more to see what type of scenarios you can come up with for this tool. But with this now done, that finishes this lesson, and we've went through a ton of information throughout this kit as far as not only the deformers we can use for our characters and other props that we may rig, but also how to set up bone structures, how to use constraints, how to make control objects for the animator's convenience, and so on. So we went through a ton of material that I would recommend you go back over and just experiment with and really use to get comfortable with the tools that Maya has at your disposal to really become a strong rigging artist. And that brings us to the end of Introduction to Rigging in Maya. Over the course of the last few hours, we learned a great deal about rigging and how to utilize the rigging tools available in Maya for a multitude of creative projects. Together, we learned how to gain the most control using flexible rigging workflows. We also learned the essentials to proper character setup and rigging props for easier animation, and ultimately building a solid foundation to later build upon. To continue your education, I'd encourage you to check out the hundreds of free tutorials we offer online at digitaltutors.com, and please check back often as we're always adding new lessons daily. Also on our website, you'll find additional rigging training that directly complement the one you've just viewed, as well as an entire library of training products covering the different aspects of 3D production that are currently being used by students, schools, professionals, and studios around the world. In this lesson, we'll learn how to set up a proxy cage for our bound objects. Proxy cages, or low-res objects, allow us to very quickly animate within our scene. Now, this is great especially for when we're working with characters that have been smoothed out, that have a smooth node attached to them. If you notice, as you animate with them, or as you move your controls around, your scene may tend to lag. So the proxy cage is going to be very cool for quickly getting in and working on animation while still being able to see how your high res is going to look just from looking at that proxy mesh. So let's go ahead and work on setting this up for this very simple rig we have, so we can get an idea of how to do this for the remainder of our characters. What we first want to do is go ahead and select our mesh. Notice how it is bound. So we simply want to hit Control D to duplicate it, okay? And then from there, we'll take the duplicated mesh that is selected. We can see that from the outliner as well. It's underneath our main group. With it duplicated, we then can go ahead and unlock all of our attributes because it no longer has its bind information. So if we right click and go to unlock, okay, now it is able to move around and such. So once we have this, now we are ready to basically work on extracting our geometry that we're going to use for our proxy cage. So let's go ahead and do that with our proxy mesh selected. And if you would like, you can go to the model and just hide that. Go to its visibility and hide it. So we're just viewing our proxy cage. With that selected, we'll hit F8 to go into component mode, and we'll right click and switch to faces. So right click and hold and select faces. So we can go ahead and detach the faces that we'd like to separate. So this is basically going off of where our bones lie. If we go to X-ray, you can see, alright, I'm going to want the proxy cage to be split at around this area so that the deformations will be accurate, or the movement of the proxy cage will be very similar to what we'd have for our bound mesh. So if we go ahead and select these faces, let's do that, making sure that we have all of them selected. I'll go ahead and turn off X-ray here, and also go to a side view just to make sure that we have all of the faces we need in our selection, as well as faces we don't need. So we could go ahead and deselect these other faces, but again, we'll just hold Control Shift and just make sure we grab all the faces we need in our selection for the chest, and again, deselect any that we don't. So once we've double checked that, we're now ready to extract our geometry. So what we do from here, holding the hot box, is first make sure that under Edit Mesh we have Keep Faces Together checked on. Otherwise, when we go to extract our geometry, what's going to happen is we're going to have to reparent all of those separate individual faces that come along with it. So just make sure that Keep Faces is checked on. Just select over it. Now that that's done, we could go back to our hotbox holding the spacebar and go to Mesh and go to Extract. And here is something very important we want to check. Make sure Separate Extracted Faces is checked on so we can have our geometry be two separate pieces. So from there, once that's done, we can simply, once this is checked on, we can hit Extract. And notice now, let's go ahead and hit F8 to come out of component mode. And notice now, we have two separate pieces of geometry to work with. So what can we do with this? Now all we can do is parent these pieces to our bones, and that's going to allow us to really quickly get some an appearance of how our mesh is deforming. Okay, as well as allowing us to save a lot of time, because what we're going to do is actually hide that bound mesh. So we can view this in the outliner to see what we're working with. Right now we have this top node that has both of them selected, but with that top node selected, if we open that up, we could get to our separated pieces. So what I like to do is go ahead and take this top node, go up to Edit, and just select Ungroup, so we could just have these pieces to work with. Notice it also gives us a transform node that we could just delete. Alright, excellent. So we're just about done. We could even go to this the top node that was once there and delete that as well. We no longer need that since our objects are ungrouped. But once that has been done, from here we could go ahead and work on parenting these objects now to our bones. So our polysurface 1, with that selected, we can shift select our bone and hit P. And with our polysurface 2, let's go ahead and go to wireframe mode. With that selected, we can shift select our lower bone and hit P, since that is associated with that bone. So what does this give us now? Well, if we were to go to a shaded view and scrub the timeline, notice that we have this animation here. So notice it's going to be following just as our mesh, our bound mesh follows as well. If we were to go ahead and bring that back, we can simply select these two pieces of geometry, hide them, go back to our bound mesh and view that, and now notice, alright, so this gives us somewhat of a representation of what we'd see with our bound object. So this is very cool. But I'm just going to go ahead and undo back so we can get to finishing the setup of these proxy objects. So from here we could give them names. We can call them PRX for proxy so we know what they are, and this is for the chest, 01. And the lower piece we could call that PRX underscore back, 01. So we know what that is associated with. Alright, great. So what can we do from here? Well, we could take what would be our global control in our scene that controls everything and basically set up a visibility switch on it that would allow us to switch between the viewing of either our bound mesh or our proxy objects. So let's go ahead and set that up. What we could do from here is, with our circle selected, go to Modify and go down to add attribute. From here, we can give it a name. We can call it, for a category name, we could call this our divisions or level. So let's even go at level. So we know that when we're at our bound level, we know what we'll see, and when we're at our proxy level, we know what we'll see. So we could simply hit add to add that. And now, underneath this, we can have another attribute that will actually allow us to switch between. So this, let's go ahead and call this our mode. Okay, and we'll make it keyable, and we'll also make it an enum. So once we've made it an enum, now we could go down here and just switch these names out. So we know that instead of green, let's call this bound. And we'll hit enter. And then instead of blue, let's go ahead and call this proxy. So we know what needs to be associated with it. And we can simply hit OK after that. So now we have this drop down or enumerated list that we can go through to set up a set driven key between the visibility of our proxy objects and our bound mesh. So let's go ahead and establish that. With our global control selected, we'll go up to animate, go down to set driven key, set options, and load this as the driver object since it has the driver attribute that we would like to work with. Now for our visibility, we could work with our proxy since it's what we're viewing right now. With both of our objects selected, we'll we'll click the driven and select both objects within our set driven key and select the visibility. So we know that right now we're viewing our proxy. So let's say we go to our global control, switch our mode to proxy, and with visibility selected for both of our proxy meshes, and with mode selected, we can now hit key selected. Great. So from here, we could go to our global control again and switch proxy now to bound. Then go back to our objects, go to the visibility for them, and go ahead and switch our visibility to 0. From there, we can hit key selected. So watch what happens. When we're at bound, nothing. But as we go to proxy, notice we're able to view our proxy cage. So now we just need to add our bound mesh. Let's go ahead and select that and add that to the driven and set up the relationship with it. So we'll select visibility for it. Notice nothing else is visible because this is the only attribute we can key. So we'll select mode, make sure mode is at bound, and we'll go to our torso and just put in a value of 1 for our visibility so we can see it, and press key selected once we made sure we have the right attribute selected. Then we could go back to our global control, go to our proxy, and now go to our model and put in a value of 0 to hide it. Then hit key selected again. So what does this do for us? Well, right now, if we were to scrub, we can see we're in proxy mode. But watch what happens if we select our control and this time go to bound. Notice the visibility switch, and now we can see our bound mesh. So that is how we can set up a proxy cage for our characters. And again, the animators are really going to enjoy that because they can go ahead and switch to a low-res state or a low-res form of the character, but still be able to see or get an idea of how the object is going to deform by what we have currently set up. Well, with this said and done, that is the lesson. In this lesson, we'll learn of some techniques we can use for applying a jiggle deformer onto a character. What we'll be doing in this lesson is taking Claire and basically adding the jiggle deformer onto her chest. Now, this is not meant to be offensive at all. What we're doing is seeing how the jiggle deformer can be used to simulate a soft tissue effect very easily for us. So let's get right into the lesson. What we'll first do is make sure that we select the amount of vertices that we're going to need, because we don't want to add the jiggle to all of our geometry, just to a specific amount of vertices, which really makes the jiggle deformer a very powerful and very handy tool. So with Claire selected, let's go ahead and go to our 4-panel views and go into our side view. From here, we could just go into component mode and go to our lasso select tool and select the vertices that we would like to apply the jiggle deformer to. So that's all of these vertices here, okay, following my mouse cursor. And from there we could go into our perspective view and work on applying the jiggle deformer. So we can go up to create deformers and go down to jiggle deformer and go to its option box. And initially, let's go ahead and use the default settings to see what we come up with. So we'll just hit create. Now, if we go ahead and come out of component mode, back into object mode, you'll see that we do have animation on Claire just to see the jiggle deformer modifications that are being made to our mesh. So if we were to go ahead and hit play, as is, okay, notice the abrupt type of motion we're getting. Well, we're going to need to adjust a few of our settings. So let's get right into doing just that from our global settings, and then we'll need to go in and adjust a few of our vert manually. So what I like to use here is go ahead and change enable to enable only after object stops. So what that's going to do for us, if we go ahead now and hit play, it's just going to give us a little bit better effect from doing so. Okay, great. So now that that's done, we can bring our stiffness down to, let's say, about 0.2, okay, to modify that, as well as our damping. Let's see what type of effects we get when we do that. Alright, notice now we're starting to get a much better effect just from taking those two values down. Okay, now we're getting a much more nicer motion and a nicer soft tissue effect. Okay, so we just have a few more settings to adjust. If we want to, we can go to our jiggle and bring that down to about a value of 0.9 for its global weight. So let's see what type of effect this gives us when we hit play. Alright, so this is starting to look better already. So from here, let's go ahead now and start manually adjusting our vertices. So what we could do is take the ones on the outer perimeter and give them a lower weight and just continue on until we get to about this point where we have our edge loops going around the chest that is going to have a more jiggle effect. So from there we'll be able to leave our weighting at the same value that it's currently at. But once we get in and tweak, we'll go ahead and see what type of settings will work best for this situation. So we'll hit F8 to go back to component mode, and we'll start by selecting again these outer vertices. Okay, again following the selection that I'm making in Maya. So we'll go ahead and grab all of these in our selection. From there, we can also do the same thing for the right side, grabbing those vertices on the outer perimeter. Okay. Excellent. So once we have these selected, we could go this time to the component editor and make sure that we're under our weighted deformers. So from there, let's go ahead and set our weighting on these outer vertices to be about 0.7, since they shouldn't move as much. So once that's done, if we were to minimize our component editor and play our animation again, we should see the change. If we hit play, now those other areas aren't jiggling as much. Okay, so we're getting a better effect. Great. Now we could go back to our object and do another pass where we take the vertices that are basically around the next perimeter and just set their weighting a little bit lower. Okay, so we'll go ahead and do that. Oh, and careful to not select the model itself so we don't deselect anything, but just to go through and select the vertices that we have not added any real weighting effects to yet. Alright, so with all of these selected, let's go ahead now and go back to our component editor. And we see here that we may have grabbed one that already has been affected, but for the others, we'll just go ahead and select those, okay, and give them a weighting of about 0.8, and do the same for the others, 0.8. Alright, great. And one thing we also want to be mindful of is the vertex in the center. We just want to make sure that would be set to about 0.7 as well, because that shouldn't move as much at all. Alright, great. Now for the remainder of our vertices, let's go ahead and see how they're looking with the adjustments that we've just made. So we will go ahead and go back to object mode. We can minimize our component editor and again hit play to see what we have now come up with as a result. And notice now our weighting is much better. Okay, so we're getting a really nice effect now from our model from just those simple adjustments that we've made. Now again, we'll see that our effects here are rather random in Maya, but once we go to render our effects, we'll be able to see a much more accurate view of how Maya is simulating this effect. So if you like, you could go to the other vertices and adjust those as well, but these are pretty nice settings to get a basic loose tissue type of effect for your models. So with that said and done, that is the lesson. In this bonus lesson, we'll take a look at Maya's Wrap Deformer tool. We kind of get an idea of what the tool does by listening to its name. It basically will take a shape of one object and have it drive another object. So this is very cool for, let's say, also working with proxy objects. Let's say if we didn't want to cut up our polygon cage as what we discussed in the previous bonus lesson. Let's say if we wanted to also have our mesh bound. Well, what we could do is bind a low-res version of our mesh and have that drive the high-res version. So let's go ahead and explore how we can do just that. What we have here in the scene is a low-res hand and a quick animation where the hand is just curling in. Now what we're going to be doing is taking that low-res hand and have it drive. If we switch our layers, okay, to now viewing just the high-res, we're going to have that drive our high-res hand. So let's go ahead and set that up. We first will select the high-res hand, then we can hide its layer, it's still selected, and we'll just now show the low-res hand and shift select that. Once we have done this in this order, we will now go ahead and go back to the visibility of our high-res hand. So we basically select the object to be influence followed by the influence object. With that now selected, we can go up to Create Deformers and go to our Wrapped or Wrap option box. Now let's go ahead and reset our settings. What Exclusive Bind is a new feature in this tool that allows us to have a rigid bind effect on our points. So it's basically going to go point to point and match up with our geometry as close as it can. So let's see what this effect does. What Weight Threshold will allow us to do is increase the threshold of basically the influence of our object. So increasing this will give us a more accurate result for our high-res object or whichever object we'd like to be influenced. The max distance, it looks at the area of our Wrap Deformer, also trying to align up our influence object with the object being influenced as close as it can. Now the influence type, we could set that to points. If we had more points here, we can go ahead and set that using that option and possibly get a really nice effect doing that. Or we could use faces and have Maya basically go off of the faces of the object. So whichever would work best in the situation. But what we're going to do is use these options that we have here. So we'll just hit Create and notice what happens. As we scrub the timeline, notice now that low-res object is driving the mesh of the high-res. So what can we do with this? Well, again, we could have a low-res mesh driving the high-res and then afterwards hide that low-res object and it'll appear as if the high-res is being driven very nicely. So we can see the benefit of really utilizing this tool. And it does have a few more options. If we were to go to Edit Deformers, we can, under Wrap, either add an influence object, so we can do that, or remove influence objects. But again, we have just checked out the Wrap Deformer tool and what a great advantage it can have in the rigging process.